everyone. I welcome you all to the live session on full course on DevOps tools by Intellipaat. This session is a must-watch session for everyone who wishes to learn DevOps and make a career in it. This session is taken by multiple experts who will be teaching you everything about DevOps and its tools from basics to advanced level. Before we begin the session, make sure to hit the subscribe button and also like our videos so that it will motivate us to come up with more such interesting live sessions. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to DevOps. In that, we will tell you what is DevOps, why one has to learn it, and why is it so important. Then after that, we will introduce you to all the DevOps tools like Git, Maven, Jenkins, Docker, Puppet, Ansible, Kubernetes, and Nagios, along with hands-on demo for each and every tool. And then finally, we have also covered DevOps interview questions and answers as well. So this is the agenda of the video. This session is going to be very interesting. So stay tuned and watch the video till the end.
In any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team and the second team is called the operations team. Right? Now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operations system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious. It ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps. Right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking. And this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? Then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps, we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles and hence releases software in even lesser days than or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities, and if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you're operating the software or you release the software for internal employees to see whether the traffic, when is it doing good when it holds when it's getting traffic onto it. Is it doing good when normal people are doing arbitrary tasks on your software? And then you are also continuously monitoring it to see if your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase. which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys, is by automating this life cycle. Basically that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay. So the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server. And this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version controls, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server, now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now, the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates, the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a life cycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system, it is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay, so let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration, it is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now if you want to test your application on that system, what you have to do is, you first have to install all the softwares on it, right? For example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python. All these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto a version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let us get introduced to Git, but before that, let us understand why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git, right? So let me just compare it on Google Trends, and this is the result that I get. Right? So if I search for Git, Perforce, and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce, because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course, and that is the reason we are learning Git also today. All right. So moving forward, now let us see what Git is exactly. Right? So Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now in case of remote repository, you get a lot of options, guys, but in our course, what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub, but for now we are going to just focus on Git. First we're going to understand what Git is, and then probably later we'll see how we can use GitHub in conjunction with Git. All right. Our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git? We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically, we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay. So let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is, let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano. Let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have 2 files which are there inside a folder DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now for making it a Git initialized working directory, all I have to do is type in git init and hit enter. Okay, and now we have a initialized Git repository in front of us. Okay, so This is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository, and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I'll do is I'll just type in git status, and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding, right? So basically we have made some changes to our file, and now we want to add it into a repository. And for doing that, all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files. So say I want to track both the files. So I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter, and now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now, right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it, right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1 to over here. Let us save it, and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file, and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of git. Now if I want the 2.txt file to be saved, I have to stage it again and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our ppt now and let's go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a git repository. Okay, so let me just jump on to my browser and then I'll show you how you can create a git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side you will see a button called new repository. Just click on that, right? And now let's name our repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is DevOps course and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this git repository, my command line that is working on my git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are two files which have not been added. So what I'll do is let me first make or let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged, right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file and all I have to do is git commit, and now I'll specify the message as modified 2.txt. Okay, so this is the message that I'm passing. I'll hit enter and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added .2.txt. It still says hello from Intellipaat and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It'll ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third file as well, which is the 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now and let's check whether this is a step I've already done. So basically you can see that I have now synced my local to my remote repository. I have as you can see in the browser. Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone and I'll give the URL and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied, or my repository has been copied to my local. Okay, and the awesome thing about this is, now if I go inside DevOps course, the directory, now over here I don't have to basically add a remote origin, right? Because you have cloned the repository, so this directory automatically knows where, if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do git push origin master. I'll give the username, I'll give the password, and as you can see, my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello, and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt. Let me add any arbitrary text into it. Now if I do a git add dot, and if I do a git commit, and I'll say let's adding file, Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say, let me first uh, pull everything. Okay, so because the git pull origin master. Okay, 1 second, guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps and let me just create, or let me just say git pull origin master. So this was the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it. And if over here you can see I have not specified what origin is, it automatically knows what origin is. Why? Because DevOps is a git initialized repository. Okay, similarly, when I said that hello is a git initialized repository, but in hello I'll have to specify what is the origin of that repository, right? But if I do a git clone, as I did in test, right, I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull, files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session. All right, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file, and now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now the files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay. uh, Moving forward, now let's talk about branches. Now as you can see, now we are talking about parallel development. Okay. And as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in git. So for creating a branch in git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch, and say I create the branch feature 1. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are two branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature 1. Now if I want to delete a branch, again all I have to do is git branch -d and then feature 1. Okay, so it says deleted branch feature 1. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again: git branch feature 1. So I have created a branch, and what happens when you're branching? Basically the last commit of your master becomes the first commit of your feature branch. Whatever you have created, whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature 1, so basically now I have switched to the branch feature 1, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch. My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my master branch. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature 1. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, all right, great. Now if I do a git status here, git status, one second, git status. It says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1, nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. And it'll ask me the password. I'll put that and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature 1 listed over here. I'll click on that and now I can see that the 6.txt file is visible here and with my commit message which was added to feature branch. Okay, so I can again switch to my master branch and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository, like what all have you done on your repository. Okay, now to see the history of a repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits. Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added. Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything. I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay. Now, if I want to see the history of master, this is the history of feature 1. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature 1. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you are on. Okay, so right now I'm on the master branch and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch. Those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay. So, but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. All right. So I hope this is clear. All right. Coming back to our slides, guys. So we now know how to see the history of our our Git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file. The file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us create let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature one branch, and let me create a file called 7.txt. Let me name it as stash file check. Okay, so I have created a file, but this file is still not staged. It is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now, if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature one. Okay, and let me go to 5.txt. So this is my 5.txt, and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it. Okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here, because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is it's not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch, in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is, you would just check out, or you would just check out to your feature branch where actually you want this file to belong. Okay, and it tells you that these two files are there, which this has been modified and this has been added. Okay, so it gives you a notification, which is good. Now what you'll do is you'll say git stash. You'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master. Okay, and if I do an ls, I can see the 7.txt file is no longer visible over here. Okay, and also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now, say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature 1. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git stash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean, and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there, which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches, and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of git. So let us come back to our terminal. Okay, so what I want to go do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made, on which the head is right now, is this commit where we added these stashed changes. So this caused a problem in my code, and I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls, and I can see that I have 7.txt which I added in my stash changes, right? So what I'll do is I'll just do a git revert, and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this. So I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature one branch. It committed a new file on my feature one branch with the message revert of committing staged stashed changes, right? And it says this revert commits 9A6090. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit id, and now I'll type in git checkout and then the commit id. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, right? Now what I want to see is what all things did we modify. I think we modified 5.txt. So let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which I do, if I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature one, so it will again return to the latest commit on my feature one branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is, I changed file in my commit of stash changes, that is, I changed the file content to test file 12, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I don't no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want, you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit, which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits? What are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash, so we can do that. Let us see how we can do that. So I'll type in git diff. Okay, git diff, and then I'll type in this commit id, which is my head right now, and this commit id, which was which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, which what content was changed and what content was added, right? So if I am comparing the head with my previous commit, it says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature one branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a git, I'll do a nano 4.txt and let me change the file content to test file for diff. I'll save it. Okay, sorry. So, all right. So let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I do an ls. So now my 4.txt file has changed, and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current? So current in my current directory, I have not committed, or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter, and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now.
So, what is a version control system? Has someone already used? I think there are some what do you call developers in here. So, a version control system, in a simplified way, we can call it as a software which is going to help you track each and every change on your organization level in a central location. So, yes, these are category of softwares which are specifically dealing with the tracking the changes to a source code. So, the first, let's couple of see what you call a couple of basic terminologies. What is source code? Source code is nothing but any information we write or any programming we are going to write, right? Obviously, we are going to write in what? In a text file. A source code is only going to be called as a anything which is written in a text file and which can be readable. So your binary files, your zip files, your jar files are not called as a source code. A source code is always going to be a plain text information which is going to be saved with that specific programming language extension and which can be open and read by humans. Okay. So the version control system tools are specifically going to deal with the source code only. You can't ask it to start tracking .exe file or .zip file or .tar file or something. It is not going to understand. A version control system category of software only understand source code files, which are means nothing but your text files. Okay, so these are nothing but they manage or record or track changes to your source code over the period of time. Okay, and it is also going to help us do a lot more than that, but helping us record each and every change done by a team in an organization in a centralized location is something you can call, which is called as a version control system software. So before version control system, how people used to do. Okay, so this is a very simple example. I'll not go very deep into it because the version control systems tools are being used from very long time, guys. Okay, it's not something new or something which is very what do you call, which is a latest one. People are using version control systems from very long time. Okay, so when you initially talk about version control system, without version control system, for example, I have a developer A, he has developed a software and he has released that software to the market because he set up a small startup and he has a release that software to the market. Now once you start a company, you need to increase the number of releases. So what this guy has done, he has had three more developers, the developer B, developer C, and developer D. So I have now three more developers. And whenever you are given a task of working on any code, that can be Ansible or your shell script, even the most basics also, what are you going to do? The first thing is, first you ask the person where is the current copy of the code, right? That's a simple question you ask. If I ask you to update a shell script, if you don't know the location of the code, you can't do anything. So, and you also need to know the latest code. You can't see 1 year back or 2 years back of version of the code, right? You ask what is the latest code. That's the same question all these developers are going to ask the developer A. So developer is going to give the developer A will give the same code to all the three people now. So they will start working on their given activity. Now, once developer B has done his activity and is going to send that code to the developer A. Now developer A will take that code and he will add that code on top of the version 1 code, and he will then release to the market. So here developer A is doing that hard work of taking his changes and applying the changes on top of the version 1 code. Now the version 2 code has been released to the market. Now developer C has done his work, and you can think it as version 3. Now again the developer A, here if you see, the developer C has applied his changes on version 1 because it did not have version 2 with him. So again it is a headache of this developer to understand what are the differences and apply those changes on the version on top of the version 2 and again release it. So this makes us what need dedicated people only to handle the version. And another problem is, whenever you open a notepad file in your machine, you in your workstation, you update a notepad file, you save it, that's all. There is no control Z. The control Z will only work until you close the file. Once the file is closed, there is no control Z. Whatever the contents are saved in that file, they are going to be permanent. It means that there is no way for you to go back and see what was the previous code. All these kind of things are not possible. So without version control system, there are going to be huge problems. And versioning manual was a task people did earlier before version control tools were available. So collaboration with the team was very hectic, and also the task of merging the code or finding the differences between two code bases were also a huge problem. And as I told you, there was no easy way to access the previous version, and multiple versions took a lot of space because each time you should do Control C and Control V in a separate location. So all these problems were brought in. Means I wanted a special tool to track my changes. I don't want humans to specially track my changes to my source code, and this gave birth to the a tool or a category of tools called as a version control systems. And when you use a version control system, the versioning is automatic. What does it mean is, they are built to track each and every file, each and every change. So if you have changed today 10 times, 10 times it's going to find out that okay, that you have changed the file, and it'll ask you to save the file. Once you save the file, each time you change, it's going to record the changes. So tomorrow when you come back, you can see that there are 10 updates to your file, so that you can compare it also. It means that it's going to give you easy access to the previous versions. And also the version control systems don't take up much space because they're only going to store the modified files or the difference of the file. So it has a more efficient storage when compared to your current version control. Okay, when you talk about the version control systems, right? So the current version control system we are going to use, or more or less we are going to use, is a very popular already, okay, which is a git based version control systems. Around 60 to 70% of the organizations have already migrated themselves to a newer generation of version control system. So when you are talking of newer generation, it means that 30% of the companies are still using the older generation. So that's why we will see both the generations, and we will see when compared to the older generation, what are the advantages for your newer generation. Okay, so that you'll also understand what were the main reasons why people started using GitHub or something when compared to the earlier ones. Okay, so as I told you, right, in our organization, there is one person who is going to trigger the changes for everyone. Who is going to give work for everyone of in the team or everyone in the company? Who will ensure that we all get work? Until unless a developer changes a piece of code or line of code, we are never going to get any activity. We can sit idle, and we are not even needed, most of the people in the companies. Because if there is no change in the code, I just need a application runtime, some couple of people for monitoring, that's all. So most of the activity or most of the work we get is triggered by the developer. And what are the reasons for a developer to change the code? Why does a developer need to change the code? Add new feature. So these are the two reasons why our developers are going to have a reason to change the code. Part of a release, what happens is I am going to get a activities, and those activities, as I told you, people are going to create storyboards, and they're going to properly document what is the business case, what is the current functionality, what is the outcome. All of them are going to be properly tracked, and people are going to create the storyboard, and within that storyboard you have a something called as a the reasons for the change of code. And it means that all of this is going to be triggered by a single person who is going to be developer. The moment the developer is changing the code, everything gets triggered. The code needs to be properly tested, so testing team will get work. The code needs to be put it in the service. Operations team will get work. The code needs to be monitored. Everyone is going to get some work once the developer has a reason to change the code. So when we are changing the code, right, we are going to store the code. So there is one more term you need to understand from the perspective of the version control systems, which is called as a repository. Okay. So when you talk about a version control system, all of these things, right, the first technical term you need to understand is something called as a repository. So we have understood that people are never going to write the whole company business logic in a single application. They are going to break down that based on the kind of service that it is going to be provided. So you end up having at least 30 to 40 services in a typical company. Now, for example, let us take an application, for example, called promotions. More or less, most of the companies have this. Okay, a promotions application. A promotions application is nothing but which has all the logic of all the promotions which you are running from your company level. So now let us think as we'll take Java as most common example everywhere. Okay, so because Java is most dominantly used, it will be still used like that. So when your developers have chosen that they are going to write the uh, source code of this service application promotions in Java, they are never going to write the complete code again in a single file. Okay, what are they going to do? They are going to break down the Java code into smaller Java files, and you end up seeing hundreds of small Java files people writing, okay, to complete the what logic. So when you have this many hundreds of files, it is not just about tracking a file, but I need the tracking on a folder level, and I want everything to be tracked, and that folder is called as a repository. So in our organization, when you log into your virtual system, you see something called as a multiple folders. Each folder is designated to an application, and that folder is called as a repository. So a repository is nothing but it is all the files which are related to a specific application, all the files and folders which are combinedly are going to be making a single application binary or runtime is called as a repository. Clear? So whenever you talk, you're going to talk about repository. Okay. So this repository, all these repositories will be available in your central server.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
And when you talk about repositories, there are two types of repositories which we'll see later. But this is something you should have clarity upon initially. Okay.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let's see the types of version control systems. So there are two types of version control systems right now. People are still using them. One is a centralized based version control system. Another one is a distributed based version control system. So the centralized one is the older generation where pretty much most of the companies have now replaced with a distributed based version control system tool. So this is a process how they follow, and there are tools. Means based on this way of managing the code, there are products in the market like Subversion, all of this. Okay, based on distributed, there are also some products available. So this is the logical way of how this they are going to run internally, and based on this logic, people have built products on it. So once we understand this, I'll tell you what products are based on that kind of a architecture. So first, let's see the centralized version control system. Right now, the centralized version control system is the second generation of version control system, guys. Okay, it's not the first; it is a second generation. Okay, and the second gen, it's based on a central. Okay, now let's talk about centralized version control system, how it works normally. Okay, let's take this remote repo. Repo here is again called as repository. Okay, you can also call your repository as repo also. Okay, and one of the repository you have is a centralized repository. So remote repository or centralized repository are both are same as. Okay, both means the code which is in the central server. Server is nothing but a actual server. See, let me give a clarity which will be useful for all of this training. See, normally your laptop also can be called a server. Okay, and when we call it as a database server, it is not a database server, but since I have installed database software on that server, we start calling it as a database server. So that is how you need to understand. Server means it's not the actual server. Since I installed a a Git software, I'll start calling it as a version control system software or version control system server. It's not version control system server, but it's a normal Linux operating system inside which I've installed a specific product. So have this clarity. So when I call about a database server, means there is nothing special about database server. In a server, I've installed database software. Okay. So here, when I call it as a remote repository or I call it a centralized repository, it means that in a server, I've installed a version system product, and that is called as a central or remote. I have 3 developers now. Okay. And when as I told you just now, right? Whenever you get a work, what are you going to do is first thing is you try to obtain the latest copy of code. That's obvious, so that every change of other people are there already. From there, you can start developing your fixes or features. So let's think that there are 3 developers like A, B, and C. Now, developer A has a try to access the code. Yes, obviously he should try to access the code. So in the centralized version control system, when a developer will try to access the code which is in the remote repository, the remote repository is not going to give you or allow you to download any code. What it will do is it will allow you to make a reference copy. Means it is only going to create some kind of shortcut in your laptop. Means actually in a centralized server there is always going to be only one copy of code. So when I access it, it's not actually allowing me to download, but it only gives me a remote way of accessing it. That's all. So when the way we watch a movie in Netflix, right? It's not actually downloaded to your local and running, right? It's streaming, right? The same way in the remote repository also, when we are all watching Netflix, it means that are we all having own copy or in a laptop, or it's only a single copy we're all seeing? It's a single copy, right? It's the same way here. So in the centralized server, there is only one copy of code in the central server. So what happens to all these developers means each and every developer will be accessing the same copy of code which is being currently hosted in the central server or in the remote repository. Now, when this developer has updated some piece of code, okay, he's updated the code. Once he updates the code, since we are all accessing only single copy of code, the latest changes which are pushed by the developer A will be right away reflected by developer B and developer C. Okay, because since they're same copy, right, the moment I update, the changes will be reflected to the other developers right away. So that was one of a difficulty in your centralized version system. Okay, because if a change is made, it will reach every developer before they can commit their changes. And unfortunately, that also includes broken code, because this developer A may not write the code completely, or sometimes his code may not properly work. So this makes a broken code. And since there is only one true repository, working offline can be a challenge for us. Okay, so it means that this has some serious downsides. The first one is that we cannot work offline because I need to be connected, and if I'm connected, the other people's changes are right away reflected to me, which is going to be a problem for me. Okay, so this is how the centralized watching system was running. Okay, so now this makes a problem for us because we get to see the people's what you call unfinished code or broken code of other developers reflected right away to you while you're still working on your changes. Okay, another thing is, since it's a single copy of code, right, anything happens to central server, all the developers should sit idle. I'm not telling it's going to crash. Sometimes I'm not telling it's going to be completely lost, but due to some high load, if the server went into maintenance mode, or if there is any regular patching activity on it, or else due to some high load, the server becomes slow or unresponsive. Okay, what happens is every developer's productivity will be affected due to that, because everyone is getting connected to that single one. Okay, and apart from that, there are some basic activities you are going to do for every virtual system, and all of these basic activities always need for you to be connected to your central. Let us talk about that basic operations of any virtual system. Okay, storing the changes, then comparing, restoring the changes. Another one is, so these are the most 4 basic activities you are going to perform for every virtual system. So storing the changes, if you really want to store the changes, if you're not connected to your central, the changes will not be reflected in the central, means you can't store the changes. And comparing the versions is also one of the most basic functionality provided by any virtual system software. So comparing versions means, if you have a hello world.java file, If you want to compare, obviously, I need to have access to the versions. Then only I can do the comparison of work. So since you're not connected, then you don't have anything access to any version. So again, this is a activity you only can accomplish when you're connected to your network and having currently access to your central server. Restoring changes. So for example, you have found out that the code you have written is bad now. So your developer told that, okay, whatever the code you wrote in the last 2 days is bad, we want you to restore the code you wrote 2 days before. Yes, that is a very simple operation we can do. But again, if you want to do that, if you want to get a specific code from the central version system to your restore back, right, you need to again be connected to your central. And if you want to collaborate with others, again, uh, since it's a single copy, I need to again do that. So this made a lot of hindrance to the developer workflow. Okay, and that this was the centralized version system and how it was operating and how people used for a very long time. And what are the products built on centralized server? The most famous are your SVN and Tortoise SVN. SVN means your subversion. Subversion was completely based on this idea of a centralized version control system, and still you also see in most of the companies people are using, not most, less, like around 20% of the companies still using your SVN, but they are actively trying to migrate. They may have some challenges. It's not like they are want to do that, but yes, everyone may need budget again, everything, right? Why you need budget? Because you need to buy the product, right? Obviously you need to have a budget. So a lot of things, again, I need to hire a couple of people for the migration activity. So moving from one tool to other tool is not a simple, right? So some of the reason, but every company right now wants to move away from centralized watching system so that they can have better collaboration between the developers. That's again a vital thing, right? So that's why, as I told you yesterday, in your continuous development phase, we need to use a third generation watching system. That's also mandatory. So still using SVN may not be beneficial to you and also to your DevOps strategy. Now let's see what is a distributed based watching system. Now the same, again I have the same requirement. I have a application. I have 3 developers assigned to them, and each developer I have given one feature to implement. So again, in this, in a distributed based version control system, each of the developers, when they try to access the latest piece of code, the cent the distributed based version control system will allow the developer to download a copy of the code from the central to local. Means he can download offline. Means he will get a copy of the code from the central to local. So it will not only just allow to access it, but it will give you permission to download it to your local machine. So this is where you have a one more terminology in the repository called as a local repository. The local repository means the source code plus your version history. So now you have a new term called as a local repository. Okay. So uh, what kind of data will be stored in your remote repository or central? Normally source code and version history. Okay. So these are the only two things it will have: source code, and for each source code, what is the version history? Version history means which developer changed what file at what time, all those kind of information. So when you download this, when you get access to download this, right, when you get a permission from the central server to go ahead and download, the central will allow you to download both of them. So you can download both the source code and the version history. So it's a very huge thing when compared to this. Okay. So it will allow you to download both of them, not just the latest source code, but also the complete version history of that repository. One thing you should have clarity very early on is, in our company, right, database means it's a central person which is going to record every information, right? That's what understanding of database is for us, right? All applications can store access database and store their application information in one server. But when you talk about a virtual system, when I told you this repository, right? Repository is nothing but a file, all the files and folders related to application. Within this folder itself, you also have your version history. So it means that when you have a repository in your version control system, along with your code, there will be a small folder created for the version history to store the version history of that folder level, which is nothing but repository. So it means that in the version control system, there is no centralized location to store the each and every application version history. Within the same repository, the version history also will be stored. So each code base has its own version history within that folder itself, which is nothing but repository. Clear? Why we need a folder? Because I'm not going to write a file in the I'm not going to write my Java code in a single file. So I end up creating multiple files, and there may be some external dependency files like XML files, or some kind of what you call TXT files or CFG files, uh, all of them, right? Some dependency files, all of them will be combinedly put in a single folder, and within that folder there will be your version history also stored there only. So in the distributed based version control system, when I try to get the latest copy of code, my central server will allow me to download a copy of the code to my local machine. Once I download, what I'll do, I'll start working on my changes. So all the changes which you're going to work, right, are going to be stored in your local repository only. And there won't be any automatic sync, or there won't be any dependency or relationship between a local and central once you download. So your local will not try to automatically connect without asking you, and there won't be any automatic sync also established. Once you download local copy, that is completely cut down from the central, so there won't be any connections between them. Then once you keep writing the code, all the changes of your source code will be stored in the local repository only. Okay, and all the basic operations of your Git doesn't need any internet access, or doesn't need you to be connected to your office network to perform all the basic four operations of your version control system, which we just now discussed, right? These four of them. So to store, to compare, to restore, to collaborate, I don't need to be connected to my central. I can do all of them from my local repository without even having. Now, once you're finished writing the code, then we can run a simple command. Explicitly, we can push it. So the from the local to central, we need to initiate that connection. So until unless we are not going to initiate that connection, or until unless we are not going to initiate that sync from local to central, the local and central will never talk to each other. So we are going to explicitly tell the local repository that, okay, what are the changes you have, I want you to push them to the central. Or else sometimes you went 1 week on a vacation, you came back now, okay, now the code you have in your local is not the latest code, because other developers would have already updated it. So you can also fetch it. So fetching and pushing are always needs to be a manual command, which needs to be explicitly executed by us. Then only it will download it and it will going to execute it. Okay. So the fetch or the push are both commands needs to be explicitly run by us, so that we only can get the updates or download the updates from the central to your local repository. And all of the basic operations also can be performed without any dependency with your central repository. Changes which are there in the code which are not there in the local repository, because I all downloaded version 1 to all of them, but here version 2 code is there. So he'll try to push the code. The Git will tell you, see, you are currently not on the latest code, so I'm not going to allow you to push the code. It will give a suggestion. First, you again download the latest code to your laptop and apply your changes on top of it, then only push it. So it's going to give you clear instruction. So this way, there won't be any changes lost, or there won't be any overwriting. Okay, it will right away understand that it's not on the latest code. So that's how there won't be any conflicts, there won't be any data mismatches, or there won't be any overriding or data missing. So when you talk about the differences, right, whatever I told you, they'll be just here. Everything except pull and push can be done without internet access in the distributed based virtual system. So except push and pull, all can be done without internet access, because I have everything my central has. Whatever central has, it has given me everything, the version history and the source code, and it needs a dedicated internet connection. Every developer has full version history on the local drive. Yes, here he only has the working copy of code and no version history on the local drive. And committing and retrieving action is far faster on the local drive, because when you run the commit operation, or when you run the compare operation, the operation is run locally. So it's far faster than when compared to you doing the same operation on the centralized. That is why, since every action is a local action, it runs like your ls command with the same speed as your ls command. Okay, but here it should go there, it should get connected, it should retrieve, so it is a little bit slower. Okay, and distributed based virtual system is very good. This is don't read this, it's a very little bit opposite. In a distributed based virtual system, it is used for very large projects, okay, which can handle complex projects. And centralized virtual system was not supposed to be is not designed to handle that. And that was one of the main reason why Git came into existence. And when you're downloading the code from central to local, right, Obviously distributed will take more time because you're also downloading version history. So that's not a big problem because today we have bigger internet accesses. And remember that whenever you write a source code, right, can someone tell me what is the average size of source code in an enterprise?
Couple of MBs.
Yes, somewhere from couple of MBs to maximum of 50 MB. Okay, you seeing 50 MB itself is a very great thing. Okay, 50 MB means you understand in the text file. For a small 2 KB file only, there'll be 200 lines. So yes, our developers will write a lot of code, and there are also some dependencies. Means it will not be large size, okay, with the today's broadband or your internal office internet speeds, right? That's not going to be a big problem, okay. But when you're first time accessing or trying to download, the distributor will take little more time because it's also going to download along the source code, additionally the complete project history, okay. So the examples of centralized watching system, your Subversion and Helix core, okay, both of them were very popular centralized watching system based products. When you come, and there is also IBM ClearCase also, okay, IBM ClearCase. There are some additional tools. Let me show you the site of this. Git-SCM is the what you call the actual website of the open source Git tool. So this is a main website of the open source Git virtual system tool. Okay. So you see Perforce, ClearCase, Subversion, all of them are like old ones, and your Git is going to completely outclass them in a huge margin. Okay. So if you want, there's a book freely available. It was freely made, and you see most of the largest companies use your Git based virtual systems. Okay, so today very less number of companies are currently on a virtual system which is not based on Git. Okay, and if you want to download for Linux, you can have directly download here and you can install it. Okay, and you see what is a Git. Git is a free and open source distributed virtual system designed to handle everything from small to very large projects with speed and efficiency. That's a very simple definition of Git. So if you really want to further find out anything related to this open source project, this is the official site of this open source project. So the Subversion was an Apache open source project. It was a what you call it was started in 2004, and a lot of people started using in 2004, and it finally became in 2004. 2004 became 1.0 version. Okay, means the release version, and it's constantly being developed by a small and dedicated people. And the Subversion was an open source product, but people didn't use Subversion. People used the paid products on top of Subversion, like Tortoise SV and all of these kind of products. Okay, and it was based on the centralized virtual system architecture. And disadvantages are the same. I'm not going to go again. So the examples of distributed based virtual systems, your Git and Mercurial were the most dominantly used initially, but Mercurial also has completely lost its market share now. The only virtual control system tool right now being used is Git based virtual control systems. Okay, why am I talking about Git based but not Git? Is there are multiple products today built on top of Git, open source Git, okay, which we'll see in the later half. So Git, as I told you, is the most popular tool among all the distributed based virtual system tools. So the Mercurial and Git are completely more or less negligible now. Okay, so you see here this guy is moving around at the 100. Okay, this is 100 line and he's just here, so he's very popular. Okay, and let me tell you a small story of Git. Git was written by the person who was very important person who was already doing a very important activity. The Linus Torvalds was a person who single-handedly wrote your complete Linux operating system for the first 4 years. Then he open sourced it, and people started helping him, collaborating him, making sure that the Linux operating system was more popular. Because the more people start working on the project collaboratively, it will become more popular, more stable, and it also has a more reach. So when this person in 2005 was collaborating with a lot of developers in the open source community, he was having a lot of problems with the code operations or the collaboration operations, like sharing and merging all of them. Why? Because a Linux operating system has how many files, guys? At least 1 GB of size, right? Initially, when in 2005 it was 1 GB. Today it is around 3.4 GB. So it is not a small data. So it has millions of lines of code. It has today your Linux operating system has 15 million lines of code, guys. Okay, 15 million means 1.5 crore lines of code will be there in your operating system. So maintaining that much large project was impossible with the current virtual systems, which is based on the centralized. So this guy, out of his necessity or out of his need, what he has done is he ended up writing Git completely within 2 weeks of time. He just took 2 weeks of time, and he right away wrote the complete product called as a Git, which was based on the distributed based version system. So he already knew that the distributed based version system, what you call that architecture, was good. So he adopted that architecture. He ended up writing Git within a short period of time, so that he can better collaborate with the open source community, and he can manage his Linux operating system project in a better and efficient way. Okay, that was something related to your Git. So as I told you, Git is a open source distributed based working system which can handle from small to very large projects. Okay, and today it's dominantly used working system across the world. And let's see what is Git lifecycle. Okay, once we understand the no, okay, we'll see the lifecycle while we are installing it. I think it will be a little better. Let's go ahead and install Git. Okay, and then we'll see the lifecycle. What do you call, along with the commands itself. So I hope everyone is giving a little, guys, try to understand what I'm doing here. Using AWS has huge benefits for you guys. Okay, you can open in your organization. You can also use it in your company also while you're working. If you have some free time, you can also practice it, because no company blocks AWS. Okay, now this is the default screen for every user. Once he logs into AWS, you're going to see this screen, guys. Okay, this is a standard page where you're going to land the moment you log into your AWS. This is going to be the home page of your AWS web services. So here, click on the services and click on EC2. Once you click on EC2, you're going to go and land in the Amazon virtual machine homepage, which is also called as the EC2. EC2 is nothing but it's a small fancy name given to Elastic Cloud Compute, which is nothing but a virtual machine maintenance. So once you click on services and you click on EC2, you'll be landing in this page. Okay, so here you click on launch instance page. In the launch instance, there are going to be 7 steps to create a virtual machine on the AWS, and these are very, very simple steps. Okay, so the first thing is the Red Hat Enterprise Linux 7.6. Okay, so this is the operating system of our choice for the complete training. Okay, I am always going to use Red Hat Enterprise Linux 7.6 only, but not any other operating system. Even though if you ask, also I'm going to decline it. We will take RHEL 7.6 only. Okay, yes, so it is the most dominantly used operating system in your enterprises, guys. Okay, you don't see Ubuntu. Ubuntu is only children's operating system. You don't see Ubuntu in your organizations. Red Hat Enterprise Linux is the most dominantly used enterprise Linux operating system across organization. If you really join a company, you will be working in the same operating system version you are currently learning. Okay, so the step 2 will be choose instance type. Here it is going to be t2.micro. So t2.micro is a free instance, guys. Okay, so this is a free for us. So as I told you, that AWS is not going to cost you. So by default, it's going to choose you t2.micro only. T2.micro is nothing but a basic notation. Okay, micro, small, medium, large means we know, right? The sizes the same way. It will be based on the RAM and CPU. If this is micro, it will be 1 CPU, 1 GB RAM. If it is large, it will be 8 GB RAM. If it is 2x large, it is 32 GB RAM. So based on the name, it keeps increasing. Always choose t2.micro, but the t2.micro is already auto chosen for you. Means you don't need to specially select it. It's already pre-selected for you. So click on the step 3. The step 3, you don't need to do anything here. Just click on next storage. Okay. For the step 4 storage also, you don't need to do anything. Click on next. Step 5 also, nothing to do. Click on next. On the step 6, remember this activity you're going to do only once is something like open ports for all access. Write something like open ports, all ports are open, some kind of general English, and do the same thing below. Okay, in the type, click on all traffic. Okay, nothing, just give a simple name like all ports are open, something like that. And what are we doing here is I am opening all the ports between the server and the external world, so that you're not going to face any port conflicts or any kind of problems while you're learning. Okay, this is not we do in real time. In real time, we are going to put a lot more secure, but you don't have to worry about it, because when you're learning, you need not to face any problems. That is why I always encourage people to take all traffic. Okay, and this is only one time activity, you need to do recurringly. Okay, and click on review and launch. Sorry, I did multiple times. Once you do this, okay, click on review and launch, it will land you in this page. Here again, uh, have a verification once or review once that it is t2.micro always. Okay, once this is there, any other setting is not going to affect. If this is changed, then it may cost you. Okay, and this server configuration is more than enough for learning every tool. You can ask me, Gautam, is one CPU and 1 GB RAM is enough? Yes, it is more capable than your 4 GB RAM of your laptop. Okay, because these are Intel Xeon processors, which are server grade processors. Okay, they are not your Core i5 or Core i3. Okay, they are 10 times more powerful. So here one CPU is equal to at least 3 or 4 cores in your general what you call in your machine. Okay, don't worry about it. And click on launch now. When you click on launch, you see this page. Now click on this will be the page you'll be seeing. Okay, the create new key pair will be already auto selected for you. So create a key pair. Key pair means in AWS it is going to ask you to log in through a security through AWS certificate. So normally when we log into Linux machine, we log in through username and password, right? Here we are going to log in through username and a key file. This key file should be created by us. You give some basic name, something like my key or my AWS or something like that. Okay, or what do you call?
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Learning, give whatever basic, don't give fancy names, don't give spaces, don't give uh, uh, special symbols. Okay, all those things, give a simple plain English, your name. Click on download key pair, and this key pair needs to be only downloaded for once, and ensure that it's always available to you. Okay, if you're changing laptop, just copy this to other laptop, that's all. Put it in an email and have it in your email. Okay, now click on launch instances, and it's going to create a instance for us right away. So have taken a lot of time for you, but in real time it will not take much time for us, guys. Okay, it's going to take very less time. So let me again launch an instance, guys. Okay, launch instance, choose RHL 7.6. Then as I told you, t2.micro is already auto selected. I'm going to click on next. So for the step 3, step 4 and step 5, nothing to do. In the step 6, again you no need to create. This time click on select an existing group, and you see all ports open for learning, right? Select it and click on review and launch, and you see again review that it's t2.micro. Click on launch, and you no need to create again certificate. You can see that certificate I created, like learning. I have multiple, but you'll only have one. Okay, so you click on learning, I acknowledge that I have the access to this certificate, and click on launch instance. You see it has not even taken me 30 seconds to create a server. Okay, it's very easy to create a server in AWS, and also very easy to destroy also. If you don't want the server, click on it and click on action, instance state, terminate. It will be right away deleted completely, forever. If you once you have completed practicing, each time you don't do this terminate, what you'll do is click on this and select something called as a stop means it will stop the server without completely deleting it, so that tomorrow again you can log in and again practice it. So once you are completed with the practicing of one tool, delete it to through terminate. If you're not completed practicing, just click on stop and again start it. So for any other whenever you want to name something, right, I can give something like my git server or something like that. Okay, it's up to you. This is not your host name but a reference name. I can also give my name also. Now if you want to connect to the server, click on connect, and once you want to connect, you can take this and open a terminal session and connect it. Completely copy this, open a terminal session, and ensure you are in the location of that certificate. It is in my downloads, right? In the downloads, if I do ls learning.pem, so it is there. Okay, if I do ls minus -l. So go to your tool and click on this. Okay, now you'll switch yourself from your laptop to the AWS server. Okay, SH-I. So you should be in the location of the learning.pem. Wherever you, if you put it in D folder or D softwares, go to D softwares, wherever it is. I'm not telling you put it in downloads only. Some people like E drive, D drive, whatever. If you, once you download that certificate, right, it will be a downloads, C:downloads. If you put it in D drive, do CD to the D drive and run this command. But ensure that you are in the location of the PEM file which you have downloaded. Okay, no need to be in downloads only. So if you're interested in other cloud, you can also use another cloud. Every cloud has a free version today. Okay, but AWS has the most simplest free option. Other people have a lot of rules. So AWS also is the most easiest cloud of all clouds. Okay, now I'm in my AWS server. Uh, now let's go and install our Git. Where are you currently? I am currently in my home history user. And how are we going to install Git? We are going to install Git using your yum package manager. Okay, so I'm going to use the yum command, and the yum command is a your something you call it as a admin level commands. Okay, in Linux, right, there are no hard commands and easy commands. There are only two different kinds of commands. One is a admin level commands, one are a normal user level commands. Admin level means you should have administrative permissions to run that command. Okay, so yum is one of that command which needs admin level access on the operating system. The way you also have a Windows also admin and a normal user, right? If you don't have admin level access, you can't install Windows softwares. I hope some people would have seen in this, they would have experienced some, because you don't experience, because you don't work on Windows operating system. But someone is giving you only normal user permission on a Windows laptop, you can't install softwares on it. It's the same thing here. Okay, so I'm going to switch to a user who has a more higher level of permission, is root user. Okay, and another important thing you always need to remember is when you're working in a Linux based operating system, ensure that you're always in the OPT location. OPT location is kind of your program files. Means in the Linux operating system, there are different locations, right? Never install, never create, or never copy, or never download anything to any other location other than OPT location. The OPT location should be the common location where you're going to create a file or delete a file or download some files from outside server to here, all of them in the OPT only, because it is a user directories where we can install a application. Okay, clear? If someone will also ask you a simple question, can you tell me where Oracle is installed? You can right away to go to OPT. In the OPT, Oracle folder will be there, inside which your Oracle database will be installed, because that's also the most common location used by every enterprise to install any product on your Linux operating system. So ensure that you are always there. Okay. Now let us install Git. Yum install Git is a command to install your Git. Okay. This is a website. I want you all to go here who don't know Linux. Okay, who are already Linux, don't tell me I know already the commands. For the people who are new to Linux only, go to this site. It's a very good site for learning your Linux operating system and also your networking basics also. Okay, it will tell you what is subnetting, what is routing, what is DNS, what is network configuration, what is your NFS, rsync, all of them. Okay, so go to this site and complete this site. It's a very simple site. It will even tell you what is Linux also. It will even tell you what is command line also. Okay, these are all simple modules. It will tell you each module. Okay, everything. It will even tell you from cd command. What is cd command? In the cd there are two things: absolute path, relative path. There are a lot of things you'll learn, and this website is like highly organized website. You to simply complete your Linux. I think you can complete this within a half a day, guys. Okay, if you properly read and remember every line of this website, and this is everything your Linux operating system. Okay, so what is yum? Yum is a package manager. Package manager means, again, remember that for any of the terms you don't understand, try to Google them and complete them, because the more you do Google initially, finally you'll not have anything to Google. The biggest difference between a person who can learn faster and who doesn't learn faster is not that he's more intelligent. He'll have all the basics covered. Okay. When I talk about what is RHL, what is enterprise Linux, what is Linux, what is the difference between Linux and Unix, okay, so all of these basics, right, are very easy to understand, are very easy to grab also. The only thing is you should spend little time. Okay, so yum is a package manager which is going to help you install packages in your Linux operating system. Why am I talking about package here? Because you don't call software in Linux language. Okay, in the Linux language there are some things you should talk as this. Okay, You don't call C drive and D drive in Linux, and you don't call something as folder, or you don't call something software. Okay, you call it as a package, you call it as a directory, you call it as a file system. Okay, and go and see what is the EL family, okay, of operating systems. What is EL family of operating systems? Okay, and what is Debian family, and what is the difference? What is the difference between a Debian and OS? Okay, what's the difference between RHEL versus Ubuntu? Having clarity on this basics will hugely clear you, and ensure that on this site you should understand every term. Don't go to the next line if you don't understand a word. Open a new tab, open that Google, complete it and record it and document it somewhere so that you can soon go and look into it. Okay, so Yum means it's like your app store. In your mobile phone, what you do, you open your app store, you search for some example, for example, Google Maps, you click on install. It will do first, it will make a call to the Apple App Store. From there, it will download the Google Maps software. Then it will install the software on your operating system. Yum is also same thing, but in the Yum doesn't have any UI. Yum is a command line based package manager, which is going to accomplish the same thing. So it means that just because when I told yum install, it is running. Sorry, I don't find that package, because you don't expect everything to be there, right? If you try to search something which is only in the Android, if you try to install something in Apple, it will tell, sorry, that app is not available. So same way, yum will only install which is having within its own repository. You ask some random software like some what you call some PUBG game, it will tell I don't know. Okay, so only ask something which it knows. How to know it is you can search Yum search. Yum search will tell you whether that is available or not. So that once you know it is available, you can then tell Yum install. Understood what Yum is? And Yum needs access to your Red Hat satellite server or internet. Satellite server will be in our companies. For normal operations, it can go to internet. Okay, so it means that don't worry, your Yum command always doesn't need internet access. In our company, we can have a set up a satellite server and ask the satellite server to give the information to him. Okay, so Yum is going to put what kind of tools is Yum will have all the popular open source softwares only. It is not going to host your enterprise softwares. You can't simply tell Yum install Oracle database, because Oracle will right away put a huge what you call case in the court for this guy. Why? Because you should pay some money to Oracle, then only Oracle will allow you to access that paid software. So it means that in the Yum, only the most popular open source free tools only will be available. Don't expect your Docker, all these kind of things here. Okay, they're all enterprise products which needs to be bought. So I know that Yum is already available. I'll do here. Okay, there are multiple ways you can see. This is a one simple way we can. And I lost access to this, guys. Let me open a new tab. Okay, Yum install git. If you want to search, you can do Yum search git. Okay, it will tell you whether it is available or not. You see, there are a lot of things, but you see, git fast version system. So there are other things also like digital something. It will give everything, but for me, git. Okay, it is there. So I know that it is available. Yum install. So once you have installed Yum, the next thing is we need to verify whether the Yum. Sorry, once we install Git, we need to ensure whether the Git has properly installed or not. Okay, so there are multiple ways. The first thing is whether the Git program is available. So normally, right, what I can do is I'll go to my control panel, my Windows operating system, I'll see. But here we can do something called which will tell whether a program is available or not. So it is telling that okay, it is currently in the bin location. There is a program called Git. So this is one way of running. So first I have at least ensured that Git is installed. Now I know that Git is available. I'm going to do git -- version. So Git is currently on the 1.8.3.1. That's a version available. And since version command is running, it means that yes, Git the Git commands are right now working. Now Git is working now. So remember that you can install Git on your Windows also, but I don't encourage it. Try to create a Linux machine and practice there only, because tomorrow you're going to write the code here only. Okay, in a Linux operating system only. Now once you have written, as I told you, ensure that you're always in the OPT. Am I in OPT? No. Let me go to my OPT. Okay. Now in the OPT, I will create a directory. Okay. Or before doing anything, right? Once you install Git, right? Git expects you to run couple of basic commands so that it can recognize that you are that specific user. Why? Because when I'm going to write or do some changes to the code, right? Git explicitly should know that this is that person, right? Obviously, because if I'm changing the source code, I should give the name and everything, right? So it expects some details to be given from our end, like my name and email. That's all, not much beyond that. Okay, so let us give that git config hyphen global user dot name and also email. This is some dummy email. Okay, so once you do that, you can also see the config git config hyphen global list, which telling this information has been set up. So these are the only two mandatory things we are supposed to do, so that when we are doing something, it is going to use this username and email to register that okay, Gautam has done this, so that it will store that information inside the repository, which is a local repository only. Okay, and there is one additional optional command I am going to run, so that we are going to see the git output in a more color coded way. Okay, because if it gives in a color coding, it will be little easier for us to understand, right? So always colors are very easy, right?
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So that's why there is a command. This is not a compulsory command, it's an optional command, but it's better to run this. Okay, color.ui auto means it is going to show some colors. Means when it throws an out, when I do any command with git, the output will be little color coded, so that it is going to be little helpful for me to determine what is happening. Okay, so yes, these are the three commands we done. Now let us take this example from the scratch. Okay, from the scratch means we will now create a new project. So for example, your company people have came and told you that okay, that we have a new application I need to build for example, your Google Assistant. Google Assistant is also for Google Assistant also, if you want your company to be there, you need to write some code, right? Obviously, for example, your company's quick info. I want now ask a question to my Google Assistant that okay, what is the current score? So for that, uh, quick info should get their code and something do that, then only they can accessible. Or else if you want to switch your Philips light today, there are a lot of things happening, right? Or we can also think that if you want to write a small application for customer care, anything, right? You need to first create a what, a folder for any application. If you want to write, first we need to decide where we are going to write the code. So I am decided that I'll write the code in this OPT location. So I'll do mkdir, for example, customer care. Okay, I'm going to write a customer care application, and this is a new application. Till now this is not in my company. I've been given the requirement to start writing the code for the first time. Okay, so I do ls, I have the file, and I'm going to do cd. Now I have created a simple folder. I have entered that folder. Since we have installed git, is git going to track each and every file in my operating system? No. Just because we installed git on this OS, it is not going to track each and every file in this operating system. Then what is it going to do is, we need to explicitly tell git to track a specific folder. It's not only going to track that folder, but all the files and folders and subfolders within the directory will be started tracking by the git. So by default git will not do anything, so I need to inform git. So right now if I do ls minus a, it's going to show me something called as a ls minus a will show you hidden files. Okay, ls will show you normal files, but ls minus a will show you hidden files. So there is nothing hidden also here. Okay, I don't see anything hidden also. Now git init, okay, dot, you run this command. Now you're going to initialize this git as a repository. So this normal folder now has been initialized to start acting as a git repository, and whenever it is in the local, what you call it, it's a local repository. So now this starts acting as repository. And I told you, in a repository what you have inside a repository, it is nothing but a folder inside which I have my files and folders, part of my code, along with my version history. Am I right? So now only this folder will be tracked by the git in the whole operating system. Other files are normal files and normal folders, nothing will be tracked. If you initialize one more folder with this, that also will be tracked by git. Clear? So it's very simple to do this. And once you do ls minus a, now you see something called dot git here. This dot git is nothing but your local, what, your local version history. Okay, later we are going to take this and push it to my central later. Okay, so this is your local version history. So dot git means nothing but all the version history will be stored inside this special folder called dot git. Once you have what you call, once you have initialized repository, what is the basic activity is to start writing code, right? So let us start writing code. Okay, let us write something called as a va hello world. Okay, for us we are not writing the code is not important for us, understanding the flow is important. So I'm going to write a file here. Okay, and let me go to the internet and fetch me some basic code. Okay, don't want to write waste time in writing a code. I'll just copy and paste the default code. You see, this is a very simple code, and if you see here what it is telling, print hello world. That's all. I'll just give a space here so that it will be clarity. Okay, so public classic hello world, public static void main, system.println hello world. So this is a simple Java program which is going to print hello world for us. That's all. Okay, so there's no complication. So this is my code. Now I'm going to save this. Now your git lifecycle starts. So now let's go back to the git lifecycle and let us understand what is the actual git lifecycle. So in the git lifecycle there are totally 3 stages. Okay, there is a what you call ambiguity. Let me clear that so that you'll better, I mean, I don't know why this name came, but this name should be this. It's already here. Okay, yeah, local repo should say. Okay, so now let's see. So what is working directory? Working directory means whenever you have initialized any normal folder in your operating system to a git repository, and that folder is called as a working directory. Okay, working directory is nothing but the actual location where you're writing the files and storing the files in the system, right? That is called as a working directory. Here, what is my working directory? Can someone tell me? My customer care is my working directory. Okay, right? So because I have initialized this more normal folder with the git, so working directory is nothing but the actual location in your laptop or in your Mac operating system where you're going to write the code, and that folder has been initialized as a git repository. Now that's your working directory. Now what is the staging area? The staging area is an intermediate location in the git lifecycle where it's going to store the changes before it's going to be permanently stored in the local repo. Local repository is nothing but your version history. That is your local repository. And what is your version history here? .git. The .git is nothing but it is a folder inside which all of your versions of your files will be stored. If you have updated your hello world.java 10 times, each time what you did, all that information will be stored inside your .git, and the .git is itself represents your local repository. Okay, so both of these are something I can see with my eyes. Working directory I can see, local repository I can see with my eyes because it is .git folder. So the staging area is only it's like a imaginary temporary location where the code you write will be stored there. Further for you to verify once, or also to look into it once before it's going to be permanently stored inside your local repository, nothing but your .git folder. So that's your life cycle. So what is a working directory is the place where your project resides in your local disk. Local disk means your local motherboard, hard disk, and this project may or may not be tracked by git. Okay, so but in either case the directory is called the working directory, and the project can be tracked by git by using the git command called git init. Okay, by doing git init, it automatically creates a hidden .git folder. Okay, so normally initially it can be any folder which is tracked or not. If it is not tracked, then you need to start the tracking by the git using the git init command. It will create a init folder which is going to be with init command. It will create a hidden folder called .git, which is nothing but your local repository. Then the staging area. Once you're in the working directory, we have to specify which files are to be tracked by git. So once I write the code, I'm going to tell the git that okay, I want you to start tracking it. Once I start tracking it, I am going to put the files which are tracked in the temporary data so that it gives me one more chance before I finalize it operation. Okay, so the staging area is a temporary location. Git gives us one more chance for us to review the code before it's permanently stored inside the local repository. So once the files are selected and ready in the staging area, they can now be saved in the repository. Saving a file in the git is known as a doing something called as a commit. A commit is a very important operation in your git. So when you run the git commit operation, it is doing nothing but it is going to store the changes which are in your local disk into the repository. It means that all the files which we have created in this normal ls folder level, right? It will be taken and stored inside the .git folder. Okay, that's what a git commit will do. So when you do the git commit, right, there is a lot of things which will happen in the background. Let us do that. Commit is an operation which is going to take the changes from staging area to the local repo. When you do a commit, it will create a commit ID, okay, a unique ID to track that code, and along with the commit ID, the name of the person who did, his email, the timestamp, what he has done, and also like reason for the change, and also which files were changed. All of this will be recorded within the commit ID, okay, because I also need to remember everything. So all of this information will combinedly be stored in the commit ID. So a commit ID is nothing but one operation to store the code. So you may do multiple operations in your company. You may see hundreds of commit IDs in your Git repository. A commit ID is nothing but a operation to store the changes to your local. See, understanding this is a little tough, but once I show you the commands, it is very, very simple. Okay, Git itself is a very simple tool, guys. Okay, on all the tools, right, Git is the most easiest tool. Once you see the hands-on, it's very easy. Working directory is nothing but whatever the location I'm currently working upon, it's going to be my working directory. So again, I got disconnected. Let me connect back again. I'm going to my customer care directory. I just created a file. Okay, so means I've already placed my file in my staging in my working directory, right? Because I've put. So to understand what Git is interpreting from your operations in that folder, you need to regularly run git status, which is the most common command you're going to run regularly. So git status, it will give you something called as an untracked file. Untracked file means a file which has been never tracked by Git. So there are also 4 states of files also. Along with your life cycle, you also need to remember one more thing is your, we'll also see that also in a minute, the life cycle. So along with that, so right now I have already done an operation. So this image is a lot more easier. The person who has created is not at all created perfect slides. Okay, so all of these are local operations. Why local operations? Because you never run any operation in the central. Okay, so you are currently resetting the working directory, and I've created a file. Okay, the file is currently in my working directory. If I do ls, I can see hello world.java, and what it is telling is untracked file. I'll come to this file status. Okay, but let first you remember what untracked file is. Okay, untracked file means this file is never inside my git repository. Inside git repository means it has never has any of this kind of file name inside the git repository, which is your local repository. So git has never has this file inside inside its version history. So it's telling that I've never tracked this file, so it's telling untracked file. So this is a new file for the git. That's what it's telling, untracked file. So once you have a file in the working directory, now I need to take this file and move this file from the working directory to the staging area. How are you going to do this is by running a very simple command called git add. So someone asked me if I want to only add move 2 files. So whichever file you want to add, give the file name. If you have 10 files, only want to add 5 files, only give the 5 file names here. Okay, it will only add those 5 files to staging area. Other files will still reside in your working directory and they will not be tracked. See, if you really want your files to be tracked, you need to add that file to staging area, then add it to the commit area, means your local repository, then only that file is being tracked, otherwise it will never track. Okay, so if I do add, you can add any number of files. The next example, we'll also see two or three files also, but right now let us take a simple example of adding a single file. Once I do this, it's going to move my file from the working area to the staging area. How can I know it is? My git status will give me a helpful information that changes to be committed. Whenever you see this message changes to be committed, it means that these files are currently in the staging area. They are ready to be committed to the local repository. Okay, now there is again a command for us to run, git commit. The git commit is a command which we run, takes the files which are in the staging area and puts in the commit area. So another question comes in is, can I choose a specific files from staging area? No. Whenever you commit, all the files which are in the staging area will be completely sent as a single commit. So it means that there is no way, you don't have any choice of selecting a file from staging area. You already have a choice of selecting which files should come to staging area. That time itself we should decide. So when you commit, the whole of the staging area will be taken and committed, And now you need to have again clarity on some more things. Is, for example, you are a developer, someone gave you to fix a defect. Okay, to part of this fixing the defect, right, you ended up changing four Java files. Okay, so you have changed four Java files to fix the defect. Now you don't need to put them as four different commits. You can add all the four files into the staging area and do a single commit. So doing this is huge advantage for us in when we are tracking the changes which are happening on my version issue. Why? Because for a person who is going to later see your code after you leave the company or after you leave for the day, is he'll understand, okay, fix the defect ID 1234 or something, he has updated these three files. And when someone will restore also, they can, with a single operation, they can restore all the four files to previous version. Because since it was a commit, I also told you, right, we can also uncommit it, means like you can get it back. So it's very very important for you to understand that for any specific change you're going to do, add all those files to the staging area and commit it, so that all of these files will be part of a single commit ID. Okay, remember this, it's a very important thing, and this is a very basic thing. If you don't follow this, people will right away know that you don't even know basics of it. If you do four operations for four files. Okay, and this is what our developers also do. Understood? Okay, so git commit is a command which moves your files from the staging area and permanently stores them in your git database as a commit. A commit means it is a permanent record in your git local repository. So the git commit -m is a command for us to take the files from the staging area and push it into my commit area, which is nothing but my repository. So for the git commit -m is a mandatory option. Why? Because I also need someone to write a single line or two lines of a meaningful message that why is he updating the code, because I need to know the reason, right? Tomorrow, if another developer has joined, he also wants to see what are the changes happened on the code. He'll know that files are changed, he'll know who has changed it, he'll know at what time they were changed and what files were changed. If he doesn't know the reason, it is very tough for him to understand or relate to it. So that's why you should write a simple single line or two lines of a meaningful message. Okay, so I'll tell git commit -m. This is my first commit for the customer care application. Write a meaningful message, okay, and don't write as a lengthy paragraphs. Write a single line. Now once I do this, it's going to tell that it has done a commit. Okay, now if you see the git status now, it will tell me something, a very important message which should you remember, guys, is nothing to commit, working directory is clean. So what does it mean is, when you see this kind of message, it signifies that
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
working directory clean. So till now I did not tell you what will git status will do. Okay, let me tell you first what does git status command will do in the background. When you run the git status command, what it will actually do is, it is going to compare each and every file which is in your working directory to each and every file which is inside your git repository or your git directory. So right now I had one hello world.java file, have pushed that file inside my git repository. So the file is actually, there is a file inside my git repository, but it is stored in its own standard directory, its own database kind of way. Okay, but I have actually pushed my file into this. So right now when I do git status, it means that the files which are in my working directory are exactly the same data and same files which are in my git directory. When they are both same, then I see the message called working directory clean. Clear? Now let's see a lot more operations in it quickly. Now first, very often use the command git status to see what's the status. Now my status is good. Now the next thing is, let us open my file again and let us update it again. Okay, vi, this time let us add a statement to it. Okay, I'm simply updating my code. Okay, I'm updating my code telling that, okay, this program will print simple message. I've updated this file, and let me do the git status now. And this time the git status is telling me that it is modified file. So modified means when you do the git status, if you tell modified, it is telling that this time again it is going to compare the same thing. It is going to compare the files in your working directory to the staging to your git repository. But this time it is not telling what last time it told us. It was a untracked file because it was never inside it. But this time it's already there is already a hello world.java file inside, but the contents are not the same because I just now updated it. So modified file means hello world.java is already there inside the git repository, but the contents are not the same. That is why it's telling modified. Okay. And when you call it as a new file is when you're pushing a file for the first time inside the git, it's going to call as a new file. Okay. So it is not even having any track of it. It is telling once I give a track to it, once I tell it's a new file, it will identify it as a new file. Then once it is modified, it's called modified file. Okay. That's three of your states of your files. Once I have it, let us also create a new file this time. Something like readme.md. Readme.md is a special file which we can use to provide some basic information about this project. Something like application name, then something like this. Okay, and let me save it. Now when I do git status, I see now two files. One is an untracked file because it's a new file, and modified file. If you only do git add your hello world.java and you do git status, you only see that one file is ready to be committed. The other file is still untracked only. So this way, if you're working on two or three files, only want to commit one, only add that one file to the staging area, and only that will go to your commit area. Okay. And when you have multiple files you want to add, you can do git add dot. Git add dot will add all the files which are in your currently in your status message. If I do git dot, if I do git status, now both of them are ready to be committed. Okay. So you can give only dot to add all of them, or give only one file name part of multiple files to only add that file. Okay. So that's how dot will add every file, giving file names with space with add everything will give only add those files. It's up to you how you want to add them. Once they are in the staging area, now I want to commit them. Okay. So git commit -m added readme.md file. Now if we do git status, everything is now clean. Now let's take another example. Let us open this file again and let us update this file again this time. Okay. And let us see some other operations. This time again I'm adding a print statement. Okay, a new print statement I'm adding this time. And this time I'm adding a message called as a welcome to git. So I'm saving this line, and if I do git status now, it will tell me what the file, what will the file status now? It will be modified because it is again comparing, and the contents of this file is no longer the same with the file which is inside it, right? So that's why it's telling modified. Now you did this at the end of the day and you left for the home. Now you came back. Now you don't remember in this file where did you do the changes. Then how are you going to catch them or find out them? Or sometimes unnecessarily while editing a file you may remove the semicolon of a actual code. So all of these problems or mistakes can happen. So how to find out what are the latest changes when compared to the code which is in your version history is through git diff command. The git diff command will exactly tell you what are the changes. If you see here, I added one empty line and I added this. You see the green color because you added something. If you remove something, it is going to show you in the red color. Means when compared to the code which is inside your GitHub, if you remove a line or if you remove something, it will show as a red color to you. So git diff will help us simply find out before we commit or before we do any operation. First do git diff so that it will tell you whether you are only pushing the changes what you want or some unintended changes are also escaping. Clear? And sometimes you didn't check this at the normal. You didn't check this. You right away added the file to the staging area. Now if you run the git diff command, it will not work, but there is a command called ---- staged which will work even though it is in the staging area. So if I do this, it's going to do the same thing. All the files which are in the staging area will be compared to the files which are inside your working in your git repository. So if there is some change, it's going to show you. So these two are essential commands for us before we decide to commit or before we add it to the staging area. We can run once and see, are we only going to do what changes we want to do or some other changes are being done. Once I feel these are done, then I'm going to do git commit -m, and I'll give a meaningful commit message, like something like added a new print statement. Okay. Now I did multiple times of commits, right? How to see my commit history is git log. The git log will give you the commit history on this repository. So till now I have done 3 commits. So all the 3 commits are there. There is a commit ID. So as I told you, for a commit ID, there is a lot of information around it stored, right? Like the name of the author, the email, okay, and also the timestamp, and also the reason for the change, commit message, and also the files change. The files change I'm not seeing because there is an additional option you need to put. It will tell you what files were changed part of the specific commit. So, and another thing, important thing to remember is the commits will always be shown in the descending order. Means the latest will be on the top and the old one will be at the bottom. Okay, so my initial commit, right, this is my first commit, it's at my bottom, and added print statement was the latest commit, it's on the top. Okay, so latest commit will be on the top. So in your organization, right, if you run git log, it may print you 100 or 200. So if you only want to see a specific one, you can do -n and 2. N and 2 means it will only show you 2 commits, 2 latest commits, because when you want to compare, you'll not compare 1 year back code to latest code, right? You'll only compare something like a 1 week back or 1 month back, right? So only print a couple of log messages and you can use that information and do whatever the operation you want, okay, with -n. Now if you want to see the complete file names also which are changed part of it, then I can do git log -stat. Okay, so here it will tell you -stat will option which file is changed and how many lines are added or how many lines are deleted. So in my initial commit, there were a total 7 lines added. In my second commit, right, 1 line was added to my hello world.java. In readme.md, 7 lines were added. In my third commit, which was my latest commit, only 2 lines were added part of the hello world.java. So this is the most extensive command you can run and the most concise command. So this is the most what you call the most detailed information your git log command can tell you. -stat. Additional information is what files were changed part of it. Okay, the most concise information is git log -one line. Okay, git log -one will give in a single line. So if you really want, you can understand this, you can run this, the most concise, the most detailed. Okay, and if you want to find out only commits by specific person, that may be some kind of reason, right? So what you can do is git log -author equal to author name. For example, you only want the commits from your team member, not some everyone other member, so you can do -author equal to this. But this time my author name is reflecting to all three. I see all three, but in this three, only one of that was done by a team member. Only that one commit will come. Okay, those are all your different kinds of log messages. Or log is nothing but your commit history. Now let's see another example here. Is this time I again am going to edit my code. So what I'll do is I'm going to add a commit message to this. Sorry, I'm going to add a what you call a comment line. So I'm going to tell prince welcome to git in the terminal window. I'm going to write this, and out of array, I'm not saying whether it's syntactically correct or not. Out of array, I wrote the code, I saved it, okay, and now what am I doing? I added that file also to the staging area without even doing the git diff. I did not even do git diff. Out of array, I added the code, I added to the git staging area. Now I got a doubt that okay, that whether my code is correct or not. And staging area is there for to help us. How can I compare my code which is staging area to my code which is in my local repository? What is the command? What is the command to compare git diff -n staged? If it is in staging area, git diff only from your working directory to the local repository. So git diff -n staged will compare the code between the files which are residing in staging area to this. Diff will only compare between 1 and 3, working directory to git repository. Git diff -stage will compare from staging area to this. Because I already pushed it to my staging area, hyphen stage is mandatory here. Okay. Now if I run it, it has told me that this prints is there, but you see, if I don't put double slash, it will not be considered as a comment line. It will be considered as a proper code, and this is not a proper code in Java. It will right away throw an error that syntax is issue. So now I need to fix it. But I already pushed it to staging area, right? What we need to do first? We need to get the file from the staging area to outside again. So means we need to unstage the files. So git reset head and the file name, whatever file name you wrote. If you run this command, it is going to unstage the changes. Unstaging means getting the files from staging area back to your working directory. Okay. So now if I do git status, you see something changes not staged. So from changes to be committed, it came to changes not staged situation. So now I'll update my code va hello world. I know what is my problem. The problem was uh, this. Okay, that I did not add the code to make sure it is a comment line but not like the actual code. I'm going to now save it. Now if I do git diff, it will work because it's in my working directory only. Now I see the code is good. Now I will add git add file name, and my status will be now what, ready to be committed, changes to be committed. Okay. So git now I'll do commit -m, and what are the message? Added a comment line for new print statement. So this time added a line, deleted a line, but now you see the git status. It is on branch master, nothing. I'm good. Okay, the changes which I've done in my local are reflected. Now what is head? Head is nothing but it's a virtual, or you can think it of something as a kind of what you call a virtual pointer. Okay, a virtual pointer which always points to the latest commit. When you do git log, right, you see this, there are 4 commits now, and when I do git diff, right, what is it comparing with? There are 4 versions of my hello world.java now, because each time I changed, I pushed that file from my local hard disk into my into my git repository. So inside my git repository there are 4 versions of hello world.java. So when I do git diff, with which version it is comparing, you need to know. But it is only going to compare with one version. Is it going to compare with the initial version? No. The most of the operations when you do, right, it will always be comparing with the latest version of the code which you have pushed inside. So the head is always going to point to the latest commit inside, because you can't remember the commit message, commit id, right? So I can't do all these things. So that's why head is a virtual pointer which always points you to the latest commit. If you do one more commit, commit 5, the head will start pointing to the 5th commit. So all of the operations will be done through the latest commit. So your git status command, your git diff command, all will be always pointing to the latest commit, and head is that 5 commits now I have seen. But we only learned one operation till now, is how to store the changes. But now I also want to start comparing the changes. That's also one basic operation. So how can we compare between the changes we have already pushed? So there are 4 versions of my code, right? Now I want to compare between multiple versions of my code. So that can be any reason. So git diff, okay, head -1. Head means it will always point to my latest commit. I just not told you. -1 means head -1. So if I do this, we know that this was the line added. If I do -2, tilde means this symbol is okay, which is below your escape button. Below your one, you have your one alphabet, right? Below left side to that you have this like inverted S symbol. That's called as a tilde symbol. Okay, there are multiple names, but in IT terms it's called as tilde. Okay, so head -2 means the latest -2 commit will be compared. So latest commit and 2 commits below will be compared. So what is it? We added system.ln, and if I do -3, it will be showing me what I added this both message. But right now I see two files being compared. So git diff, it will compare all the files which are between the 2 commits. So if there are 2 files change part of it, both the 2 files will be showed you. But if you only want to compare one file, then you can give the file name. If you use the file name, only that specific file will be compared between the commits. If you don't use the file name, all the files which were part of that commit will be compared. Okay, so I see this diff head minus 3 means this is my what, this program will print simple message, which was my second commit. I added readme.md and commit. This is my initial commit. I can't compare with the initial commit. Okay, you can only compare initial commit minus 1. So 4 4 versus 3, 4 versus 2. Okay, so that's what we have done now. Okay, clear? Head minus 1. So welcome to Git was the latest change. Then this was the latest minus 1, and this was latest minus 2 and latest minus 3, which was this one. Okay, so this is my commit 2, this is my commit 3, this is my commit 4. Clear? The head allows us to compare between the multiple commits you have. Okay, but now you'll ask me a question. Okay, it's fine for me to remember head minus 1, but what if I want to compare like head minus some specific number? I don't want to start counting that back. So that's a valid question you can ask me. You're telling me that okay, you're taking me as a reference of the latest commit and comparing backwards. But what if I want to compare between like 2 and 3 or 1 and 2? Because here I'm comparing with the latest commit, and compared to the latest commit I'm going backwards. But what if I want to compare between some specific like a commit 20 and commit 21? Under 25 commits, I don't want to compare always taking the reference as the latest one. So that time when you want to compare with any combination to any combination, not taking the latest as a your reference one, what we can do is we can take the commit ID and we can compare. So when I told you, you have the one command called git log -f one line, right? So when you run this command, we get the commit ID. So normally a commit ID is a very large string, but in this string, right, the first 7 are unique numbers. So you don't need to take the whole string ID. Within this whole string, the first 7 are also unique. So what it will do is it will print only the first 7. So what I can do, git diff example commit 1 and commit 2. I only want to compare between 1 and 2. I don't want to compare between anything other than that. Okay, and I'm going to print which file you want to compare. So you see between 1 and 2, this was the line we added. This program will print a message was the data we added as part of the second commit. So git diff through commit messages, I can compare between any commit to any commit. But when you want to compare between the latest commit, because there are a lot of times you want to compare the latest code, because that is the active code you're working upon, right? So you want to compare the code you have currently written to the old code. So at that time you can use the diff one. If you really want to compare between any commit to any commit, you can do this. Clear? Because each time we change some code, so I'll know what's happening on that each time. Because when we did this git diff only, you have understood based on the changes. This was the last time I added print. Before that I added system order. Before that I added a message to the top of my code, right? Now the message is restoring changes, right? That's the third operation I told you. Obviously when we are learning, I told you, right? What are the 4 basic things I told you can do? Storing, comparing, restoring. Restoring means, for example, out of your 4 commits, after second commit, all the data you added part of third and fourth commit are now wrong. Someone told you that okay, the code you have written is bad code now. Now if you have found out that the data you have the commits both 3 and 4 are not good, so what is the logical step now is some people will right away tell they'll delete it. That's the worst thing you should never do. What is the best way of now removing the changes part of my third and fourth commit? I want to undo my changes. So undoing the changes is nothing but what git will suggest you is whichever file you want, you extract that file outside and again commit it back. Okay, so instead of we deleting, because see here I am the only developer, but what in real time there are some commits done by your other team member which are valid data. Because see, after this second commit, the third commit and fourth commit are done by your other team member which are properly working, but the code you added part of second commit only has that problem. So that's why deleting the commits is never a good idea. And another problem will be there is part of your second commit, right? You added 5 files. In that 5 files, only one file is not good. So unnecessarily undoing the other files is also again a problem for us. So that is why there are a lot of headaches if you start thinking about deleting the data, and it is never possible. It's impossible to maintain that. So that's why what Git will tell you is, see, if you really feel that you have written a bad code and you want a code which is old code now, which is working condition, go to that specific commit and extract that file. That's how you are going to uh, uh, like fix the code which you want to fix by extracting some code from the earlier commits. Okay, so never think of deleting or never think of messing up. Okay, why? Because normally, right, normally when we store in a database, if I add some data, right, every data is every row, right, every row is independent row. When you add some data to a database, right, if I add 10 students to a database, each student has all this information in one row, right? Affecting that row will not affect anything other. But that's not how the Git database works. In the Git, right, every commit will sit on top of one commit. So my commit 1, commit 2 will be sitting on top of it, my commit 2 will sit on top of commit 3. So every commit has a relationship between every commit, so you can't simply go and mess up on specific commit. Okay, it will completely destroy your whole commit history. So that's why messing up with a commit history or going and updating a commit history, all of these are not possible. Some of them are not at all possible, some of them are possible, but you should not do that. That's why the only simple way of you fixing a problem is, if you already know the problem, if you already know the code which is already there inside your version history, get it outside. But if it is not there, then write the new code and again commit it. Okay, so now let's see a situation where that my code which is in my part of my commit to is a working good code. So first let us do cat hello world. Okay, oh, it's already gone, huh? Okay, it's already disconnected, let me connect back. Normally this will not happen in most of the situations. In very rare situations this will happen, so never worry. This is your AWS server will never get disconnected like this. I have a little bit unreliable today, that's why. Okay, don't worry. Now let me go into my directory. If you run your git status command outside, when it will tell not a git repository. My opt folder doesn't have git repository, so simply you try to run any git commands outside your outside the directory where you have not initialized, you'll get all fatal error. Okay, now let us do cat. This is my current code. Okay, this is my current code. Now from the git, right, git log hyphen one line, I found out that the code which was part of my second commit is good code. So first let us compare simply. Git diff head tilde. So this till until this I feel the code is good. Above these two commits are the code is bad. Okay, so now I'll do git checkout, then from which commit. Okay, so I know that it is head -3, head tilde 3, and the file name, which file you want to check out. Okay, before that, again let me do a cat, because I want you to exactly know what happens in the background. Right now this is my code content of my file is this. Once I run the git checkout command, the file which is in my local will be overwritten by the file which I'm extracting from the git database and placing in my folder. Okay, you see all the changes were thrown out. Clear? So the changes I did part of commit 1, commit 2, commit 3, all of them are gone. Okay, this is my initial code, right? It was my initial code. Yes, it was our initial code. Part of my commit 1 I added this, part of my commit 2 I added this, part of my, sorry, yeah, commit 2 I added this, commit 3 and commit 4 I added. So all of them are thrown outside. So what it did is, it has overridden the file which is my local with a file which is extracted from your version history. Okay, clear? So once you do that, what you do with this now is you again push it back to the repository so that that file is there. Okay, so I'll do now git add. So my verse 2, 3 and 4 changes are still intact. So the hello world.java now part of my commit 2 and commit 5 will be same, because both are the same files. Sometimes you may want to update something. You extracted a file, you want to add some additional things now and you can send it. That is why we can never know what combination you have. That is why you never do all what you call editing of your commits and everything. Because once you extract it, right, you may want to add some additional lines, right? So it will not be similar to any code, right? You extracted a file which part of your second commit. If you're as it is pushing it inside, there is not change. But You may not do that always. Once you extract your second commit, you may add the updated working code to that, and you can again commit it. So there may be multiple kind of situations. That is why once you extract it based on your requirements, again update it, or again as it is, push it inside. Okay. Here this time there are three deletions because three lines were deleted. That's all. Okay? So that's your this one. So now once you have done local, now let's go to the central. Okay. So central means we have not even touched the central. Now let's just touch the central, and let's see what is the central and all of these concepts. Till now I did not even use the word GitHub, right? Why did I not use the GitHub word? Because when talking about this Git, right, there are a lot of things which are features which are missing from the open source Git. What are those kind of features? Let us see what are the features which are missing. Okay, from Git. Like I don't have any UI layer to it. Okay, because if I don't have a UI layer, it's not easy for everyone to use the virtual control system software. Is as a developer or as a DevOps engineer, I will know what command to run and see what is happening on the version on my repository. But really, if my manager or my developer or someone wants to log in, it is impossible or hard for them to see what's happening on with a simple UI layer. So Git doesn't have any UI to it, and also it also lacks a security. If anyone can log into this server, right, he can simply delete that folder. My version list, everything is lost forever. Okay.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
There is no security to my code. So if someone has access to server, it also means he has access to the central repository. So it's a problem to me. So I need a better way to secure my code. Okay. So in a how I can secure is through my integrating my existing LDAP. LDAP means I don't want to have any user management. Once I want to do a security, obviously I need to start creating username passwords to that server or to that application. So, but how are we going to manage the username passwords is through an LDAP software. Okay. Go and check what is LDAP is. Okay. It's a very vital part and you should have very clarity on it. Okay. Go and do a Google of your LDAP. So LDAP is a tool which is going to help you use your centralized authentication and authorization of your organization level.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Whenever you join a company, right, they'll give you username password, right? That username password will be stored in the LDAP software. That's why you can use the same username password to log into your HR portal, your what you call your email, to your Skype for business, or every other tool. You'll use the same username password. Why? Because those are centralized username passwords. Okay. So I'm going to integrate that specific LDAP software to my GitHub, to my Git software, so that I can have a better security. And also I also need something called as RBAC. Just because if I give access, I don't expect everyone should have full access on my virtual system. Based on his role, I want to control. So RBAC means role based access control. So once I set up my common username passwords of my company, just because he can log in, I don't want him to do everything. So RBAC means role based access control. Based on his role, I want to give only that much amount of access to the repositories. So this is a feature which is needed for us. And another thing is I want my logging. Logging means I also want to record in a very in a location where what is happening on my Git. What is happening means what all the operations are being performed and what is the health of my Git application, because Git is also an application, right, which you have installed. So if I want to keep track of my health of my application so that I can do regular maintenance on it, and I can also know if there are any problems, right, I need a logging, and that is not currently there. I also need auditing. Auditing means I also need to know who is doing what on my centralized server. If I don't have proper auditing in place, I can never catch a culprit who has somehow done some damage to my important source code. Okay. So then it means that I also need to have a proper auditing in place so that I can track each and every user who is currently logging in. What code is he changing? Is he doing any damage? All those kind of things I should know. Okay. So now let's see how can we work in a centralized version system. How can we push your local to central? Then also how can we collaborate? Okay. Those other two things which are pending. Let us figure them out. Okay. So everybody go to your github.com and get yourself signed up. Okay, so that you can also start working in a centralized. So signing up is very, very simple. Username, email, password. It's far easier than your Facebook guys. Okay. So just to give a username, email, and password, click on sign up. That's done. You don't need to select anything like I agree to terms and conditions. Also, you don't have. Okay. Once you do that, you get an email to your email, and you can click on that email. Then only it will be approved. Okay. Then you can come and log in. So I already have a sign in. I'm going to sign in here. Okay. Guys, Microsoft should be your remote. You should not even think that Microsoft exists today. That should be your part, because the more cloud you go, the more cloud native we become. There are a lot of terms today in the market. Okay, Microsoft has become completely irrelevant today. That is why Microsoft use something called today. Microsoft keeps printing this message on their t-shirts and moving. Okay, the Microsoft prints these t-shirts in their company and they'll be running here and there. Okay, because if Microsoft is not loving Linux, Microsoft would have already been dead, and someone who already bought Microsoft. So this guy did lot of changes internally to ensure that Microsoft was not dead. So that's why Microsoft today doesn't what is if you know one thing, let me tell you one thing. Today .NET is open source, guys. You know that? Yes, PowerShell is also open source. PowerShell is a very simple thing that doesn't matter, but .NET is a huge thing, right? So Microsoft knows that trying to sell a product in the market is no longer a important thing. There are for everything there's a free version now. Okay, so that's why they've changed their company. So Microsoft also now gives a huge importance to Linux operating systems. Okay, so once you log into GitHub, this is going to be the location. So here, instead of github.com, in your organization will be a server name. In whichever server you install the GitHub software, that will be your server name. Okay. Now the next thing is, so you see in the left side called repositories. We had a clarity on what is repository, right? So let us click on create a new repository, and let us name our repository name as customer care. Okay, and click on create repository. This is an empty repository which is created on your central server, and you often you don't get a chance to do this. Okay, you only get a chance to create an empty repository in your central server when you're creating a new application. Most of the time what we do is we push code to the existing repository because already the code would have been there. We are only going to update that code. Okay, so now we have this repository. Now what am I going to do is I need to push my code from my local to the central. Okay, that's how I can ensure my changes at the end of my day are going to be pushed in a central, so that if I go home and if I lose my laptop also, I'm not going to lose my changes. Okay, so that's a very common thing. So okay, so I have logged into my repository. So once you have created an empty repository, what you need to do is now you need to first do one simple activity of telling your local repository where is your central repository located. So obviously what we need now is a location of my central repository. So you can run a simple command git remote -v to find out whether a repository is already added or not. Means first basic thing you should do is first you need to give the location of the central server. So git remote -v will tell you whether it's already configured or not. If it's not configured, let us go ahead and configure git remote add, and it expects you to provide two information. One is give a reference name to your central server, like my central server, your central server, give anything. Okay, it doesn't matter, and it don't need to be same as your team member. Okay, this is only a reference name you're giving yourself on your laptop. Then space and go to your central server and get something called as a repository URL. For every repository on your virtual control system, there is something called as a repository URL, and this repository URL always ends with .git. Okay, so if you see here, if I get this repository URL, what you see is this is my server name, and this is my organization name, and this is my repository name. So my organization name here, I have named myself, but it will be normally your organization name. If you're working Wells Fargo, it will be Wells Fargo, or if you're working JP Morgan, it will be JP Morgan, like that. Okay. And then your repository. A repository name will always reflect the application code which is inside that. If it is a web application or a Alexa app or a Google app or whatever app it is, it's going to be that. It will be ending the .git. Okay. You hit enter and you do again git remote -v. This time I will see that my central will refer to two links. Both the links are same here, and one will be for the fetch operation, one will be for the push operation. So for both operations, it will be the same link. So whatever I do, that operation will be going and performing on this specific location. So once I do this simple operation of setting up my location, you can add any locations. If you want to push to code to one more location, you can put my central -1 or your central or something and add one more location also. But most of the time we don't do that because we only have one central server, right? We don't have two, three copies. So git push now is a command, and what this git push expects two options to it. One is your location. You don't need to give the complete name. You can just give my central, which will operate, and also the branch name. The default branch name is always called as a master branch. Okay. By default, when you create a repository, right, by through git init command, the branch name will be automatically master. There is no control on it. That's a git default behavior. So whenever you initialize a new repository and you create something, there'll be one default branch created and the branch name will be master. And once I hit enter, it will ask me for credentials because this is not a public portal. It is secured with username password. So now you should push the code to my son with your username password only. Okay. You see, if the credentials are correct, then it is going to push the code to the branch called master. And if I go back to my code, if I simply do refresh, I see the code reflecting. See hello world.java, readme. You see this readme.md file, right? What are the contents of readme.md? It will always be printed on the home screen of your repository. That is why I told you the readme.md is a special file. What are the contents of this file will be printed on the home screen of your repository. Okay. You see here, I total have 5 commits here. All the commits I have done. I can see here, I can see my name. I can see my commit history. If you want further information, you'll also see all the things. What were the changes happening on this? Okay, all the things. Who has changed it? What was the time? What is the commit ID? Whatever we see on the command line with the commands here, everything I can see on the UI here. Okay, and how to download or how to get a code is through clone command. So the same repository URL which we earlier did, right? You can click on clone here, copy the repository URL, and whenever you're going to get a new work, right? Now let us talk about the new work. So this is a complete workflow we have seen from end to end. Okay. Now let us talk about a real-time situation. Okay. Now let me go to one more different location. I'll go to, for example, root location. Okay. Now the first thing you should understand is branching. What is branching? Branching means what you can call it as a, if you see here, the first reason why we come into the, see, branching was never in your second generation. Okay, branching was introduced in your third generation version systems, like your git based version system. Okay, so there was no concept of branching in your subversion or your centralized based version systems. So branching means having one more copy of the same code within the same repository. So when you create a branch, right, the same copy of the code will be copy and pasted, and now you have two copies of the code in the same repository. Okay, so that's branching. Why we need to create a branch in the first place is, for example, you are currently working on a release and that is pushed to your production today. Okay, today morning you have pushed into your production. Okay, now once you have pushed into production today morning, which is going to be, for example, today, now what you do right away, you start working on the next release, right? So you started working on new release now. So after 2 days, customers start complaining that there is a problem in your production code, okay, or your the code which is deployed into production. Okay, there is a problem in the production. So if you have not, so what you do is within the next 2 days, you already committed the code to the master repository, right? Because you don't waste 2 days, right? So you have written some amount of code and you have pushed into master. Now there is no copy of my production code currently, so that my developers can go and start troubleshooting. Because if I don't have the copy of the code of production currently, because I already committed with one more commit, for me it is going to be a problem. So what I need to do is, again, I need to download that code. I need to revert the commits what I have done to get the old code and again start comparing my current problem with the code and do all this kind of RCS everything. So this is going to be a huge problem. Okay, so what am I going to do is, when we are doing the development activities, we are never going to push the code to the master branch. What we do is we create a separate branch, okay, and push the untested or unverified code to this branch until we get a sign off to do the production deployment. Okay, what are the advantages here is, it is always mandatory that we should always maintain the current code which is being running in the production in the master, so that before we complete the release cycle of 15 to 20 days, before that any problem comes in, I should have the copy of the code which is always running in the production in a particular location, and that location is called as a master branch. That is why in the Git based projects, when you work, right, people are going to create a lot of branches, and each branch has a little bit meaningful message to it, so that for example, you're working on a Facebook integration, your website, create your branch name as Facebook integration, because you get the freedom to create a branch name. Whatever branch name you're going to create, you can have a branch name of your own choice. So this way I can always ensure that the working code is not disrupted. I'm going to make a separate copy of code and I'm going to experiment there. If I fail this experiment, if I don't understand, again I can make one more branch of my main branch, and again I can continue my development activity. And this is not an optional thing, this is a mandatory thing we should always follow. Never push a code. But somehow a fresher joined and he'll try to run the same command which I ran my local. What this command he'll run, my fresher command, fresher will come and run this command, git push my central to master. It will right away push his changes of my local to the master repository, which I never intended to do. How are you going to safeguard from this is, there is something in your git, something called as the settings. Go to the settings, you see something called as a branches. In the branches you can do something called branch protection rule. So add a branch protection rule. So which branch you want? Right now I want to put on master. Then put, uh, put this require pull request reviews before merging. So I'll explain you what this is security, but I am telling you that, okay, I want someone to review my code before merging. Reviewing my code means there is a human element in this. So before I run this command, if I really want, there should be a human who should approve my push to this. Okay, so if I really want to push my code to master, this should go through something called as a review process before I push my code to the specific branch called master. Other branch you can directly push from your local to central, but for master I am enabling a protection rule. What is the protection rule? Require review before merging, and I'm going to click create. So this way, unfortunate situations like this will be avoided. If I run this command, that command will fail. If there's a branch protection enabled, this command will tell you don't have authority to directly push code to a central. Then how can you do that? So that is what we'll see now. Okay, in a real-time workflow, how are you going to work upon a small requirement, and how you're going to complete the requirement? So these set of rules which you are going to follow to accomplish your Git based activity is called as a Git workflows. Okay, so there are 3 to 4 workflows in the market, but we will learn one specific workflow which as a DevOps engineer we are going to work often. Okay, so the Git workflow is nothing but the set of step-by-step rules we are going to follow to have a consistent mechanism when we are going to share or collaborate code. If you don't have workflow, right, every developer will define his own rules of how to merge code. So that's not a good thing. That is why people came up with something called as a workflow. Workflow nothing but set of standard rules we all follow, which will be consistent on the organization level, so that there won't be any ambiguity on how you are creating a branch, how you are merging a branch, how you are doing all of these operations. So there are 2 important branches which you need to know in the market. One is your feature release workflow, which you are going to right now know, and another one you need to know by yourself is your Git flow workflow. Okay, the Git flow workflow will be used by your developers for complex situations. Okay, but we are not going to handle that situations, because we as a DevOps engineers are going to only write code in a very simple way. So feature release workflow, is it not ideal for developers? Yes, it is ideal, but for small projects, okay, or for your operations teams, it's ideal. For large and complex projects, Git flow workflow is ideal. Okay, so let's see this. Why? Because remember that when I give a task to you, If this task will be completed by single person, then Git feature release workflow is good. If I ask you to write an Ansible automation tomorrow, right, I'm not going to give that work to 3 or 4 people. Already it is only 20 or 30 or 40 lines of code. Do you think I'm going to share that code to 2 or 3 people? No, I'll tell you, you go and write that code. You go and write this code. You don't have relationship. So most of the time, Git flow workflow is ideal for a feature which is being implemented by single person or for small teams. It is ideal. But is it it is having any disadvantages? No, it is a perfect workflow you can use. Okay, let's see an example of a workflow which is nothing but you need to actually follow in an automation when you get a piece of work on how to work and how to complete it. So we are going to use the same commands, but we'll have a certain flow to it. That's all. I'm not going to create any new commands here. All the same commands we used we are going to use, but there's a certain flow to it. We'll follow that. So I'll simply go to root. Okay, so my lead developer or someone has given me a work to do. So what is the first thing I should do is I should get the copy of the code from my central. So if I go back to my code, this is my latest code. Okay, so I'll go to click clone or download, copy, use this button and get the code. So how do you download the code is git clone and give the repository URL. And once you hit enter, it is right away going to download the code from central to local whole folder. And inside this folder, I told you if I do ls -a, you also have the .git folder, means it's going to download the latest code along with the version history. So if you do git log, you also see all the commits which have done earlier and we pushed it central. Okay, so as I told you, you have whatever the version system has, everything you have. Now what is the third step you should do? Third step is create a branch. So git branch space branch name is a branch I can create. So I'll create something called as a Facebook integration. Once you create a branch, what it will actually do is it will copy all the code which is in your master branch and create one more branch. Means there are two copies of code inside your repository now. Okay, how can you see them is through again git only. So git branch -a will tell you on which branch you're currently. I'm currently on my master branch. So these are remote branches. Okay, I'm not on remote branches now. I'm on my it's always local is important for us. Okay, so in my local, earlier it was only one master branch. I created a new branch called Facebook F integration with a simple command called git branch. Now I need to switch from one branch to other branch because the two copies of code are separate, right? If you want to make changes in one branch, first you need to switch to that branch, then make the changes. And any changes you're doing to do on one branch will be retained within that branch. They'll not be applied onto other branches. If you have 10 branches in your repository which are being handled for different projects, if you only update in one branch, the changes will only be retained in that branch only, which will not be propagated to other branches. So let us switch from one branch to other branch with a simple checkout command called checkout space your branch name. Now if I do git branch -a, I see that this star symbol and color has changed to from master to Facebook because I'm currently residing on the Facebook F integration branch. One more way to find out on which branch you are is to git status. It will also tell you you are on branch Facebook F integration. So I have confirmed myself that I switched from one branch to other branch. Now let me update my code. So va hello world.java. Now let me add some code here. So far as code is not relevant, let me write some basic code because the flow is important. I've done a change now. So I need to now do what? If I do git status, it will obviously tell me that the code is modified. I need to add the file to the staging area. Then I need to add the file to the commit added part of Facebook int project. Now git status should show me that it is clear. Now the changes in this are only if you really want to see. I do cat hello world. Now let me switch from this branch to master branch, and if I do cat same file, do you see this change? Do you see the contents of the cat hello world? When I switch from one branch to other branch, the code also will be replaced with the code which is in from that branch. If you do normal ls, the files you see part of one branch will be different files, though the files, because the file name will not change, right? The content of that will change. So the ls will be different list of files. Okay, so in my master still this is only the code, but in my Facebook integration, this is the code. So right now there are two different copies of my code. So since I've enabled my branch protection policy, if I run git commit git push my master, my central and master, it will fail because my branch protection is enabled. So now what I should do, I need to push it to a different branch. So first let us see if my remote -v is configured. Okay, my remote -v is already configured with a name called origin. So git push your location of your server, which is origin, and the branch name. What is the branch name? Facebook -int, right? But ensure that you're on that branch. You can't push a code from which branch. So first let me see whether I'm on which branch. So git status, git branch -v will tell me I'm on my branch master, so I can't push other branch. So let me check out to that branch. Okay, first ensure that you're on a specific branch first. Yes, now I can run my command git push origin and the branch name. What branch name? Facebook -int. It's going to ask for my authentication. Once I do that, it is successfully going to enable me to push a new branch. If I go to my central, if I refresh now, I see that Facebook -int is a new branch which was created. Once you do this part, what you do is you ensure that your code is end-to-end tested from your CI system. Once your code is end-to-end tested, now you're going to raise something called as a pull request, which is a very important term you need to remember. Okay, what does a pull request mean? Pull request mean it's a merge operation which also needs it's a review done by a person. So pull request is nothing but it's a merge operation only. Okay, why do I need to merge is in our organizations as a mandatory practice, we only deploy the code which is in your master branch only to production environment. I can't get any approval in this lifetime or next lifetime to deploy my Facebook integration branch code to my master to my production environment. So mandatorily in our company, we only push the code which is in my master only to the production environment. It means that the code which is in my feature branch needs to be merged with my master. Merging is nothing but applying the changes of this branch onto that branch. Applying changes means, for example, two files are there. In this file, after line 8, 9 and 10 lines are added now. So the two line and 8 and 9 adds will be applied onto that hello.java of my master branch. So it means that I'm going to compare the files. If there is any text missing, I'm going to add that text to the same files. That's called merging. So why I need to merge is I will never get an approval to take this code and deploy into my production. So I obviously need to raise a merge operation to apply my changes of this branch onto the master branch and then take this new merge commit and deploy to production. That's why it's called merge. But a normal merge can be happen. But what does this pull request means is I need a human to review it. Why? Because my fresher can simply, if he tries to merge it again, it's a huge problem for me. I want a proper code to be sent. So I'll do something like I lead developer something. Please approve this. You can call PR to merge Facebook int into the master branch. Okay. Once you click on create pull request, this pull request will send an approval. So you see here currently review required, merging is blocked. Merging can be performed automatically with one approving review. So if I go back to my code now, I have now raised a pull request. So let me think that okay, I am logging in as my as a lead engineer for this project. Okay, so I can see pull request. So I can see that okay, I'm no longer, you can think me as a lead engineer who has more access than this. Okay, because since we have set up what RBAC here, so I have more permissions than my team members. So I'll go this here, and as a lead engineer, I can see that okay, there is one pull request pending for approval. So you can see how many commits were there part of that new branch, and I can also see what files were changed. I see that these 3 lines are added part of this what you call merge operation on the file name hello.java. If you have 20 or 30 files, it will be, you can scroll them down and can see in whichever file what changes were done by that specific developer. So once you see that okay, once you have a clarity that okay, the code is there and everything. Okay, and sometimes you also need to expect to put the test results also. You can also upload here, guys. Okay, you can also upload files also if you want, because you can put the test result cases or email approval, the testing is passed, all those kind of things, artifacts. So the person of your lead developer, he'll think that okay, that everything looks good. He'll click on merge pull request. He'll use his administrative privileges and click on confirm merge. Once merge is confirmed, the changes of your Facebook integration branch will be applied onto the master now, and these are only done before the production list. This is not done every day, guys. Okay, this will only be done once your release is at the end. Once you have a release manager approval, then only it will be done. Until unless your code will reside in your separate branch other than the master, and every time your CA system and the CD system automation will be done on that branch only. Okay, now it is done now. Okay, you see pull request successfully merged and closed. So if I go back to my code now in my hello world.java, which is in my master branch, also has this new code. If I switch to my other branch, switching branches in the UI is very simple. On the branch you can click. So my Facebook integration branch has a this code. Now my master also has this code because I just merged it. So that's how you take the process of following this set of rules to accomplish your activity. Okay, which is called as a feature branch workflow. Okay.
Now I'll tell you about the life cycle of Maven and what are the various phases in Maven. Okay, and we'll do some hands-on exercise of this. Okay, so to begin with, these are the 6 phases of Maven. I'll tell you. Okay, so first phase is validate, then compile, test, package, install. Okay, so what exactly this phase is validate? So see in Maven, what exactly the use of Maven is, it is used to build the application. Okay, build means like suppose some code has been committed, it will pick that code, do the testing and generate a jar or raw file. Okay, so that file can be deployed into the whatever server you want. But in order to do this, Maven has 6 phases. First one is validate. Validate means like, okay, one file is there, form.xml. That you understand this thing like this file is there. So Maven follows whatever is written in form.xml. Okay, so all these sections are written in form.xml, like what should be done, okay, what are the dependencies, what is the version control tool, everything it is written there. I'll show you how it looks like. So in this 4 phases are there. First one is validate. Validate means it will check for all dependencies, whether this project is dependent on any other specific project. Okay, if it's dependent, then it will download the file, download the software in case some software is missing, and automatically it will download the software. Okay, this is what exactly validate do. Okay, second phase is compile. Compile, like I told you, like for development, developers are doing coding, developers do coding, as well as QA people also do code. Okay, in order to prepare test cases, automated test cases. They are writing, they do write scripts and all that. Okay, so what exactly this compile will do? Compile will compile all the code which is present, like which developers have committed. Okay, I think this code is mostly into SRC main directory. I'll show you the path. And QA code is into, I think, SRC test. So what validate will be doing, what compile will be doing, it will compile all the source code present in main directory. And test, compile and test, third, fourth phase, what exactly it would be doing? It will be compiling the code which is present in test directory. That means the one which QA have written, and it will compile, and after that it will execute the unit test case as well. Okay. So this is a 5th phase. 5th phase is package. Package means.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Once the code has been compiled and executed properly, okay, to package in this phase, a jar file would be generated, jar or war file, whatever like customer wants, whatever the requirement of project is, so that file will be generated, okay. And in phase number 6, install this jar file. So the jar file will be deployed into the local repo wherever like developers want to like management would like to deploy that file. It would be deployed in that location. Okay, so it will prepare in the jar war file, and after that it will deploy it into the local repo. These are the 6 phases. Okay, it doesn't matter like in which organization you are working, anywhere you are working. Okay, how complex the project is, if they want that you should deploy the application using Maven, then these 6 are the important phases of Maven which you should keep in mind and you should follow them. Okay. Okay. Now go to the command prompt. You can see my command prompt now. Here you go there. Here you type this command mvn archetype /generate. Okay, this one, and enter. It will take some time. It will be downloading all the files and all that. Okay. Whatever I'm doing. Choose a number. Okay, 4 I'm typing. Then top of group ID is asking, I'm writing form dot my company. Okay guys. Now artifact ID is asking that you type hello world. Okay. Else you'll miss it. Here you type hello world. Enter. The snapshot you leave it blank. Enter. Okay. Value of property also leave blank. Enter. Okay. Now here you type while. That's done. Now what I want to show you. Okay. Just see this path. Build would be generated in this. See users, go to, for me it's Krishna Kumar, for you it would be your name, and copy this hello world project. Okay. C drive, users, here you go to hello world, this entire project you guys copy this. Okay. And once you have copied, after that you go to your C drive. Okay, there you might be having one folder called maven_practice which you have created and paste it here. Okay, now if you go to this folder hello world, guys, for me target folder is there since I have completed all the phases. You guys would be having SRC and POM, right? In SRC you would be having main test. Main means here main code is placed. Whatever developer have done, might have developed some code, okay, have written some code in order to develop the application. So main code would be there, main source code. Okay, and in test, all the source code related to test cases would be there in test. Okay, test folder. Fine. Now sir, open this form.xml. This I told you, like Maven would be behaving on the basis of form.xml. Whatever is written in form.xml, okay, so Maven will work like this. Now open this form.xml. Okay, now guys, you see this. We have given group ID as form.mycompany. What exactly it is? It means that like here instead of form.mycompany you can put anything. Okay. Like what exactly it represents is that this entire project belongs to this particular company. That's the group ID. main mode of group ID. Okay. Okay. Now artifact ID. Artifact ID. See, after we run all these 6 phases, one war file would be coming. Okay. One war file would be generated and it would be named as artifact means nothing, name of the project. That's it. The jar file which will generate for this particular project would be hello world underscore. Version is what exactly the version is. What's the version of this project that we call as version. Okay. Hello world underscore 1.0 hyphen snapshot. And after that underscore what? Guys, packaging. Packaging means what? Okay. What exactly it means? Whether you would like to create. Sir, what exactly war file is that? I told you guys, like whenever we are, when we used to build the application, okay, a file which will be built would be either in jar or it would be either a jar file or war file. So here you can specify that packaging. Whether you would, if you write here jar, then that packaging would be done in jar file. If you write it war, then packaging would be done in war file. Okay. So if you combine this hello world underscore 1.0 underscore war, okay, dot war, this file would be created after running all these steps. I'll show you how exactly it would be done. Okay, guys. Now try to understand what dependency is there. Okay. I told you validate. What exactly it do? Validate this. Okay. So this will be checking for check for all the dependencies, and after that it will try to resolve them. Okay. Where exactly you can find dependencies in form.xml? See, here one section is there for dependency. These are all the dependencies. So in this particular phase, dependency, it will go through all the phases. Okay, I mean to say all the dependency checks and try to resolve them. If like something is not there, it will try to fix it. Okay. Second phase I was telling compile. Okay, and test. What exactly compile do? It will compiling this phase all the code all the code which is present in this folder. SRC main base folder will be compiled. Okay, and this phase like point number 4, test, compile the test cases. Okay, so all the code which is present in test folder would be compiled. Package means prepare jar or war file. In the end, in this particular phase, one new file would be created, which will like new war file would be created, and it would be named as hello world through your artifact ID underscore version number underscore war. I'll show you. Okay. Now let's go to the phases. Download the hello world program. Okay. Now what we will do? Yeah. So everybody do this thing. Come to your command prompt. Okay. Here you go to your folder. CD, what you have written, maven underscore practice. Go to this folder. First of all, you go to this folder. See this. This one. C drive maven underscore practice. Your folder. Okay, let me see where exactly I am there first of all. CWD, I'm disconnected. Go to CD dot dot, then CD dot dot. Okay, now CD maven underscore practice. Your folder, guys. Join this folder. Okay. Tell you one command. Here everybody, now this is the command of mvn underscore verify, okay, which is used to validate the dependencies, this page. This is the command. Everybody go there and write this command. So the mvn verify, that's it. Type mvn verify and enter. For you guys, for me, like because I have already installed, once you write mvn verify, you will be getting build successful, right? So what exactly this command did, mvn verify, okay. I showed you form.xml and there one tag was there called dependency. So this mvn verify, this verified the all that dependency tags, okay. In case some issues are there, something is missing, then it fixed that automatically. So this part is over. Now this part, you would be writing mvn compile. What mvn compile will do? This would be compiling all the code which is present in hello world. This one, main folder. Okay. I am writing now mvn compile. It should get build successful once you compile it. Yeah, done. Build success. Now third step is there for test cases. Okay, for that you need to write ambient test. Okay, so what this command will do, whatever code is present in test folder, it will compile them and it will execute them as well. Okay, now you type ambient test. Now guys, once it is done, now final step is packaging. Packaging means a jar file would be generated, and after that it would be deployed to local repo. Okay, now everybody write ambient package, enter. Now I'll show you where exactly that war file has been generated. This will take some time. We are done. Ambient package is for this phase. Okay, now everybody, you go to your folder, hello world folder. Okay, after that you will see one target folder has been created. Go to this target folder. See, here is the war file. I told you now how exactly it has been created. Hello world -150 -snapshot.war. This war file has been created. Once you write ambient package, in that case, this, if build is successful, this file would be created, and this file naming convention would be combination of this hello world or artifact ID underscore version number dot war. Now see, since war file has been generated, we will deploy it into the local repo of Maven. Okay. Last phase, install. Okay, once jar is ready, if you want to push to remote, first of all, we'll put it into local repo.m2. Okay, for this one command is there, ambient install. Everybody go here, and this is the last step, write ambient install. Enter.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
I'll show you where exactly this file has been deployed. So this war file would be deployed to local repo. So you need to go to this folder to check it out. C users, go to C users. Okay. C users, your name, and here one folder is there. You can see .m2. Everybody would be having. .m2, go to repository, and here one folder would be there, sir, com, my company, hello world, C, snapshot, C. Here is the war file. It has been deployed here. Now packaging it have done, packaging of entire project.
Alright, so why do we need continuous integration? Let's understand this using an example. So imagine yourself being in a company and where there are 3 or more developers who have been asked to add features to an already existing website. Right, so in the beginning you all were given version 1 code and you had to work on this code to add your features. So developer 1 had his features to add, developer 2 had his features to add, and similarly developer 3 had his features to add. Right, so developer 1 added his features and he submitted first, right, and he submitted to the to submit his work. He basically added changes to the version 1 code, not to the version 2 code, right? So his changes in the version 1 code had to be integrated with version 2 code, and only then it would amount to become version 3. And at the same time, testing was also supposed to be done. Once this was integrated, testing was also supposed to be done to see whether the new features who have been added to the website, are they not interfering with the already existing features of the website? Is everything functioning normal? So this was the normal routine, or this is a normal, I would say, the life cycle of a software development methodology, right? So once the bugs have been identified in manual testing, everything was given back to the developer saying that, these are the bugs, please fix them. Now, there were problems in this structure. You would say that this seems perfect, but there are some problems in this structure. Let's understand those problems. So the first thing is that because it took a lot of time in integrating things, and it took a lot of times in manually testing things, developers used to work on 3 or 4 features together, and at once, say twice in a 6 month time or once in a 6 month time, they used to commit their changes or to the source code management system, and then a manual integration was done because such a large code base is there. So a manual integration took a lot of time because there were a lot of features which had to be integrated, and I'm just talking about 3 developers. Imagine in a company when there are 100 plus developers working in the company, right? And everyone is committing to the source code management system. Now integrating that takes a lot of time, and this was a problem. So first you have to integrate that, and of course after that you'll have to test him, and testing was also done manually, which again took a lot of time. And because of a lot of time in manual integration and manual testing, it affected the time when we will give the feedback back to the developer. Now imagine you submit your work to the company, but you have not got the feedback how your work is. And of course, no person is perfect. Every code that goes through the software development lifecycle will have some bugs that we'll have to fix, right? So the developers used to wait for the bugs to come back from the testing team and took a lot of time, and this led to a big gap in the software development lifecycle. It took a lot of time to develop code or to develop applications with respect to the features that were requested from the application, right? And because of this, there was a high risk and uncertainty when you look at it from the business perspective, because you could not pinpoint on a date which would near to the customer expectations. It always took a lot of time to make changes in an already existing application, right? So these were the problems before continuous integration, and we had to solve this time problem that we have so that our release cycles become shorter, our work becomes more accurate, and because of this we came up with continuous integration. So what is continuous integration exactly? So continuous integration is basically the process of having shorter release cycles by creating small features in our code and simultaneously integrating them to our source code management system. But there's a catch: the integration and testing now happens automatically rather than manually, right? And this is why continuous integration is such a hype, and it benefits a lot of organizations, because not only do you have shorter release cycles, that is, your features are going out every day, but also you have automated integrations and automated testing, because of which a lot of time gets saved, right? So how does the time get saved? Let me prove you using an example. So this is a classic scenario of how things happen these days. So you have a developer, the developer finishes his code and he submits his code to the version control system, which is picked up by the continuous integration tool. Now the continuous integration tool automatically deploys it on the testing server, and the testing server automatically has build suites which have been defined for your application. It tests all the features of the application automatically, and if there are any bugs which are identified, probably a test case failed or something like that, it gives that feedback to the developer, and all of this happens in a matter of minutes, right? That's how fast it is. Now imagine yourself in the earlier world when I told you it took a lot of time to manually integrate things, to manually test things. So you used to get feedback in days, if not hours. And in this case, that is today, you get automatic feedback in a matter of minutes. And this has led us to improve our release cycles in such a way that today we are getting releases, 2 or 3 releases in a day. Earlier, we used to have releases twice or thrice a year, and now we have 2 or 3 releases every day. Obviously, it's shorter releases, shorter features, but that's how powerful our software development lifecycle has become with the use of continuous integration. And it does not stop here, right? With more mature continuous integration or with more mature DevOps model, what happens is if your test succeeds, it is automatically also pushed on to production, right? And this is the power of continuous integration. Now obviously continuous integration is just a concept. If you want to implement it, it will be implemented using some tools. So we're going to discuss that in a few moments, but before that, let us summarize what we just discussed, right? So the advantages of continuous integration include frequent commits and hence small feature updates to our website, but every day or every twice or thrice a week, right? We have automated build and testing that saves a lot of time. It gives the feedback instantly to the developer, and also because of this there's a low risk and faster delivery of products when you look at it from the business perspective. Right now, like I was saying, that all of this is possible using continuous integration, but continuous integration itself is just a concept, right? It can be implemented using hardcore tools, and we're going to discuss that in a few moments. So continuous integration is the topic for today, and the continuous integration tool that we're going to discuss today is Jenkins. Now, Jenkins is an open source tool which is basically used for continuous integration. It is based on Java, and a lot of companies are working on Jenkins to get their day-to-day work in the DevOps lifecycle done. Right? So this is a brief introduction about Jenkins, and I already told you the features of continuous integration are all of them pertain to what Jenkins can do in your life, right? So without wasting any time, let's go ahead and start with Jenkins by first installing it on your system. So how can you set up Jenkins on your computer? Now, there are a set of commands that you would need to run on your Linux box that would set up Jenkins, but there are 2 or 3 ways you can install Jenkins with. If you have Docker installed on your system and you are just into testing, you can have Jenkins installed in a Docker container. So with that, you do not have to set up your environment with Java. You do not have to go through the process of downloading things. Just download that container, and that would have Jenkins up and running on your system, right? But this is a bare metal installation that I'm going to show you guys. So let me just switch back to my server that I've deployed on AWS to see how you can deploy a server on Jenkins. Alright guys, so this is how my AWS server looks like. So what I have to do is I have all the commands written over here in my notepad. So let me copy these commands. The first command will basically install OpenJDK 8 on my system. So let me do that. Okay, so it's unable to update. Reason is we haven't updated. So let me update the system first. Sudo apt-get update, and once that is done, I'll install OpenJDK 8. Alright, so now it's installing OpenJDK 8. Next step would be to copy this command. This will basically add the Jenkins key in the repository. So let us do that. Alright, so this is done. The next step would be to install this command. Alright. So this is our next command. This would basically add the binary of Jenkins to this list. And now we're going to update. So our repository links gets updated. And now let's install Jenkins. Alright guys, so Jenkins is installed. So first of all, let's check the status for our Jenkins service. So for that, we can check it using service Jenkins status. Alright, so the Jenkins service is active. So our next step would be to open the ports of the EC2 server. So let us do that. So the inbound connections. Let's open all traffic to be on the safer side. If you want to be more secure, kindly open port 8080 because that is what Jenkins operates on. Alright, and let me click on save. Alright, so this is done. So now what I'm going to do is I'm going to come back to my dashboard. This is my Jenkins master. Let me copy the IP address, and this IP address I'm going to use with the port 8080 to open Jenkins. So as you can see, the Jenkins dashboard is now visible. So the first time you install Jenkins, you'll have to enter the administrator password, which can be obtained from this path. So what I'm going to do is I'm going to go to this path and I'm going to cat over there. So this will basically, so let me do a sudo. So this will basically give me the password, and let's copy it and paste it over here. Continue. And now Jenkins is booting up. So the first screen that you would see is customize Jenkins. So let's install this tested plugins. This would basically install all the plugins that we would require for today's session. So once you've clicked over there, your plugins will start to install. And we're going to wait a while till this finishes. All right, our next screen is going to ask us for adding a user. So let us do that. Let's give the username as Intellipaat, password as Intellipaat. Once you've filled out all the details, let's click on save and finish. And this would bring you to your Jenkins dashboard. So you would get the Jenkins is ready page and just click on start using Jenkins. All right, so this is how your Jenkins dashboard looks like. And we're going to come back to this. But before that, let's just go back to our slides. All right, so guys, we've successfully installed Jenkins on our system. Our next topic would be to understand the Jenkins master slave architecture. All right, how does Jenkins work in the production environment is what we're going to discuss over here. So the Jenkins master slave architecture is basically important to accomplish continuous integration. Reason being, your testing will always happen on the testing server, and your production code will always be deployed on the production server, right? So you always have to deal with multiple machines when you're working in a DevOps environment, and that is exactly why you need Jenkins master slave. So for in this kind of situation where you have to deploy your code to the testing server, Jenkins becomes your master server and your testing server becomes your slave server for Jenkins, right? Similarly, your production server would become slave server for Jenkins, and the master Jenkins will only have the Jenkins installation. Jenkins will not have to be installed on any of the other systems which are serving as the slave of Jenkins, right? The third thing is, why do we need a master slave kind of scenario? So I've seen a lot of people basically just use Jenkins on the same computer where they have to deploy the code as well, and that is because they are not dealing with probably parallel jobs of deployment, or they're not dealing with complex builds, and that's the reason they have it on the same machine. But when you're working on the production environment, you have to have a master slave kind of an architecture wherein the testing and the production server would become slave for your Jenkins master. All right, so now what we're going to do is we are going to set up master slave on AWS, and let's see how we can do that. All right, so the first thing that we have to do is deploy two servers on AWS, that is slave 1 and slave 2, and then we connect it to Jenkins using the JNLP connection. So let's see how we can do that. So the first thing that I'm going to do is let me jump onto my EC2 management console and let me create two slaves. By specifying the number over here, that is 2. So we're going to launch the instances. So our instances are launched. Let us rename them as slave 1.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And we have our other, which is slave 2. Now, mind you guys, we will not be installing Jenkins on either slave 1 or slave 2. We will be controlling these slaves through the Jenkins master. Now, there are some settings that you'll have to do in your Jenkins master. Let us go through that. So the first thing, so this is your dashboard. So the first thing that you have to do is you'll have to go to click on Jenkins and go to manage Jenkins, go to configure global security. Once you're here, just scroll down and you will reach this section which talks about agents. Now over here we are talking about TCP port for JNLP agents. Just change this to random and click on save. Once you've clicked on saves, now we will go to manage nodes, and now we will add a new node. Let's name this node as slave1. And now click on permanent agent and click on OK. Now over here, you will have to add the launch method. You'll have to change it to launch agent via Java Web Start. And the current working directory path, specify that to /home/ubuntu and /jenkins. All right, just specify this and click on save. You will reach this screen. So I'll tell you what to do after this. For now, let's add one more new node. Let's name it as slave2, and we'll copy everything from slave1 and click on OK. All right, so everything is the same. So the remote root directory would be this /home/ubuntu and then Jenkins. All right, so slave2 is also configured. Let us check what we can do now. All right, so the next thing that you have to do is now click on slave1 and download the agent.jar by clicking over here. All right, so your agent.jar is now downloading. I had one before, so just ignore this thing. So this agent.jar is now downloading, and now I'll have to send this file to my slave1 server, and I'll show you how you can do that. Right, for now, just click on show in folder, remove the older agent, rename this as agent. All right, and now we'll have to send this to our slave1, and the way we can do that is by first selecting slave1, take the IP address from over here. You'll have to download a client called FileZilla. Just open that. In FileZilla, paste the IP address over here. Username would be Ubuntu for the Ubuntu operating system. Port is 22. And in the settings, you'll have to click on edit and then click on settings. Go to SFTP and you'll have to add the key file over here. I've already added that. Just click on add key file. Just go to your key file, select that, click on open, and it'll be added over here. This is important to connect because when you're connecting to AWS, the only method that you can connect to is using your PEM file or your PPK file, and this is the way you can add it in your FileZilla browser. All right. So once you have added that, just click on Quick Connect, and now you will be connecting to your slave1. So once you're connected, you will be given all the directories. So here are all the directories. Now I'll have to copy my agent.jar on my slave1. So just click here and it'll copy your file to slave1. Okay, so let us also verify that if our slave1 has been copied or not. So let us connect to our slave1. So we'll connect it using this IP address. Let us go to putty, click on new session, connect to slave1, and let us give a special appearance to this. Let us decide a color on this. So let us decide the orange color. So the orange color is slave1. So let's click on OK and let's click on open. All right, so login as Ubuntu. Great. So now if I do an ls, I can see that agent.jar has been successfully copied. All right, so slave1 is done. Now we'll have to do the same thing for slave2. So let us go to slave2, download the agent.jar. While it's downloading, just copy the IP address for slave2, enter it in FileZilla so that we can connect to it. All right, click on Quick Connect. So you will have the directory listed over here. All right, now we'll go here and we'll rename our agent1.jar to agent.jar, and the way we can do that is like this. So we'll just go here, rename this, right? Remove the older agent file and rename this to agent.jar. Once that is done, just drag and drop it on the server. And now let's connect to slave 2 using putty. So let's click on new session, SSH, add the file, and let us keep the color for this slave as white itself. All right. So this is slave 2. And if I do an ls over here, it's the agent.jar file has been copied successfully. All right. So now the next step would be to basically go to your slave, and you'll have to execute this particular command at the place where your agent.jar is present. All right. But before executing this command, we'll have to install OpenJDK on both these servers, that is slave 2 and slave 1. So let us do that. So here's the OpenJDK command. Let us pass it over here. So we'll have to update the server first. So let us update it. All right. And now let's pass the command. All right. So while Java is being installed over here, let's do the same for our slave 1 as well. So let's update it first. So it's updated, and now let's install OpenJDK. All right. So while Java is being installed on this, I think we are almost done on our slave 2. All right. So slave 2, the Java is installed. So what I can do now is I can go to my Jenkins page and go to slave 2, and I can run this command over there now. And this is it. The moment you run this command, can you see it says connected? And the moment it says connected, just come back here, refresh the page, and your slave 2 is now connected. Let's do the same with our slave 1. Just copy this command, go to your slave 1, let's clear the screen, and paste this command. All right. So now both the slaves are connected to your AWS Jenkins server, and you're set. So if you see the nodes, you have a master now, you have slave 1, and you have slave 2. And this is what we were supposed to do. So let me come back to my slides. All right. So we have successfully set up Jenkins master slave on AWS. Our next task is to basically create a pipeline which would be triggered by Git webhook to deploy a project on Jenkins. So let us do that. So for that, these are the steps that we'll have to do. So basically we have a project. I've created a project on my GitHub repository. Now this project has a Docker file, and this Docker file can be built to basically deploy a website on Docker. All right. So we're going to deploy a website on our slave 1 first, which will basically act as our testing server. It will be pseudo testing kind of a thing, right? And if our website is successfully deployed on our test server, that is slave 1, it will then get deployed on slave 2, which will be our production server. So this is basically our job, and this should happen automatically. So a Git webhook basically means that the moment I commit on Git, it should automatically trigger a job on Jenkins. It should automatically deploy the website on my website on my testing server first. If it gets deployed successfully, then it should move forward and deploy the same on my production server. All right, so this is what we are going to do. So let us quickly go to our GitHub website to see how our code looks like. So basically, this is my code, guys. I have the Docker file, I have the website in here. Docker Compose, please ignore it. We're not going to use it. So we're going to use the Docker file. The Docker file code looks something like this. So basically, this is a container which it's going to pull. And after pulling the container, it is going to add the DevOps IQ folder inside the var www html DevOps IQ directory. This is inside the container. All right, so this will get deployed inside my server once I trigger it from Jenkins. Now to do this, first we have to install Jenkins on both the slaves as it is mentioned in the steps. And like it says, like we'll have to configure it in a way that if the build on Jenkins slave 1 is successful, then it should be built on slave 2. Once it's done, we should finally trigger the job using get webhooks. All right, so let's do this, guys. Let's go ahead and start with the demo so that let's see how it can be done. All right, so the first thing that we're going to do is install Docker on both the slaves. So let us go to our putty terminal. Let's go to slave 1 first. Now remember, guys, you will have the connected state over here. Do not close this terminal, otherwise your connection will stop. So what I'll do is I'll just minimize it and I'll duplicate the session so that I can work in a different terminal. All right, so the first thing that we have to do is install Docker. So let's do that. Sudo apt get install docker.io. Okay. So Docker will start installing now. So while Docker is installing over here, let us do the same on slave 2. So just duplicate the session and go to Ubuntu. Now install Docker. All right, so Docker is being installed on slave 2. It has installed on slave 1. Let us check. So docker ---- version, if we can do that, that means Docker is installed. Yes, so Docker is installed on slave 1 and is installed on slave 2 as well. Let's check. So sudo apt sudo docker version. Okay, so Docker is installed on slave 2 as well. Awesome. So our first job is done. We had to install Docker. Now our next job is to configure Jenkins to build the project on slave 1. If successful, should be built on slave 2. So for this, we will have to go to Jenkins. So Jenkins is over here and we'll have to create a job. All right. Now you can check the status of your slaves over here. So you can see that master is idle, slave is also idle, and slave 2 is also idle. Now first, let's create a job for our slave 1. So our slave 1 basically will have a freestyle project, and let us name slave 1's job as slave 1. So or let's name it as test. Okay. And then click on OK. All right, so the job has been created. Now the first thing that we had to do was to copy our code to the workspace. So let's just clone our repository or mention the repository link over here and by clicking GitHub project. Okay, and then go to source code management, click on Git and mention your repository over here as well. Now because this job has to run on slave 1, we'll have to restrict where this project can be run and select slave 1, right? So slave 1 is job, and say slave 1, once you select slave 1, this job will only run on slave 1. Okay, once you have done with that, the next thing that you would have to do is come down and click on add build step. But before doing this, let us check if my job is being built or my workspace is being populated by the Git repository content if I build this job on slave 1, right? So this would basically test our connection as well. So let's do that. So let me click on build now, and this will basically start a build wherein it will copy the Git content on slave 1 ideally, right? So the blue ball basically tells us that the job has completed successfully. So let us click over here, and I can see that it has been successfully been finished. So let us verify that. Let's go to slave 1, and if I do an ls over here, great. So I can see the workspace is there. Let me go inside workspace. All right, so inside workspace, let us see what do we have. We have test. So this is the job name. Awesome. So if you go inside test, do we have the git repositories content? Yes, we do. All right, so my git repository was successfully cloned into the test job. That basically means from my master, I'm able to build a job on the slave 1 node, which is great. So that basically means our connection is working fine. Awesome. So let's go ahead and go back to configuring our job, right? So what we want to do is we want to deploy the website which is mentioned over here in this repository to my project. Now the way to do that is by running this Docker file, right? For running this Docker file, I'll have to check what is the present working directory. So my present working directory is this. So let us copy this. And once you come back to Jenkins, you'll have to scroll down and click on add build step. Once you click on add build step, click on execute shell. What will execute shell do? So execute shell is basically used to run any commands that you want to run on the terminal of the other machine that you're trying to build on Jenkins, right? For example, we are trying to build on slave 1 from Jenkins. So what commands do we want to run over there? So I want to run docker build command. So I say docker build, and then docker build, and then the repository where the docker file is, so it's over here, and then the name of the image that I want to give. So the name of the image would be, say I want to say it's test. Okay, so this is the image name. Once the image is built, I'll have to run it. So let's run it on port 80. No, so let's run it on port 82, and then let's run the image like this. So this is the command for running the Docker image that you have just built, right? Once it's built, the next step would be to check whether it's there or not. We can do that on the browser. And I forgot one thing, I'll have to add sudo. And because this job can be built time and again, what we'll have to do is we'll have to remove the older containers which are running on the system, right? So for doing that, I can say that sudo docker rm -f, and for removing all the containers which are running, I'll have to pass in sudo docker ps -a and -q. This should delete all the containers which are running inside my slave 1. Now to check if my docker file is building my containers or not, what we can do is we can simply copy the commands from over here. So the first thing that I want to do is I want to build it. Let's build my docker file. So the file is now being built. Awesome, so it's been built. The next thing that I want to do is I want to check if I want to run this command, right? So for running it, the command is this. Let's copy it, paste it over here, hit enter, and my container is now running. So I'll have to check that if it's running or not. So I'll go to slave 1, copy this, paste it over here. So, and port number is 82. So I can see the Apache page. That means the container is working. Let's check if our files are being showed or not. So if I go to DevOps IQ folder, yes, I can see the website. So means these commands are running fine. But what I have to do is I have to check if it's running through Docker or not. So I have configured the commands over here, and these commands work on the terminal. They should work over here as well, right? So let us go ahead and save this. Okay, so our job has been saved, and the next thing that I would do is let me remove all the containers which are running over here. So for that, I'll have to do sudo docker ps. Let me remove this container. So the container is removed. Now let's go ahead and run this container, run this job. All right, so now let's go ahead to our Jenkins dashboard and let's build the project now to see if everything goes fine. So I've clicked on build now. All right, so it gives me a failed build. Let's see what the problem is. So the problem is over here. It says the first command sudo docker ps -a-q docker I'm require at least one argument. Okay, so I've got the problem. So the problem is there's no container running over here as of now, right? And that's why it is not able to remove any container, and that's why it is giving me this error. Okay, to solve this, what we can do is, for now, let's, in the configure part, let us just remove this line, or what we can do is we can start a container over there, right? So let's run any arbitrary container, docker run -it -d and then ubuntu. Let's run it so that there's a container running, because ideally there will be one container running at least on my system. So let's click on save, and now let's try to build the project. Okay, so the build has gone successful. Okay, for checking that, I'll say let's just refresh this, and yes, my website is being deployed over here. Awesome. So let me just do it one more time so I'm sure it's working. So let me just do a docker ps sudo docker ps, and let's remove this sudo docker rm-f, remove this, and now let's run our arbitrary container. Let's ensure that this website is now not working. So it's not working. Now let's build this project. All right, so now if I come here and I refresh this, yes, so the website is working successfully. Awesome. So it works on slave 1. Let us now configure the same thing in slave 2 as well, right? So let's come back to our dashboard. So the test job, this could be our arbitrary test job. So basically we are trying to deploy it on a server. If it gets deployed successfully, we are going to deploy it on the prod as well. So let's create a new job and let's name it as prod freestyle project. Click OK, and the GitHub project is going to be the same, this one. Let's paste the URL over here, and we have to restrict this to run on slave 2. Great. The source code management is this Git repository. And the build step also would be the same. So basically we want to delete all the containers which are running right now. So for that, it's sudo docker rm-f $docker ps-a and -q. Okay, next step is to build the file. So do sudo docker run -it -p, and we want to run it on port 80 because it's production, right? And the image name is test -d and test. And before this, we forgot one command, which was sudo docker build, and then the directory, which is /home /ubuntu /workspace / the job name, which is prod, and then over here the docker file would be present, and I want to name it as say production. The container name would be production, and over here also the container name would be production. Awesome. So let's click on save, and let's now try to build it. But before that, we'll have to launch one container on test. So let's run an arbitrary container. All right. So container is ready. Now let's check by clicking on build now if this job is working fine. So I've clicked on build now, and if you want to see the console output, we can see it over here. Okay, so it says job failed, and the reason for that is got permission denied. Okay, so the problem is I forgot to add sudo. So let's add sudo. Let's add sudo over here, and that should be it. Let's click on save, and let's try it again. Okay, again we have a problem, but I think it's a new error, so let us try to resolve that. So it's unable to prepare context, and the path is /home/ubuntu workspace and prod not found. Okay, so let's check if this path exists. So if we do an ls, we have Jenkins. Okay, let's go inside Jenkins. If we do an ls, okay, so workspace is over here. So basically I'll have to change the path to /home/ubuntu/Jenkins/workspace/prod-t and then production. Click on save. Let me check if there is a container running on my slave 2. If there is no container running, then I'll have to run one. So sudo docker run -it-d ubuntu. Okay, container is running, and let us also ensure that we do not have any website running on our slave 2. Okay, so this is the command that we are getting right. This is the output that we're getting right now. All right, so let's click on build now, and let's see if our build is successful. All right, so it's getting built. Let's hope for the best. Let's hope it's successful. All right, so it gives us a blue sign. Blue means that build was successful. Let's try to refresh over here. And yes, it works. Now let's just go to DevOps IQ folder and see if our website is up and running. Yes, so our website is up and running. Awesome, guys. Now what I want to do is I want to trigger. So first I want to trigger prod job only when the test job is completed. Now let's see how we can do that. So we'll go to configure, and let's see if we can configure this. All right, so I'll have to go to test job actually. Let's go to the test job. Let's go to configure, and over here I'll have to go to add post build actions. Okay, let's click on that, and after this we'll say build other projects. Click on that, and which project to build? I want to build prod, and trigger it only if the build is stable. So if the build passes, only then it should start with prod. Okay, awesome, great. So let's click on save, and if my test gets succeeded, then my prod job will run. All right, so let us check this as well. So let me try running it. So we can run the test job using a pipeline view as well. So if you just have to come back to the dashboard, and over here you'll find both your jobs. Just click on the plus sign that you see over here, and once you click on the plus sign, you should be seeing a build pipeline view option over here. If you're not, So that means the plugin is not installed. So let's install that plugin. For that, you have to click here, go to Manage Jenkins, and then click on Manage Plugins. Click on Available, and then search for Build Pipeline.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Build Pipeline, select it, and then install without restart. Just click on that. All right, and now your plugin will start to install on your Jenkins server. All right, so my build pipeline plugin is installed. Let us go back to our dashboard, click on the plus sign, and you can see there's an option now which says build pipeline view. Select that and name this view as CI/CD or anything that you want, right? Click on OK. All right.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Everything seems fine over here. Build pipeline view title, let's name it as CI/CD. Okay, let's click on OK. All right, let's check. So in my CI/CD view, I just see the prod job. So let's see how we can fix that. So I want the test job to also be there. So let's see. So let's click on configure and build other projects after the test is done. Okay. Okay, so we forgot to choose the initial job. So the initial job will be test, right? And let's click on OK. Okay, so now it looks good. So the test job will be executed, and then we'll have the prod job executing. Okay, let's try running these jobs by clicking on run. All right, so as we can see, our test job started and then our prod job started and it completed. So this completed in 1.5 seconds and this completed in 1.5 seconds as well. And both of these have these websites. Awesome. Now what I want to do is I want the moment I commit on my GitHub, this should trigger my Jenkins job. So for doing that, let's go over here. That is my Jenkins dashboard. And let's try doing that with test. Okay, so we'll click on test and we'll click on configure. All right, and yes, so in the build triggers option, just go to GitHub hook trigger for git SEM polling. All right, and just click on save. The moment that's done, just come back here on your GitHub. So for configuring your webhook, all you have to do is click on settings and click on settings, go to webhooks. Inside webhooks, click on add webhook, and now just copy the IP address and port number of your Jenkins dashboard or your Jenkins page and paste it over here slash github hyphen webhook. Specify that and click on add webhook. If the response is received by Git and everything works fine, it will give you a tick, which means everything is working fine, right? And just go back to your dashboard and you can see that everything works out. Great. Now, what we have to do now is we'll have to push a commit on GitHub, and that will automatically trigger a build over here. So let us check that. So we'll just open this over here and we'll go on our master. Let us trigger a build. So this build can be triggered from anywhere. I'm just doing it on master for the sake of simplicity. So I'll just do a git clone of your repository. Git clone. All right, everything is done. Now I have something on my I have a website, right? So what I'll do is I'll change the contents of that website and let's see if that content is visible on our servers as well. So I'll just change the index file. The first thing that I'm going to change is the title. So I'll change this as Jenkins prod website. Okay. And let us change the image as well. So I have one more image over there. So let's name the image as 2jpeg. Great. So now let's push this on Docker Hub. So let's add it, commit it. All right. And let's push it now. Git push origin master, the username and the password. All right. So the push has been made. Let's check if anything is triggered over here. So as you can see, the test got triggered and now the prod also got triggered. So both the jobs have been successfully completed just on a push. Let's verify that. So this is my, so let me see which one is my slave one. So slave one is 108. So let us see. Okay, so this is my slave one. Let us refresh this and see which website is coming. As you can see, the background got changed and as well as the title also got changed. Similarly, if this job is successful, it should also be triggered over here. Let us check if the website is also pushed here, and yes. So the job is also pushed here. Awesome. So let us try this one more time. And with this, let us try to bring back the same background that we had, right? So let's do a nano on index.html and let's change the title to Jenkins final website, and let's change the image name to 1.jpg, which was the earlier image. Save it. Now let's push it on GitHub. So we'll add it, commit it, and now let's push it. All right, so our code is now being pushed. It's been pushed. Now let's come here and see what is happening. So our job should now be running. So test got completed. Prod is being completed. So prod is running right now. And prod also got completed successfully. Awesome. So let's check if our website got changed over here. So this is my testing server. So the title got changed and even the background. Let's see for our production, and even our production website got changed. So awesome guys, we have successfully completed what was asked to us in the hands-on. So we were supposed to create a Jenkins pipeline, which would basically, if slave one job is complete, it should be built on slave two. and the job should be triggered by a Git webhook, and that we have done successfully. Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else, right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in argue that why don't we use VMs in this case. Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution, but the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it will become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now, it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So, what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM, wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute. Right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now, once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you have installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container. Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that is it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay. So if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software. And on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries. And on these, you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay. So this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Right. So because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, you again, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So, in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually, when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we have, we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right, so guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right, now let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. All right. So if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It will install Compose. It will install the Docker software. It will install the other components of Docker. So you don't have to worry about what component is what. But basically, just go to this particular link, download the Docker software, and once you have the Docker software, just come back to this CLI and this just pass the command Docker version, and if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the Putty software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. All right, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker -version.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stand for? A. Development and operations.
B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And as you can see that the Docker version is 18.061 CE and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. All right. So we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on so that you get the maximum knowledge possible from this session. All right. So the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. All right. So basically, this is how this is the whole life cycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a life cycle state that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right, so this is the first command that we can try out when we are working on Docker. All right, so whenever you want to find out what version of Docker that you're working on, you can simply pass this command docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull, so that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command docker version, you get the Docker version, the current Docker version that is installed on your system, along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right. So what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull Ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull Ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that, so sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is hyphen IT, which basically means make the terminal interactive. Hyphen D, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what hyphen D does, right? So the command would be sudo docker hyphen IT. IT means make the container interactive in the terminal so that I can also pass in commands. Hyphen D, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run hyphen it hyphen d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then hyphen a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
All right, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. All right. Okay, now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right, moving forward. Now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID, because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step means? So this step basically means that if I am on my system and say, I run my Docker command, say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is, let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is, I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is, whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container, and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now, right? I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID, so I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right, so with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right, and now I can run a container on the image test, and all I have to do is sudo docker run -it-d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, says just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right, so this is the shortcut that you can use while working with Docker. All right, so my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right, so my container is now running. The next thing that I have to do is install Apache server on this container. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. All right, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. The service Apache 2 start hit enter. And if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now and let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshar/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, that is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So on containers port 80 Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container, this is the command to do that. -p space port number that you want to specify, the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that Apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. Alright, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container and that software is able to access on the browser using the port that you mapped on the container. All right, so our um, for our verification, what I'll do is sudo docker ps and I'm gonna stop this container now. So sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being I've stopped the container over here. All right, and this is how you can save changes to a container, install software and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/Apache. This was the image name, right? That we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page and you can see this is the image that I just pushed to the repository, which is hshar/Apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container, and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker hub. This is what we have learned. Now, the next step is, what is a Docker file? So, a little introduction about a Docker file. So, you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, when you're working in a production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Docker file, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Docker file is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Docker file. Now, a Docker file is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Docker file that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a Docker file. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Docker file. Now, the first line of a Docker file is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Docker file, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area of your presentation will basically tell you the Docker file content. So this is exactly how the content of the Docker file should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt get update and apt get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Docker file, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt get update, and the second is apt get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Docker file, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. All right. And these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker and hyphen command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the docker file, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we are doing is, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service apache to start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd apache ctl -d foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the apache ctl -d foreground with the entry point command. Alright, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case, I specified a variable name which has the value DevOps Intellipaat. Alright, so these are some of the commands that you can use to create a docker file. Now let us create this docker file on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then docker file. So let me just create a directory first. So let me create a directory called docker file itself. So mkdir docker file. Let us go inside it. So cd docker file, and now whenever you are creating a docker file, the name of the file always has to be docker file itself, right? So I'll specify nano and then docker file. We went inside. So the first thing that we want to do is we want the ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file, right? Once we have done that, the next step would be to run Apache in the foreground, that is run it. So Apache CTL -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html, and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file, and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -a-n-g, and then docker, and then $user. Enter, and now all I have to do is just re-login into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Docker file. Okay, and now I want to build this Docker file. So docker build dot -t new underscore Docker file. So you can see the Docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Docker file. So let us run this new underscore Docker file. Docker run -it-d. Also let us specify the port number. So let us open it at port 84, and then -d new underscore Docker file, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container on route. So we named it as one.html. And yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my Docker file. So the first thing that we did was apt-get update, apt-get -y install Apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the one.html file has been added, and at the same time docker file was also added. So inside the directory we had these two files, right? One.html and docker file. So both of these were added inside the container. Now to not have docker file inside your container, what you can do is, instead of dot, specify dot slash and one.html. That would solve this problem. It would only add one.html in the container. Okay, so it added one.html, and index.html is basically the default page of Apache that you see, right? So we added one.html, so this was added by the Docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Docker file. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Docker file in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Docker file directory, right? So what I can do is I can map this Docker file directory inside a container. Now to mount this particular Docker file folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
home /ubuntu /docker file. Now this is the location of my folder, and then what is the mount point of inside my container? So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. Alright, so this is called bind mount. But there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container. Right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home /ubuntu /docker file is not going to exist, and that is where it is going to give you an error and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system, it will be a little different. For Windows, it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now, what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount, it is a little difficult to basically migrate the data. In volumes, it is very easy. You just take the volume up, and then just put it on some other system and it will work. But in case of bind mounts, you'll have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right. So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay. So this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount. Source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d, and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session. And what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between
two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new underscore docker file. Okay, so what I'm gonna do is I'm gonna launch docker run hyphen it, and then source say is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm gonna do is I'm gonna launch docker run hyphen it, and then hyphen mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this hyphen d new underscore docker file. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec hyphen it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache, and target would be say /app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var /www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory. Okay, and what I do is I create nano do.html. I create a file, and then I specify that html body h1. This is the new html file. Close the header, close the body, close the html, come out. Okay, now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp /2.html and then /var /www/html and then the container id. /var /www/html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container. docker rm -f delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to apache, target is equal to /var/www/html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d, and then the image name new underscore docker file. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address but on page 82, you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the docker file, right? For volume, we have it attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome guys, we have successfully understood what docker volumes are, and I'm sure that you guys have also understood. If there are any doubts guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first, let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen? That if I want to change code in notifications, I will have to pull the whole code base. I have to pull the whole code base. I will have to go to the notifications file and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now, Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base, even if you had to change the minimest thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the module, so all of these small things like notifications, mail, payments, passenger management, customers, or these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. All of your modules that you're defining, all of the features that you have defined, have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now, to solve this, we came up with a microservices architecture. Now, what is a microservices architecture? Each and every module, that is a customer services function, or the notifications function, or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab, right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through uh, probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say we our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab, because booking of cab is no way related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down, right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs wherein values are separated by commas. In JSON you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that all he has to know. And of course the code of his own function as well, right? And of course, if he makes any changes, and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservice which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we were to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker Run, or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers, that is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now, a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end. And of course, you'll have to configure the DB password and everything inside the container as well, right? Now, one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it, and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now, this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3. And there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we are trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself, right? So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress, and that to the latest version. The ports that we want to expose, so inside the container, the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables, we specify that the WordPress DB host is DB:3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay, and what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file, that there's a volume which is being created, which is called DB data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you, that Docker Compose is not present. So Docker Compose version.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for it, for the file which has just been downloaded, to be converted into an executable file. And that's it. And now if I run docker compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file for, so let me first create a directory. So it would be compose. Let's get inside compose. And now let's create a YAML file for WordPress dot YAML. Okay. And if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command docker compose, for basically running your Docker Compose YAML file, the command is docker compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well, password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. this is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Right? So a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. Alright, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine which can automatically repair containers, but what happens if the machine goes down, right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is docker swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log into this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. And let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter, and you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that there I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now, as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say -- force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker and it'll work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. So specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So alright, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine, and once everything is running great, it'll exit. So now if you want to see what all services are running on your Swarm cluster, all you have to do is say docker swarm service ls, docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto-scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it will basically scale down to only 2 replicas. Now if I do a service ps docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. Alright, so this is how you can deploy an application on Docker Swarm.
Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically if you want to install any type of or any set of configuration on any node or any group of nodes, The way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now, there are some key features of Puppet which we are going to discuss next. So, what makes Puppet so special? Why is Puppet so popular? So, the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically, it is a tried and tested tool which helps every company in its configuration management needs, right? So Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it. The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet, there are a lot of people who are enthusiasts, right, who are not being paid, they're just doing it because they love, working on.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or they love the profession and they love working on this tool which is Puppet, right? And out of that love, they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore, this is a key feature of Puppet, that there's a large open source community for Puppet which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website, right? So if you don't understand Puppet, you don't have to take help from your colleague, you don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software, okay? And the fourth thing, which we have already discussed but is very crucial for its success, is platform support, right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that, right? So these were some of the key features of Puppet, why Puppet is so popular, right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into how Puppet actually works, or getting our hands onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master-slave architecture. So there is one master and there could be numerous slaves which are being served by the master, right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave, right? So the way Puppet works is So first, the slave basically sends its state to the master, right? So when the master slave architecture is set up and everything is set, if there is any change on the master or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master, and what master does is it checks whether the state sent by the slave is what is required from the slave or not, right? So there is a state for that particular slave which is defined on the master, right? So it checks against a state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to the slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself, right? So the Puppet agent then installs all these tools on itself or on the Puppet slave, and once it installs everything, it sends back a report to the master saying that everything has been installed. Please check whether your requirements are now being met with my state or my metadata which I'm sending it to you, right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests, right? So this is a 3-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted, and it is encrypted using SSL certificates, right? So there's an SSL connection which is established between the Puppet master and the Puppet slave, and the way it works is something like this, right? Now for SSL connection, we need certificates, right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master, right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate, right? It requests a slave node to give master the certificate, and the slave obliges for this request and sends the slave certificate to the master, right? But still at this point, the communication has not been established, although the certificates have been exchanged, right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the Puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the Puppet master and he shall sign the certificates of the nodes which basically he wants to attach to the Puppet master, right? Once the Puppet master signs the certificates of the slave, only then a secure connection is established, right? An encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between Puppet master and Puppet slave, and this will be more clear to you when we'll be setting up Puppet, which is basically our next session, where we'll be setting up a Puppet master and a Puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on Puppet master so that the connection becomes encrypted. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the t2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node Puppet master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my Puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my Puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well, so that we don't get confused between the master and the slave. So this is my master server. All right, so while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. So the file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet Master here. So we are installing Puppet Master. Puppet Master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet Master is nearly installed now. And now let's check the content of the policy. So yes, Puppet Master has been successfully installed. And now what I can do is I can check the status of the Puppet Master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet Master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet Master for running. Right, here we are. So basically your Puppet Master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet Master can only use 512 MB of the memory. So Puppet Master can work in a 512 MB memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet Master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet Master over here. So Puppet Master is now restarted, and now we'll open port 8140 through which basically Puppet communicates with the slave. through the firewall of the OS as well. So that's done and we're set. So Puppet Master is successfully set now. Let's go to our slave and start setting up our slave as well. So on a slave, we have updated the machine. WCAT is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet Master. Over here we're installing Puppet, which is nothing but Puppet Agent, right? So once Puppet Agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano /etc/host, specify the IP address, write Puppet in front of it, and save the file. Alright, so now we're ready to start the Puppet agent. So let's do that. So Puppet agent has now been started. Let's enable Puppet as well, which basically means on restart also, Puppet will be started automatically. So this is done as well. Alright, so now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed. So the moment Puppet slave starts, it basically sends a request for the master certificate. How does the Puppet slave know where the master is? We just specify the IP address in the host file, right? So it knows where the Puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time it also requests for the slave certificate. So this when the master requests for the slave certificate, the Puppet slave basically sends the slave certificate, and now we have to go to Puppet master basically. So we are here. We'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request from the Puppet slave on the master. So how do we know it's the Puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign. And if there are more than one certificate or more than 2 or 3 certificates and you want to sign them all you have to do is sudo puppet sign and then -- all. Specify this and your certificate is now signed, right? So my Puppet master and Puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave, and these are the changes that we are going to do. So basically we are creating a file which exists in this particular directory, right? So the Puppet master has to ensure that this file is present on this directory, and the permissions, the read-write permissions of this file is this, which is the user should be able to read-write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file, and the content of the file should be this. Let's copy it, paste it over here, save the file, and once the file has been saved, all you have to do is restart Puppet master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet, and since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent hyphen test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent hyphen test. So this command will basically ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in /temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet Master slave setup is now complete, right? So now you can use the Puppet Master slave to basically do configuration management. So you'll just have to specify the configuration on the master, and then it will be applied on the slave. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you are basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx? We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agent's configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one. All right, with this guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're gonna do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest, so that basically if I want to install say Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go. And now inside this directory you will have something called as code, right? So you'll have to go inside code. Then there will be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. Alright, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, these whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure, which should be equal to installed, right? Followed by a comma, and now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be say status.txt, right? So again it will be followed by a colon. Then I'll specify the attribute. Now the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file there should be a text which says Nginx installed. Okay, followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644, followed by a comma. Okay, so everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifests folder, which exists inside the environment production. Okay, so this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent -test, right? And I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify -test, and we'll hit enter. And now it says applied catalog in 0.01 seconds. All right, so let's check if we have the tmp file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. Alright, so I think, guys, I got the problem. The folder name has to be environments. Okay, so if you look over here. Alright, so let's try this. So let's try to change this folder name. So for that I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again. So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again and do a Puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, Nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do, we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says Nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed Nginx, and it has created a file on the agent itself as well, right? So congratulations, guys, on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are 3 components of manifest. Basically, we can call these components, which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this, we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master. So let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It would be $text. Okay, let's try to save it, and let's go to our slave 1 and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent -- test. Let's hit enter. All right, so something happened. Let's check. So cat /tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right?
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Two values, one is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service Nginx status. Service is running, so let's stop the service. So service Nginx stop. So we'll have to add a sudo. Yes, so Nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent -- test. I'll hit enter. And now it's basically applying the catalog. So my Apache, so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I just have to specify packages, and I'll have to save the catalog, and that's it. If I come back here, if I again do a puppet agent test, let's see what happens now. All right, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server. So let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed. So we can also check it on the browser, on the terminal. Service Apache 2 status and you can see Apache is now running on this slave. Similarly, if I want to check service MySQL server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed two packages, two softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. Alright, so now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here, we say we are using the basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp/status.txt. okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying, is Apache 2 present or not? So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. Alright, so what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that /bin/echo. Say we are checking if Apache is present or not. So we'll say Apache 2 is installed. So we'll say this, and this has to go inside /tmp/status_apache.txt. This will go over there. So this command should run only if the command the command would be /bin/which Apache 2, and only if this command is successful, it should run this particular command, right? So, and now we'll just close the resource, and that's it. Let's save the file, and now let's come to our slave, which is this. Let us try to run the test. So sudo puppet agent -test. This basically has now created a file. So let's see if the file has been created or not. cd/tmp/status underscore. So we don't have a file over here. So let's see status underscore. Okay, so let us go inside tmp first and then do an ls. So I can see status underscore apache file is present. So I'll just cat it status underscore apache.txt. So it says Apache 2 is installed. Reason being, over here do have Apache installed. But let us go to another slave which I have connected to my master. Let's see if we have Apache 2 over here. So service Apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change, and the master told this slave to install Apache 2 on itself. No worries. So what I'm gonna do is I'm gonna sudo apt get and I'm gonna purge Apache 2. Okay, so this will uninstall Apache 2. And now if I do a sudo service apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent hyphen test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside /tmp. I'll do an ls over here. It has a file called status underscore apache. Let's check that. So status underscore apache. What we can do is probably this could have been created earlier. Let us remove this file first. Status underscore apache we have removed. We'll have to add a sudo here. So it's removed now, right? Let me just check if this command actually works or not. So /bin/which apache 2. So it is running service apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm /user /sbin/apache 2. Either we can do this or okay, let's first do this and then we can probably try something else as well. So user sbin/apache 2. Okay, so now if I do /bin/which apache 2, do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent hyphen test. I'll hit enter. Alright, so the catalog has been applied. Now let's check inside tmp file. So cd tmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is until and unless this file or this command is not sending me 1 or is not false or is not executing properly, till then do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we will do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is if I go to my slave 2, I'll just do a puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore apache file. Let's do a cat on that, and it says Apache 2 is not installed. So basically we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet. Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, It's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management, right? And now what happens is any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically, right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is there is no room for error because everything happens automatically, right? So if there was any error which could be committed while installing softwares, that is not the case now because everything is automated. So that is why configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem. Right now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed that Ansible playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So a playbook essentially should have a lot of plays. So guys, you have the first level in the tree of playbook comes a play, right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play you define the tasks that has to be done, and each task has something called as module, it has something called as notify, it has something called as handler, and a lot of other things as well, right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So like I said, playbooks has a lot of plays and each play has a lot of tasks, right? Now let us see how we can define a play in a playbook. So guys, in a play, you can have 2 or 3 tasks or 4 tasks or 10 tasks or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1 and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session, but let us take an example that these are the 2 tasks which have to be done on a particular host. So they can be combined inside one play and then they can be executed. Similarly, if I want to execute a script on host 2 and install Nginx on host 2, this would become play 2. Okay. Now, how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay, now out of these, which are plays, what are plays and what are tasks? Let's look at that one by one, right? So guys, this particular block of code is one play wherein you have defined the hosts, right? So whenever you define the host, you start with a new line wherein you're defining the host. That becomes the starting of your second play. Okay, now the next thing is inside a play you have tasks. So as you can see, you have tasks over here, and the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is you'll have to pass the command. Now what command has to be executed on the terminal? That same exact command you have to mention here. Okay, then the second name is execute script on server, right? So what is the script that you want to run? Test underscore script dot sh. This is the script that I want to run. So in this I have two tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay, hyphen marks the beginning of a new task. You specify the name of that task and then you specify how that task will be executed. All right, for example, in this case there should be a command which is being executed. In the next case there should be a script which has to be executed. The syntax will remain like this, right? Now whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this hosts colon and then host 1. Then whether that particular command or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo colon and then say yes. Okay, then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay, so apt colon and then the package name, which is nginx, that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you are starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay, once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks. So it becomes a dictionary. So it has all these information, each play, and once you define that and execute that, then it executes according to what is asked inside that particular play. All right, so when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, When you combine them together inside a playbook, it become a list of dictionary. Okay, so again, seeing what tasks are nothing but they are basically commands that we want or tasks or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first, let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay, so this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay, so let's create a playbook called sudo nano play dot yaml. Okay, this is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay, then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay, and now let's specify the tasks. Okay, now inside the task, guys, the first thing that you would do.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Is you'll have to define a task. So let's name the task something. So let's call it install Apache. Okay, let's call it this. Then what I'm gonna do is I'm gonna give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2 and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible -m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave1. Yes, so the name is slave1. So let's change that in our YAML file as well. So sudo nano play.yaml and the host name is slave1. Okay, now let's try to run this playbook. Now how can I run this playbook? Type in Ansible -playbook space play.yaml. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave1 right now and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task. And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, changed equal to 1, and nothing has been failed. Now, if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is let me just uninstall Apache. Sudo apt get purge Apache 2. I'll just uninstall the package and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt-get update, and the next step would be to install Python, sudo apt-get install Python. Once this is done, I'll just have to go back to my master. I'll have to make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave 2. Okay, so this is my slave 2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here. SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a ansible-m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do this? Alright, so now let us go to inside Ansible, right, and let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play 2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install, let's say I'm installing Apache on this system, and I want to install Nginx on my slave 1. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave 1 now, and I'm installing Apache on my slave 2. Okay, so name is equal to Apache 2, state is equal to latest. Alright, seems cool. Now I will be executing this playbook, and let's see how it goes. So basically with one command, what we are doing is we're installing software on 2 different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. Alright, now let me execute this command. So it is ansible-playbook and then play.yaml. Okay, So let's execute this. So it is executing play 1. It is installing Nginx on my slave 1. All right. Okay. So it has been done. Now we are executing play 2 and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server 1 is already ready and it says welcome to Nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. All right. So I've configured 2 different servers from my master, right, at the click of one button, right? I just executed one playbook which configured 2 servers of mine, installed 2 different softwares on it based on the name that I specified. All right. So awesome, guys. I think we have almost begin we are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh, and what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var/www/html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be 1.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script, guys. So let's save the script, and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. Alright, so my script is now ready. Now I'll go inside my playbook, guys. So I'll go to sudo nano play.yaml, and I want to do this task on my Apache server, right? So I'm inside my Apache play and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script : and what is the name of the script? hello.sh. That's all I have to do. Now let's save this play, and now let's try to run this play. So I'll do a ansible -playbook and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says okay equal to 2, changed equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see? Automatically a website was created which is now called hello world. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be say I'll go inside the script file. I change the text to hello world 1.2. Okay. Mind you, I'm not going to any other server. I'm just running the same command again. Right, again the commands will run. As you can see, it says on slave 2 there's one change, and if I refresh it now, can you see the website has changed automatically, right? And this has changed without me going onto this server. And this is the power of configuration management, guys. Now imagine you have 100 servers and you have to change a file in all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide, guys. So if I'll come back to my slide, all right. So now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing. right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right. So we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we changed the permissions for that script file. Once everything was ready, we executed the Ansible playbook, and the script file was automatically taken up and shifted or
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right. So guys, this is how you create a playbook. So the first step that you have to do is you'll have to install Ansible on the master, right? But you do not have to install Ansible on the slave. That's because Ansible works in such a way that, Ansible installation is just required on the master. On the slaves, it just requires Python to be installed. If Python is installed, it can directly connect to that particular Ansible slave, right? So this is the first step. First step is install Ansible on master. Second step is to configure SSH from the master to the slave. That is, you should be able to do an SSH to the slave from the master without any key and without any password. So we'll see how we can configure this. Third step is that we'll have to set up Ansible host, and then we'll have to test the connection. All right, so we'll do this step by step, guys. So let's start with step 1, which is install Ansible on the master. Now, in order to do that, you'll have to first launch 2 instances on AWS. Now, let me just quickly jump on to my AWS console. So guys, this is my AWS console, guys. And the first thing that I have to do is I'll have to launch an instance, and the OS that I want is Ubuntu. The processor would be T2.micro. I click on next. What are the number of instances that I want to launch? I want to launch 2 instances. I'll click on next. Move to the part where you'll have to select the security group. Now, if you don't have a security group, first create a security group and add a rule for all traffic, and it should be basically from anywhere. Click on review and launch, and this will be done. If you already have a security group which has these kind of properties, what you can do is you can click here on select an existing security group and select the security group that has all the rules according to what software you're installing. All right. So once this is done, guys, click on review and launch, and finally review all the settings that you have done and click on launch. Okay. Select the key pair that you have on your system and click on launch instances, and this will launch 2 instances on AWS for you. Next step would be, guys, to basically go to my management console and naming my instances. So let's call my first instance is as Ansible 1, and let's say my second instance is Ansible 2. Okay, Ansible 1 is going to be my master and Ansible 2 is going to be my slave. Let's try connecting to Ansible 1 first. So I'll go to my putty tool, and this already has my my ppk file selected, which is HEM, right? So this is already selected. Now I'll click on open. So I'll click on yes, and I have successfully connected to my master now. Awesome. So I have connected to my master. The next step would be to connect to my slave. So for connecting to my slave, again, I'll go back to my management console, select the second instance, copy the IP address, open a new putty terminal, put the IP address over here. Let us change the color so that we can differentiate which one is my master and which one is my slave. And yes, now we are basically connecting to my slave. Let's enter the username, and we'll select successfully connected to my Ansible slave as well. So my green terminal is my Ansible master. This is ready now, and this is my Ansible slave. Now what are the next steps that I will do? First, I will have to update the master and the slave. So on my master, I'll type in the command sudo apt get update. Similarly, on my slave as well, I'll type in the command sudo apt get update. All right, so my machines are now getting updated. Once I've updated my master, next step would be to install Ansible, and for that the commands are these, right? So once you've updated the machines, you'll have to install a package called software properties common on my master. Usually when you're launching an instance on AWS, this package is already the latest version. So as you can see, it says it's already the newest version, which is awesome. The next command that you have to run is you'll have to add the repository for Ansible in your master, right? So just type in this command, hit enter, and this will basically add the Ansible repository to your master. Next step is to update the machine. So let's update the machine with this command. So it says sudo apt-get update, machine is updated, and now finally the command to install Ansible. Hit enter, and Ansible will now be installed on this particular machine. So while Ansible is being installed on this machine, guys, what do you have to do on the host or on the slaves? You'll have to update the machine, which you have already done, and just install Python. Okay. So this is my master. Ansible is successfully installed on my master. On my slave, I just have to install Python. Nothing else. No other Ansible software. So Python is being installed on this machine now, and Python is installed successfully. Okay. So Ansible is installed on my master. Python is installed on my slave. These both are ready, right? Now let's see what is our next step. So let me just go to my slides. So the first step was to install Ansible on the master. I've done that. Next step is to configure SSH access to Ansible host. Now what does this particular step mean? This means if I go to my master right now, and if I type in the command SSH Ubuntu @ the IP address of the slave, I will not be able to connect to my slave right now with this command. Let's see. Let's verify this. So I'll go to my AWS Management Console, and this is the IP address for my slave. Let's try to copy that over here. Let me also explain you what is basically happening in this command. So I'm doing an SSH on this machine with the username Ubuntu. Okay, so that's why Ubuntu @ this IP address. Now, if I hit enter, if I'll just type yes, this is basically asking, should it add this IP address in the list of known IP addresses? I'll click on, I just select yes, and this IP address will now be added. I hit it enter, and now as you can see, it says permission denied. So you're not able to do an SSH to this instance with this particular IP address. Now we have to solve this. This should basically be a success. This should be able to connect to the slave through this particular command. Right now, why are you getting permission denied? That's because the only way to connect to that instance is using the PPK or the PEM file, right? We don't have the PEM file in this instance. So we'll have to enable my slave to be able to accept connections from this particular machine, so that it does not require any key like a PEM file or a PPK file or any kind of password. Now this is a necessity when you're trying to install Ansible. Now let's see how we can do this. How can we enable keyless access into my slave? Now for doing that, guys, the first thing that you'll do is you'll have to go inside the directory .ssh. Once you go inside that, let me first show you the structure right now. If I do an ls, you can see there are two files. One is called authorized keys and the other is called known hosts. What is known hosts? When we were executing this particular command, SSH Ubuntu @ IP address, it asked us whether this IP address should be added to the list of known hosts, right? So inside this known hosts file, if I do a cat on known hosts, you can see that this is basically the code, or this is basically the encrypted form of this IP address that is that on the slave, and which tells it that, okay, so this is a known host that I'm connecting on. Okay, if you don't understand this, guys, don't worry. This is not a part of you getting to know Ansible. I'm just telling you this for your knowledge. All right, so this is encoded form of the IP address that you'll be connecting to. All right, what else is there in this directory? You have something called as authorized keys. Authorized keys is a file wherein you will be entering all the machines which can connect to this particular system, right? If I do a cat on this file right now, you would be able to see that this is the SSH, or this is the key code that of this particular file. What is this file? This is the PEM file that got downloaded on my system when I created a key pair, right? So when I connected to this instance, I connected using this particular file. So this is there in the authorized keys file, which means that if a machine is connecting to this particular instance and has this particular file as an argument, in that case, that allow that machine to connect, right? So if I remove this, nobody will be able to connect to this instance, even if they have this particular file. Okay. Now what I want to do is, on my slave, if I go to this particular directory .ssh, and if I do an ls over here, this file, that is the authorized keys, I want to add one more key in this, which will basically allow my master to connect to my slave. Now which key I have to add, I'll tell you now. Now, in order for you to generate a key for your system, all you have to do is type in ssh-keygen. This will basically create a key for this particular machine. It is going to be unique for this particular machine, all right? So ssh-keygen, if I hit enter, it'll ask you to enter the file in which to save the key. Do not enter anything, just hit enter repeatedly, right? And then once you get this kind of a message, that means your file has now been successfully created. And where is it created? It is always created inside .ssh directory. Okay. Now if I do an ls over here, I can see there's a file called id_rsa.pub. Okay. Now the code which is there inside this particular file, I'll have to put it inside the authorized keys of my slave. Okay. So let's try to do a cat on id_rsa.pub. This is the code id_rsa, sorry for my mistype. This is the code which we have to enter on my slave now. Okay, so let's copy this code, and on my slave, let me do a nano on authorized keys, and now let's just paste the code over here. Okay, we have pasted the code. Let's save the file. And now if I try to do an SSH again from my master, I should be able to do it successfully. So I'll just again go to that particular command. This is it, right? Let me copy this command and let me clear the screen, guys. So I'll clear the screen so that it's visible clearly. Now I'll do an SSH on this particular IP address, and now you can see I didn't get an error. I basically got logged into my slave. And how do you know that? This is the username @IP 172.31.45.176. This is what you're getting on this terminal, and if I see over here, I have the same number over here as well, 172.31.45.176. So I'm connected from this machine onto this machine through SSH. Now if you want to exit the SSH, all you have to do is type in exit. It says connection to this IP address has been closed, and you can see it has reverted back to the same name that was of the master, which is IP 172.31.44.88. Earlier it was 172.31.45.176, which was of my slave. Okay, so I have done my second step successfully, which was basically to configure SSH access to my Ansible slave without any password and without any key. Right, you just enter SSH Ubuntu @IP address of my slave, and you'll be able to connect to it successfully. Now what is my third step? My third step is setting up Ansible host and testing the connection. So I have SSH enabled on my master. It can easily connect to my slave now without any password and without any key. But how will Ansible connect? We'll have to configure that now. Right now, in order to add, or in order for Ansible to know that it has to connect to a particular machine, it has to have its IP address. Right now, where can you add that IP address? That IP address is basically added in this particular location, /etc/ansible/hosts. All right, hit enter, and this is the file that will come up. Right, so these are all the commented lines, are all the templates that you can use to basically add hosts, but I'm going to tell you a new template in any case. So the way you add hosts is you start by square braces. Okay, and inside square braces you give a name. Let's say the name is production. What does this name symbolize? This name means that whatever is below these square braces is basically inside the group production. So this is the group name. Okay, and now what I can do is I can add n number of IP addresses over here, and all those IP addresses basically will be inside the production group. Okay, you can name your group anything, guys. It's basically random. You can name it anything, but whatever IP addresses you will specify after that will get inside that particular group. Okay, now I have created a group. Now I want to add a host inside this group, so I can give my host a name as well, or I can give my slave a name as well. So let's call my slave as slave1, right? Then you'll give a space, and then you'll type in Ansible underscore SSH underscore host is equal to, and then the IP address of your slave. So in my case, the IP address of my slave is this particular IP address. Let's try to copy it and let's enter it over here. Okay, so you enter the group name, then you enter the host name or the slave name, space Ansible SSH underscore host equals to the IP address of my slave. So whenever I'll ask Ansible to ping any of my slaves now, it will read this particular file to get to know which IP address it has to ping on. Okay, now let's save this file. So my file is now saved, and now let's try to enter the command Ansible -m. So now what we are trying to do is we are trying to see whether Ansible can communicate with my slave. Okay, now in order to do that, I'll type in Ansible -m ping. Ping means ping that particular all the slaves which are basically connected to this Ansible master. How are we selecting all the slaves? We'll type in the command all. So Ansible -m ping on what? All the machines that are connected to this Ansible master. I'll hit enter. So it will go through that file which we created /etc/ansible/hosts. It will see all the hosts which are added in that particular file, and then it will ping those machines, right? So as you can see, it on slave1 was the name that I gave to my host. On slave1, it was successfully able to send ping, and what it received was pong, which means that it was successfully be able to communicate with the Ansible slave. All right, I can also type in Ansible -m ping, and I can specify the group name. So the group name was production, let's say, right? I hit enter. As you can see, it automatically got to know, okay, so if I'm pinging production, these are the hosts which are inside it, and this is the message that you're getting, which is success. If I try to type in the host name as well, so I can also do that. I'll type in Ansible -m ping slave1, which is the host name, hit enter. It'll again be able to ping the slave machine. But let's say I enter a name which is not there in the host file. What will happen in that case? It will not be able to match it to any of the name present in the host file, and hence you'll get an error. No hosts match, nothing to do. Okay, so guys, this is how you can set up Ansible master slave on AWS using the Ansible software, which basically does not require you to install the Ansible software on the slave. Just install Ansible master on the master, the Ansible software on the master, install Python on the slave, add the IP address of the slave in the host file, and configure keyless SSH access from the master on the slave, and you're ready to go. All right, so let me just come back to my slide. So let us summarize what we did. We installed Ansible on the master and we installed Python on the slave. Then we configured keyless SSH access from the master to the slave. And the third step was we added the host's IP address on my Ansible master in the file /etc/ansible/hosts, right? Once I did that, I was able to communicate with my slave.
Let's talk about Kubernetes now. So basically containers are a very good way to bundle and run your applications. We talked about this before, right? You can have your applications divided into a various number of small independent pieces, and you can bundle them together and run it dynamically and manage it. So right. So in a production environment, you need to manage these containers, right? So there are a lot of containers that you have broken your application down into. So you need to manage these containers to ensure that there is no downtime and there is no hindrance here and there. So that is where Kubernetes comes comes into the picture, right? So what basically Kubernetes does is it provides you with a framework to run on your distributed systems very resiliently. So it takes care of all the scaling that you have to do. So by scaling, I mean if you have, let's say, 3 replicas of a pod, we'll discuss about pods later. So you can make it to 4, 5, 6, 7, or bring it down depending on your needs. And if there is a failover for your application, it can rebuild it if it's required. If it gives you with a deployment pattern. So there are two ways of basically deploying things. You can recreate it. So what it means is basically if you have, let's say, two things which are running and you have an update right now, so you can either recreate the entire thing, which will give you a little downtime, or you can go with the rolling updates. So the rolling updates will basically move it one by one, all the replications that you have, and replace it with your new updated deployments, right? And it provides you with much more than that. So basically Kubernetes can be thought of as a portable, extensible, open source platform which is used for managing containerized workloads and services, and it facilitates both declarative configuration as well as automation. So it does both of those things. So what do we mean by declarative configuration? So you give your configurations as a file where you declare, okay, this is mapped to this, so this basically does that. So we'll talk about that when we talk about YAML files, and it gives you this automation kind of thing where it basically manages all your things through controllers. So it has a very large and rapidly growing ecosystem, Kubernetes. So various number of people are involved with Kubernetes ecosystem. A lot of people are there, so they give you this service and support, and there are different tools widely available which are very compatible with Kubernetes. So a lot of people are working with it. So there is a huge community to it, where you can find different answers to the problems that you face in and around different communities. So it's a very, very, very happening and hot topic in the computer science field right now, and specifically towards the DevOps. So Kubernetes is a very, very good container orchestration tool. So it helps you manage all your containers and deployments and scale it.
Why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server. Right now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base. Right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependencies. So say, for example, tomorrow my passenger management code fails. So that would lead to all the features will lead to basically failing. Reason being, all of them are dependent on each other, right? And this was solved by using microservices. Now, what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now, my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately. It's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message, which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON, that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service the customer service module might not require that much of power that is there in one server, right? But still, my customer service module is occupying the whole server, and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue, you can also upscale it, but upscaling would also cause the same problem. That is, say, your server is able to handle 10 replicas of your customer service uh, module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to, say, around 85 to 90% of its usage. Now, what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still, your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different, and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine, what is the health of a container. Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help. Right now, there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today. Right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of your feature which is running, it became difficult to monitor it. Right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in that case it was manually updated that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it, because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number, and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is, for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes, wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system. It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside.
So let us begin with Kubernetes architecture. So basically Kubernetes follows a client server architecture. So basically there's a client, there's a server, you send a request to the server and it replies back, something like that. So along the ways, it follows a similar architecture to that. In this Kubernetes architecture, we have a master installed on one of the systems, and there are a lot of different slaves, as you can call them, or different nodes which are on the separate systems, and these are connected. So there's one master which controls everything, and there are a lot of slaves to it, or different nodes to it, which are created on different separate Linux machines. So as you can, if you remember in our installation, when we tried using the AWS console, so what we did was we had multiple instances, out of which one we had as a master and rest of them we attached them with the token as a slave. So that's how the architecture is, and you can see the overall architecture here in this picture. So there is this one master node right here. Now master has different components to it. If you look at it, this is a worker node, this is another worker node, and here you can see a master node has an API server, a kubectl. A kubectl is basically a command line interface, which we'll be discussing on later, and there's an API server. So as a master, it has to host, so it has an API server there, and then there is a scheduler which can schedule different jobs, and there is a controller manager. So there are a lot of different things which can be controlled, which have a controller manager which makes sure that certain things are created and maintained, if you will, for their requirement. And there is etcd, which is another part of the master component. And then in the worker node side, you can see there's a kubelet, there's a kube proxy, there are different pods, and then there is on above it, it's a Docker, but you can have any other containerization platform. If you can create containers through that. You can use that as well. And then there is the internet. So we'll be hitting each of these individually one by one. So if you are starting off, so let's start off with the master. So we saw there was etcd, there was an API server, there's a kube controller manager, there's a scheduler, and there's a cloud controller manager. So we'll hit all of these one by one now. So basically etcd is something that stores configuration information, which can be used by each of the nodes in the cluster. It is a highly available key value store which can be distributed among multiple nodes. Also etcd, the job of it is to has to store all the configuration and the specifications, and it has to be readily available across all of them, all of the nodes, so that there's a constant availability of things and you know what is going on, right? So these configurations are accessible only by Kubernetes API server, as it may have some kind of a sensitive information. So it is kind of an encrypted area where you want to keep your sensitive information as a key value store, and it is a distributed key value store which is accessible to all. So this key value store contains all of the configuration information and other sensitive information that is required for it to run. So it make this information helps Kubernetes node and server architecture stay alive, and it is just sometimes called as the brains of the Kubernetes, as it has all of the information which is required for it to run. And the next part is the API server. So as we mentioned, the API server is the one which is the only one that can access the etcd, right? So this provides all the operations on the clusters using the APIs. So there are different APIs. As we mentioned, it is a client server platform. So there's a lot of information which is all of the work which is done through APIs. So this makes sure that all the operations which are done on the clusters are done using the APIs. API server implements an interface, which means different tools, libraries can readily communicate with it. So it is a very key part of the architecture. And then there is a kubeconfig package along with the server side tools that can be used for communication. So what it basically does, that kubeconfig thing, is basically exposes the Kubernetes API. By exposing, I mean there are some things which stay internal and some things that you expose which is publicly available that you can see from the outside. So the kubeconfig package lets you expose your API so that others can reach it from the outside, right? So Kube API server is designed to scale horizontally. That is, you can scale more and more by deploying more and more instances. So if you want to scale the architecture, so in order to do that, you have to create multiple instances and divide your workload along it, and it scales horizontally. So it scales horizontally in that way. You can run multiple instances of a Kube API server and balance the traffic between those instances. So if you have multiple nodes, easily you can transfer whatever the traffic that is coming on or whatever the request that the client is asking for. You can serve those by balancing those traffic throughout the nodes that you have with the help of the API server, as you have multiple instances. Coming to the Kube Control Manager, it is the component on the master that runs the controller. Logically, each controller can be thought of as a separate process, but to reduce complexity, it is compiled into one binary and run as a single process. There are various components of the controller. So these are namely basically four kinds. First is the node controller, which is responsible for noticing and responding when the node goes down. So you have a lot of nodes. If you are creating like multiple nodes, so it has to make sure that all of the nodes are running. So our node controller's job is to make sure that it notices and responds when a node goes down. Then there is a replication controller. Now, when we'll be discussing YAML files, you'll see that you can have multiple replicas of a single pods, and you can have lot of like a pod can be thought of a set of containers, and those containers will have a lot of information, right? So if that container has your application, so you don't want one instance of that application to be running. You want it to have multiple instances. So let's say if I have a client which wants some service to be done, and that service is, let's say, image processing, and it converts image to black and white. It would be okay if I had only one customer. So now I have like 10,000s of customers, all of them requesting that their picture should be turned into black and white. But if you have only one instance, there will be a lot of traffic on it. So what you want to do is you want to have multiple replicas of the same pod. That is the pod which has the containers which basically turn the image to black and white. So what you want is multiple instances of that, so that each of them requests which are from your 10,000 clients can be served properly in a faster manner without having a downtime, and so that the traffic is also distributed. So the job of the replication controller is to make sure that if you define in your YAML file that I want, let's say, 10 replicas of this pod to be there, so it makes sure that there are always 10 replicas available, and if some replicas goes down or if it stops responding, its job is to recreate it. Okay, then moving on, there are endpoint controllers which populates the endpoint objects. That is, it joins the services and the pods, and it's basically making sure that the different endpoints of your application is running and they are in constant connection with each other. Then there is a service account and token controller, which create default accounts and API access tokens for different new namespaces that you have. You'll understand namespaces in this module itself. We'll be discussing that in the add-on section. Now moving forward, we have a scheduler. Now scheduler is again a very key component of master. It is responsible for distributing the workload. So if you have a lot of workload, its job is to schedule it and distribute the workload. It is also responsible for tracking utilization of the workload on cluster nodes, then placing the workloads on which resources are available and then accept the workload. So it'll look at the resources that are available and then it will accept the workload, and then it's responsible for distributing it and tracking the utilization of whatever the resources that we have, right? So basically, in other words, what you can tell is that this is a mechanism which is responsible for allocating all the pods that are available to the nodes. So as I told you, there are a lot of different containers. So if you understand Docker, you know there are a lot. The basic container has a simple image. Now multiple of these containers together forms a pod, and this pod can be some kind of an application. So as I mentioned before, if we have multiple replicas of these pods, so there are a lot of replicas which can be deployed on a single node. And if one of the replicas is, let's say, busy or is down for some reason that it's facing some responsibilities, the scheduler is responsible for allocating these pods to different nodes and then making sure that if something is not working, then the work will be given to some other node. And that is the important part of the scheduler.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Then moving on, then there is a cloud controller manager. Now cloud controller manager runs the controller that interact with the underlying cloud providers. So in our case, it was AWS. It could be GCE, which is the Google Cloud Engine. And there could be a lot of different, you can use Azure or whatever the cloud that you are using it. So cloud controller allows the vendors code. So that is the cloud vendors, whatever is your cloud vendor, if it's Microsoft or Amazon, it allows that their code and Kubernetes code to evolve independently of each other. So it can, both of the codes are working, they are working simultaneously on the same thing probably. So it makes sure there is a coherence among these two while they are working as a single unit. So it is a very important part again. So the following controllers, cloud providers have their dependencies. So there is a node controller, there's a route controller, and there is a service controller and a volume controller. So there are 4 kinds in this also again. So the job of the node controller is for checking the cloud provider to determine if the node has been deleted in the cloud after it stops responding. So if it stops responding, its job is to make sure that the node, to determine if the node is deleted or not. And then there is a route controller. So the route controller basically is for setting up different routes in the underlying cloud infrastructure. So it's basically responsible for where the information goes from where to where and routing it basically. So basically what a router does. Then there is a service controller, which is used for creating, updating, deleting cloud provider load balancers. So like we have a scheduler for distributing loads in the master side of things, in the, let's say, pod side of things or whatever we have. In the cloud side of things, the service controller is responsible for load balancing their traffic. And then there is a volume controller, which is for creating, attaching, mounting volumes. Now volumes are again can be thought of as storage, and it's a very this volume controller is responsible for interacting with the cloud providers to orchestrate these volumes. So as I told you, volumes can be thought of storage, like storage. So storage is there. So there's a lot of different storage. What you want is that your storage interacts or properly mounts and attaches itself to the cloud. So the job of the volume controller is for creating or attaching or interacting with the cloud providers and properly orchestrate, that is sending and properly giving the instructions basically, if you will, to these volumes to properly work with the cloud. Then coming to the node side of things. So the Kubernetes nodes has 3 different parts. There's a container runtime, there's a kubelet service, and there is a Kubernetes proxy service. Now Kubernetes proxy service is another very key part of it. So let's discuss all of these one by one. Now let's touch upon the node side of things here. So the node architecture, as we saw earlier from the overall picture, contains of basically 3 major things. First is the container runtime, where we talk about different tools which are responsible for running your containers. Second one is the kubelet service. which is responsible for talking to etcd and the master and getting the information, which we'll discuss when we talk about kubelet service. And the final one is the kubernetes proxy service, whose job is to make sure that some things.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Are available to the external host without any hassle. So all of these things have been designed in such a way that it becomes a very hassle-free job when you're working with Kubernetes. So let's hit them one by one. So the first one on our hand is container runtime. So a container runtime is a software responsible for running the containers. And as I've mentioned earlier, that Kubernetes is a container orchestration tool. It is not something that creates the container. It is something that manages them. So you need to have a software that creates the containers. So that could be Docker, and I've mentioned here that Kubernetes supports several runtime containers, which is Docker container, and there is Containerd, there is Creo, then there is Archlet. There's a lot of different things, or any other implementation of Kubernetes CRI, which is Container Runtime Interface. So you can use any of these to create your containers. So the first thing that is required in the architecture is a container runtime, something which creates and runs the containers. Moving on, the second part is the kubelet service. Now, this is a very small service in each node, which is responsible for relaying information to and from the control plane service. Now it interacts with etcd. So if you remember when we were talking about in master, that etcd is a distributed, highly available key value store which contains a lot of configuration information and specifications for your different deployments. So the job of this kubelet service is to interact with the etcd store and to read and store the configuration details. So it interacts with the etcd and it stores and reads and these configuration information, which is very responsible for us. It does more than that. What it also does is it communicates with the master component to receive the command and the work which is required for you to do. So the master and the node interact through this kubelet service where it basically communicates with the master component. Then this process also takes the responsibility for maintaining the state of the work and the node server. So it does three very major things. It does interact with the etcd to get the configuration information. Then it interacts with the master to know what is the command and what is the job to be done. Then it also makes sure that whatever the specifications that we have read and what is the state of the work is required, it is there and the node is maintained. Finally, it also makes sure a few of the networking side of things where it makes sure that ports are forwarded and the networking rules are well working and everything that is required. So it does all of that. So kubelet service is responsible for all the major networking related things. Then there is Kubernetes proxy service. Now, this proxy service runs on each node and helps making the service available to an external host. So what does this mean? Let's give you an example. Let's suppose I told you before, right, that the pods are a set of containers which is deploying an application. Let's say I have two pods in one node, right? And both of the pods are mentioned as a replica of each other. Just what I've done is I've made a very small change in both of these pods, right? So since I'm an external person, I don't know where the pods are. I know where the node is. Maybe I know the IP of the node and I'm trying to reach that node, right? So what would be the information that I get? Will it be what it is inside pod 1, or will it be inside what is pod 2 or the container 2, whatever it is, or it is container 1 or it is in container 2? Which one do I reach, right? In that case, what will happen is when you don't know where it is, the job of the proxy service is to bridge that gap. Since you don't know where it is, it makes it look like you know where it is by routing you to the proper place. So if I hit the IP of a node, I do not know where actually the pod is, but the proxy service basically maintains that gap. It talks to the node and it communicates it to the pods and or the containers and gets back the information so that it looks like you are actually hitting the pods without actually hitting it. So it basically makes sure that that service, which is the whatever is inside your container, is available to the external host without actually them knowing where it is. It helps in forwarding the request to the correct containers and is capable of performing primitive load balancing. So as I was giving an example, so if I have two containers, if I make a very small change in both of them, let's say one says hello world and one says bye world or something like that. So the primitive load balancing that it does is if you hit that node again and again and again, there will be instances where you get hello world as the reply, and there will be some other instances where you get bye world as the reply. So that is the job of the proxy service, to make sure that you actually get informations from the container without actually knowing where the container is. Its job is to bridge that gap. Moving on, it makes sure that the networking environment is predictable and accessible at the same time. It is isolated as well, so it makes sure that it is predictable. So if I'm hitting a node, so I think it what I should receive what I'm expecting. It makes sure that it becomes predictable, that I get what I want, and it makes sure that it's accessible while I still don't know where it actually is. That is the time it's being isolated. So I don't know where it actually is, but I still receive the information with the help of this Kubernetes proxy service. That is the main job of it. It manages pods on nodes, volumes are nothing but storage kind of things. Then there is secrets, which we'll be discussing on later on. So secret is something basically which you use to store information with an encryption. So if you have sensitive information like password and stuff like that, you can use secrets to pass that passwords on, or creating containers, health checkup, or whatever you want. Kubernetes proxy service does it for you. Now we'll be talking about the add-ons which are there in Kubernetes. So add-ons use resources like daemon sets, deployments, etc. to implement cluster features. These are all different features of a cluster that you can use because these are providing cluster level features. Namespace resources for add-ons belong within the Kubernetes namespace system. So if you have installed Kubernetes, right? You can just write Kubernetes get all pod -- all namespaces. You'll see different namespaces which are already available. Let me show you just before we begin. So this is my master. As we've been talking here in this slide, that there are a lot of different things which are there, and it will be available along with the kube system namespaces, right? So I'll just want to show you that if you type a very simple command, kubectl. Now kubectl, as we talked, is a command line interface that allows you to interact with your Kubernetes cluster, right? So this is there on the master. This is my master component. So kubectl get pods. I want to get pods, but what I want is, since I've not deployed any pods, so if I do that, I'll get no resources right now. It's because there is no default namespaces which is there. So what we want to do is we want to get all the namespaces. So we'll type kubectl get pods -- all - namespaces. We'll discuss about namespaces later on. So what you basically want to know is, like, if there is we define resources in different namespaces where they work. So if you type kubectl get pods -- all namespaces, we will see currently all of the different pods that are running inside of Kubernetes, which are responsible for its running, right? So as soon as I've hit, as you can see, these are all kube system. The namespace here of everything is kube system. Now this has Calico kube controllers. Now Calico is our basically our network manager kind of thing. This we installed, if you have seen while we were installing it, there is an etcd IP, as you can see. There is kube API server, then there is Calico kube servers, there is kube proxy servers, kube scheduler, and everything. All of these information that we were discussing, core DNS and everything, you can see inside this is running, right? So let's get back to what we were talking about. So these are the different namespace resources. The add-ons belong within the kube system. So whatever the namespaces that add-ons that you will be adding, these all belong to the kube system namespace. As we saw, when we did all namespaces, we saw kube system, whatever namespaces it had. We did not add many add-ons in there, but there are a lot of different things still. So there is DNS. The DNS is a mandatory add-on. So in my, if you can see my terminal again, the kube DNS was already present in here. This, see, core DNS, this is still inside the kube system. The core DNS is already present. So DNS is a important mandatory add-on which is there, but along with that, there are a few other add-ons that you can use. There is a web UI dashboard. There is a container resource monitoring tool which you can use for monitoring how the status of your containers are right now. Then there is cluster level logging also. We'll talk about that, all of these in detail in the future modules, but we'll give you a zest of it now, because we'll show you even how to set up your web UI dashboard for Kubernetes. We'll even show you how to monitor these resources, which we'll be using for using Prometheus and Grafana, where Grafana is used for visualizing those information. There is cluster level logging. We'll show you all the logs and stuff as well in the hands-on in the future modules. But just now we just need to give you a zest of things, so we'll explain it to you here. So starting off with the DNS. Now, cluster DNS is a DNS server in addition to other DNS servers in your environment, which server DNS records for Kubernetes service. Containers started by Kubernetes automatically include this DNS in their servers. DNS server in their DNS searches. So I was telling you, this is a mandatory add-on. This you need to have if you want to work with Kubernetes. It's already present, predefined in it already. But the other things which we are going to talk about in these add-ons, they are not very necessary when you're working with it. It's a good thing to have them as well because it helps you work better, faster, and in a more informative way. But this is something which you actually require. Moving on to the web UI dashboard. Now, dashboard is a general purpose web-based UI for Kubernetes clusters. It allows you to manage, troubleshoot applications running in the cluster as well as the cluster itself. Even you can when you go with the web UI dashboard, which we'll show you after on. So all the concepts that I'll be teaching you how to run through a command line interface, you can do most of it through the dashboard as well, but we'll be teaching you command line interface because it is important for you to learn how to use command line interface when you're running with the Kubernetes, because it gives you a better zest of things, and not all the production environments that you'll be working with will allow you to do your dashboard based things, right? Moving ahead, there's a container monitoring resource. So container resource monitoring are generic time series metrics about containers in a central database, and it provides UI for browsing that data, right? So for this, you can use a lot of different tools again, but what we'll be showing you in this course is using Grafana as well as Prometheus and Helm, where Helm charts are used to get data through Prometheus, and we visualize those data through Grafana. So we'll be showing you that as we go along the modules. But basically this is used to see how your nodes are performing, how their health are, and how many of them are getting killed and they're restarting and stuff like that. All of that data you can get and monitor your containers, right? Then there is a cluster level logging. Now, cluster level logging mechanism is responsible for saving the container logs to a central log store with search/browsing interface. So all of the containers that you have, they have logs of their own, right? So what you can do is sometimes when you want to receive some information or when you're trying to troubleshoot or debug something, you need to have the information of what your container has been through. So cluster level logging mechanism is responsible for that. It stores all of the container logs to a central log store with search browsing interface. Now next is kubectl. Now kubectl I'd say is not just add-on, it is again a very mandatory add-on. It is a part of the master, if you will. It allows you to basically communicate or interact with the kube API server and send commands to the master node. Each command is converted to an API call. As you saw in the example that I showed you, I had a command line interface that was my bash terminal, and there I typed kubectl get pods. Now that is a command. Now that command is turned into an API call, which is through the API server. It is sent to the nodes, and then according to whatever the command is, there it reads the information and it gets back the whatever the information that they have to give on our command. Like if I give the command, so they have to give me the information regarding that command, right? So that will come back through there, and all of this is then my information that the command that I want to pass through the master is given through kubectl. I give my commands through kubectl to the master, then the master gives it to the nodes through the API server, and through the API server these are responding and everything works through APIs, and all of the API calls are made, and then finally you get the result, right?
Kubernetes is one of the most sought after container orchestrating tool in the world right now. Almost all of the organizations who are using containers are using Kubernetes as the tool to orchestrate those containers, and hence kubectl is an integral part of it, where you can use it as a command line interface to interact with your Kubernetes cluster. So the first command is create. So what do I mean by create? So basically what I mean by first command is the simple fact that if you see on your screen right now, the kubectl will be the starting of all of these commands. So the first word that you write will be kubectl. So it basically tells you that this is being interacted with the help of kubectl. So kubectl will be there, and the first thing that you write after that is create. Now create is a command which is used to create resources from a file. It could be of the file .json, or it could be of the type .yaml.
either way is accepted. Other use for create is also there, so you can use create to use a lot of different things. So in this, when you are using with a file, the syntax is kubectl create -f and then the file name, and it creates those resources inside of those files. But create can be used to do a lot of different things. You can create service loads balancers, service node port, service account, cluster role binding, config map, cron jobs deployment, namespace. All of these things can be created using this command. There's another thing that you can use to create files configuration as well. So you use kubectl apply, and using that apply, you can apply some configurations to your cluster as well. So that is something else that you can use. So you can use for creating resources from a file, you can use create or you can use apply. So let's quickly try creating a file using kubectl create. So I have my Kubernetes cluster here up and running. I only have one node right now. Let me show you that really quickly. Kubectl get nodes. So this shows you the number of nodes I have. Just wanted to show my cluster is up and running. Now let's create a file. So I have a file ready in here. So this is a YAML file for deployment. So a YAML file for deployment, basically this has the specifications of the deployment that I want to create. So it has the name of the the kind is deployment, and the name is nginx deployment, that is in the metadata, and it has 3 replicas. So basically it will spawn 3 pods, and you have another match labels, you have images, you have container specifications and things like that, right? So let's create this file. So in order to do that, I will switch to my terminal really quickly. I'll have copied this. I'll move to my terminal really quickly. Now in here, I will type the command nano t2.yaml. I'll just paste this particular YAML file which I have really quickly. And once I've done, I will just save it and I'll exit. So my file is ready. Now what does the command say? The command says kubectl create -f file name. You can see right here, right? Kubectl create -f the file name. So we'll do that. Let's quickly go to the file. Kubectl create -f and the file name, which is t2.yaml in our case. Once I do that, you can see the deployments has been created. Now, if I check for pods, so I have 3 replicas in my deployment, right? So I have 3 replicas in my deployment. You can see, so it has created the deployments and it has created everything. So you can check by kubectl get deployments. This is nginx deployment which was created, is up and running. Cool. Let's move on to the next command. So I was talking about this, right? So you can use create to do a lot of different things. Like you can create a cluster role, you can create role binding, secret, a lot of different things. All of these things which are mentioned here can be done with this. But the syntax will be a little bit different from what we did just now. So I have that syntax ready for you as well. So if you wanted to say, let's say create a deployment with the name and you can give this image. So the syntax for it would be kubectl create, then whatever that you want to create. So if this was a deployment, it's a deployment here. If it was a cluster role, it will be cluster role. If it's a secret, it will be a secret. Then here the things will change accordingly according to whatever you are creating, right? So this will change. For deployment, it will remain deployment's name and -- image, and whatever the image that you are pulling, that image, and then the commands and arguments. So like for example, you can do kubectl create deployment and call it my deployment, and image of nginx and replicas equals to 3. So let's see what happens when we run this command. So let's bring up our cluster, kubectl create. Let's bring on top of it so that it's better for you to understand. So you can see kubectl create deployment, and name it deployment. I will say name it my dep -- image equal to nginx -- replica equal to 3. Let's see what happens. As you can see, a new deployment is created with the name of my dep. So if I do kubectl get deployments, now I have another deployment coming up. As you can see, the nginx which was created when we did the before one, and my dep which we created just now has been. So you can use create commands in the way to create something from a file, or you can create some another resource with some arguments and some names and everything that you have to keep in mind about the syntax. Using these syntax, you can do this. So this is one of those commands. Let's move on to the next command, which is kubectl get. So we've been using get now exclusively. So we are doing kubectl get pods, kubectl get pods wide, and different things like that now. So basically get command, what it does, it prints a table of most of the information about the specified resource. For example, when I was doing kubectl get deployments, it was getting the information with respect to the deployments. You can filter the list using the label selectors, and you can use selector flags, and you can do a lot of different things. So let's say if I wanted to get deployments from a particular environment or namespace, we can do that as well. So that can be done. If the desired resource is in the namespace, then only you will see those results, otherwise you will not. And if you want to see all namespaces, then you have to pass the parameters, which is --all -namespaces. Let me show you how that works. So the basic syntax is kubectl get and the resource name. So let's start with the basic one. I'll show you all of these commands really quickly. So kubectl get pods. You can even type get po, and that will also work for pods. I'll show you. Get po. Oh, sorry. kubectl get po. This will also work, and kubectl get pods will also work. Both are the same thing. You can see same results. So we are getting pods like this, right? And let's say if you wanted to get some particular pods and you wanted to pass some particular thing, then you can have that as well. But let's say if I wanted to, this is getting me all of the pods in the default namespace, because that is the namespace that I've designed. But let's say if I wanted to see pods of all namespaces, so what you can do is kubectl get pods -all -namespace and pass this parameter. You can see the S was missing, namespaces, it's namespaces. So you can see all of the pods which are there in different namespaces. You can see which all namespaces it belongs to. So default ones were the one which were coming here, and there are cube system is another namespace which we have, and you can see all of the pods which are there in various different namespaces. I have started also spawning, right? You can do that as well. Another thing that you can do is kubectl get pods -o wide. Now what's that command? You've seen something here which is -o wide. So this basically returns you all of the pods with more information, like all the pods which you have in with more information. So you can see before what we were getting is, let's say, only the name, the status and restarts and the age. Now we are getting all of those plus the IP plus the node that it is on, plus the nominated node and readiness gates. So we have all the information coming in, and that is with the -o wide. So if you want to get more information with respect to any particular resource, then you use the flag -o wide, right? So that's that. And you can get services, deployments, anything. So you can get kubectl get deployments. We saw that before. You can also get services, kubectl get services. You can get ingresses. You can get basically anything that you want, which you can. If you want to print something, there's like a print statement for the resources that you have, and that is how it works, right? So that's that. Let's move on to the next command. So we got done with get, right? So next one is expose. Now what you can do with expose is like whenever you have a Kubernetes service running, right? So if by default it is on like the cluster IP interface, and your deployments and everything which are not on the exposed end, it is not reachable externally. So let's say if you wanted to expose a resource as a service to an external point, then you use the command expose. So basically it looks up a deployment service replica set replication control or a pod by name, then uses the selector for that resource as a selector, and it sends it to a new specified service point. For example, let's say my deployment, I have created a deployment right now, right? But that deployment resides inside of my cluster. Nobody from the outside world can see what is going on in there. That's the problem. What if I wanted to, make it externally reachable, so that somebody who can type in the port numbers or the link or the address, whatever it is, they can reach the particular deployment. So what I'll do is I'll expose that deployment as a service at some given particular port, and using that I can reach it externally. So let's try to do that. So the basic syntax for that is kubectl expose, and then you can have the type or the file name. So for example, here the deployment is the type name of the resource that we are providing, deployment and the deployment's name, then you have to give. So deployment and deployment's name is nginx, and -- port 80, that is the port that it is currently serving on, and the target port is 8000. So you have to provide both in order to do that, right? So you can do that really quickly. So let's expose us deployment that we have right now. So I'll open. So let's run this command. So kubectl first let's get the deployment. Okay, we have the name of the expose deployment. Let's say my dep. We will expose my dep -- port equals to 80 -- target port equals 8080. You can see a new service is created. So if I do kubectl, now to get service, you can again type get svc or get service, both will work. You can see a new service has been created with the name mydep, which was the name of my deployment, and it has been exposed to a port 80, which was there initially, right? So that is the idea behind it. So that is how it works. You can also expose it as a particular type of service, which can be externally reachable IPs as well. That can also be done. So, but that is not required for now at the moment. But just know that you can expose your deployments as a service. So my service deployment was exposed. So my deployment was exposed as a service on the port 80, right? So that is that. Let's move on to the next command, which is delete. Now what you can do is you can delete some resources as well. So a lot of times you will be requiring to delete resources, and it depends on what you're deleting, that will determine what all will be deleted. So let's say kubectl delete, and then you can have the file name -f file name, you can have -k directory, you can delete an entire directory, or you can have a type or label and you can delete particular things. For example, if you wanted to delete pod, so kubectl delete pod, and then the pod name will delete a specific pod. But let's say if I wanted to create everything created by my deployment, so that is my deployment should also be deleted. My number of pods created through that deployment should also be deleted. So I can delete a file. So kubectl delete -f t2.yaml will result in all of my deployments with respect to the Nginx deployment being deleted, as well as all of the pods which were created will also be deleted. So and you can delete things with the help of label as well. So you can see this example in here, which is on the bottom left side of the screen. Kubectl delete pods, services -l. So you are deleting pods and services which have the label where name is equal to my label, or by the label name equals to my label. So wherever this exists, all of those pods and services will be deleted. So you are passing it as an argument. So these particular things I want to delete. Let me show you these really quickly so you get a better understanding of things. So first, let's try to delete the deployments that we have. So let's see what all do we have. So kubectl get deployments. So we have 2 deployments right now, and kubectl get pods. And you can see we have 3 pods coming from the Nginx deployment and 3 pods coming from the mydep deployment. This is according to replicas that we created initially. Now let's say that I wanted to delete the Nginx deployment and all of the pods associated with it, right? So all of the pods associated with it. So what do I do is kubectl delete -f t2.yaml, because these things I created through a YAML file, right? So I'm going to delete that particular file. So what happens? Let's see. So you can see it has deleted the deployment. So if I get kubectl get pods now, terminating, you can see. And if I do kubectl get deployments, only one of the deployments is remaining. If I do get pods now, you can see my Nginx 3 of them have terminated, only 1 is remaining. And in a second, I think the last one will also be gone. So that is basically how you can delete all of the everything which is created from that file will get deleted if I do that, right? Now, what if I wanted to delete a particular pod, right? So let's say kubectl get pods. So this is the mydep pod name. So this is the pod name. So if I do kubectl delete pod and then the pod name, so you just copy that. So the problem with this one will be that since it's a deployment that we created, that is the mydep is a deployment, so it will keep respawning the pods. But you can see, just notice the name 4DZZ4, it will not be spawning once we delete it. Let's see. So it has deleted a pod. It will take a couple of seconds. We'll just give it a couple of seconds. So it has deleted a pod. So if I do get pods now, I will still get 3 pods from the my deployment kind of thing, but none of them would be this particular pod that we deleted, like 4DZZ4. You can see that particular pod is deleted. Since that is the feature of deployments that we keep on, it will, once we specify, let's say I want 3 replicas at all time, no matter if it gets deleted or it stops responding or whatever, Kubernetes has this capability where it respawns the pods constantly. So that is the advantage of using deployments. That is why people prefer using deployments. So if your pod fails for some reason, Kubernetes automatically restarts a new pod for you. So that is that. So this is the kubectl delete command. Let's move on to the next one. So the next one is autoscale. So you can give a command to autoscale. So you can autoscale your deployments, and basically it creates an autoscaler that automatically chooses and sets the number of pods that run in Kubernetes cluster and looks up deployment, replica sets, stateful sets, as well as replication controller. So all of these four you can autoscale. and it basically gets them by the name and creates an autoscaler that is given with for the resource as a reference. So let's say if I say I want to autoscale deployment and then deployment's name, and I will define how many minimum or maximum pods I need. So this is basically done because let's say if you are Grofers or if you are Flipkart or Amazon, you don't get the same number of people trying to access your website every single day, right? It will not happen that every day you will get the same amount of traffic, but sometimes, let's say during a sale period or during some festival season, you will get a lot of traffic coming to your particular website. So how do you know that when it's going to hit, and how do you auto scale? So you can basically tell Kubernetes that whenever, let's say, there is huge amount of traffic coming. So let's say if there is something you can define. So if let's say my pod can handle 3 requests at the moment, and for example during a sales season that 3 becomes 6, my Kubernetes autoscale command will basically enable my pods. So let's say I have only 3 replicas, it can automatically scale up to 5, 6, 7, 8 just to serve the requests. It can basically do that. So it has that capability as well of auto scaling. So you can do that with the help of Kubernetes as well. Let's move on to the next command, which is scale. So I'm moving on to the next command because I cannot show you auto scale right now. I can show you scale. I can show you how you can improve the replicas. And basically what you have to do is you can scale for a new size of a deployment, replica set, replication controller, or stateful set. Works for all of these 3, and basically allows you to specify one or more preconditions to scale also. So whatever you need, you can replicate that as well. And basically if you wanted to manually increase the number of replicas that you have, then you use the command scale. So very simple command. So the syntax for it is kubectl scale, and the resource hyphen resource version equals to version, and then current replicas count, and then the replicas count and file name and type. So let's try this out. Let's see how this works. So I'm going to be opening my terminal again. So I have a deployment which is running, which is my dep. So kubectl scale hyphen replicas equal to 4, and then it says to write the file name and or the type, right? File name or the type name. So replicas equals to 4, and then we are going for my deployment, which is of the name my dep. Let's see. As you can see, it says the deployments was scaled. So I had 3 pods running before. Let's see what happens now. kubectl get pods. Sorry. As you can see, 1, 2, 3, 4. It has scaled my number of replicas just by a ping of a command. And you can do the same thing with the help of autoscale, where you can define the number of replica sets that you want. You can in here you can define minimum to maximum 10. So at all times it will be minimum of 2, but based on the service request, it can be scaled up to the maximum of 10 to serve all the service requests. So that is the use of the scale command. Okay, let's move on to the next one, which is called describe. So as the name suggests, it's prints out a detailed description of the selected resources, including the related resources, events, controllers, and whatnot, right? So if you are going to get the detailed information for, let's say, one particular resource, then you use the command describe. The syntax is pretty simple and pretty straightforward. So you type kubectl describe, and then you write the type of the thing that you want to describe. So let's say if it's a pod, so kubectl describe pod, and then pod's name. So whatever pod you want to describe, you mention the name, right? And if it's a service, then you write kubectl describe service, and then the service name, kubectl describe deployment, and then the deployment's name. So whatever it is, then you go ahead with that, right? Let's quickly dive in and see how that works. So we have, I'll clear the screen so that, because the describe will give you a lot of information, that's why. So kubectl get pods, that is just to get the pod's name. So that's that. Kubectl describe pods, and then pod name, right? It returns the entire information with respect to the pod. So everything for this pod has been here: the name, the namespace that it is in, the priority it has, the node where it is residing, the start time, the labels it has, the annotations, the IP, the controllers, the ID, container ID, image ID, and what ports it is on, if it is being pulled, restart counts, when was it, type of the conditions like initialization is true, container is ready, true, pod schedules true, and normal everything, all of the events that has happened with respect to this pod, and everything, the volume mounts and everything about this pod, you can find in here. That is what describe is used for. So when you want detailed information of a particular resource, you go for describe. That is the basic idea behind that. Let's hit clear and move on to the next command. So next command is logs. So basically logs, as you can suggest, it prints the log of a specific pod or a resource. And if the pod only has one container, then the container name is optional. So when you can have pods with multiple containers also. So if they are multiple containers, then you would have to specify the container name as well. But if you have only one container, then it's
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
fine, right? It's optional then. Then if you wanted to get, so the syntax for it is kubectl logs, then -f, -t, depending on whatever that you are using, the pod and or the type name, and the container name that you want. So if you want to get all of the containers in a pod by the label app equals to nginx, then what you do is kubectl logs, then -l for the label, and then the app equals to nginx all control containers equals to true. So what we'll do is we'll try to get logs of one of our containers, and let's see how that looks like. So it's kubectl. Let's get pods first, so that we can copy the pod name. Yep. So kubectl logs -f pod, because I think we can give the type name. Yeah. So we can give a pod or type name pod, and then the pod name, which is, let's say, this one. And since I think it has only one container, so I don't think I need to give the container flag, so it should work. Maybe we don't need to specify pods in here. So you can see the logs with respect to this has been printed. So you don't need to give the name, you just need to give the name of the resource and it will work. So that was the logs for this particular thing, right? So don't need to give that, and you can directly go ahead with that. We could have given some label, but we just went with the resource name, right? So that is that. Let's move on to the next command, which is exec. Now exec is something which is used to execute a command. Even you can use exec to get inside of the containers as well. So you can get inside the containers, you can change different resources in there. So you can use exec command for that. So basically any commands that you want to address, you use the command exec. And the syntax is very simple: kubectl exec, and then the pod or the type name, and then you have different flags which you can put in. For example, kubectl exec my pod, and -date, it will give you the running date of the pod. Let's quickly try that. Yes. Kubectl get pods, kubectl exec, then your pod's name, and then whatever the command that you want, right? It's not clear. I just wanted to move this here so that you can see the command, and the way I'm typing is the same. Exec, and then any pod name. So go with this pod, go with this pod, -. You can see Wednesday, deck 9, everything with respect to that has been delivered.
So guys, continuous monitoring is basically the process of continuously keeping a track of all the servers and the applications which are hosted on that servers and creating a log out of it, right? Now, how does it help? Basically, it helps in cases when your application transitions from an active to a critical state, right? And sometimes what happens is you're not on the application all the time checking whether your application is up or down. So your work is basically done by a tool which continuously checks whether the application is up or down, right? If there are any performance issues, is there any non-responsiveness, is there any downtime, all of this is managed or is basically monitored by the continuous monitoring tool, right? Now, the moment application transitions from an okay to a critical state or a non-responsive state, there are a set of rules that you defined, right? For example, if it's unresponsive, probably a mail or a notification is triggered to the administrators, and basically what will the administrators, they'll properly restart the service or they'll restart the application, right? If there is a bug that is encountered, so for example, if the program goes into a infinite loop and the memory goes haywire, or the memory basically gets full under seconds. In that case also it becomes a critical case, right? So earlier we saw that it was probably a non-responsive case, but in this case it becomes a critical case because even the other applications on the same server becomes affected because now the memory of the whole server, it became full. So in that case the mail would go to the developers and also the administrators. Developers, why? Because now they have to identify where exactly the problem is, right? So probably the problem is within the code that they've written for the application, so they'll fix it. And the notification also goes to the administrators because once they are done with the code, the administrators basically have to take that code and upload on the servers again, right? So guys, this is what a continuous monitoring tool is. Now, why is a continuous monitoring tool important? Let's discuss that, right? So let's discuss these points one by one. So your continuous monitoring tool detects any network or server problems. Like I said, it continuously monitors all your services, all your applications, all your servers which are running and hosting your application, right? And it tracks for any kind of change, right? It generates a stream of log, and in that stream of log, the moment there is a change, the continuous monitoring tool automatically creates a notification or an email and send it to the specified contacts in the rule, right? So what kind of changes? It will look at any network or server problems. It will basically see all the security issues as well, right? For example, if someone is planning a DOS attack on you and they try to do that, they initiate attack. So your continuous monitoring tool, if you set up it with the correct configuration, it would be able to identify if a DOS attack is happening on your website, right? And continuous monitoring tool does not only help you to identify what just happened to your set of systems, right, or your server, it also helps you to identify what exactly caused that problem, which is very helpful because now the developer knows exactly what has to be done, what has to be fixed. Rather than just saying that the application is down, your continuous monitoring tool will also tell you the details of the event which occurred, which is a great thing because that would help us narrow down on the problem or the segment which basically caused a problem in the whole program, right? The next thing is it also monitors and troubleshoots server performance issues, right? For example, your hardware on which your application is running, your continuous monitoring tool also keeps a track of how the server health is, right? How fast is it to all the requests which are made, right? And how are the response times, how are the performance basically of that server. So all of that is logged, and at times when the performance goes below a certain level, for example, what happens is, guys, the computers never get slow. It's just that the applications or the softwares which run on those computers, they become advanced, right? For example, if you have Windows 10 and you updated your Windows 10 one day, you probably get some new features added to it, but with those new features, that particular operating system is now going to take up more processing power or more resources from the memory, etc., right? And this can cause a problem when you have servers which run 24/7.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
And have applications which get upgraded timely, right? In that case, you might have to change your server or system, or you might have to upgrade your hardware. So basically, your continuous monitoring tool can also help you in identifying when your system health goes into a critical state, so that you know that when you want to change that particular system, right? So guys, these were pretty much all the reasons that why continuous monitoring tool is so important, right? Why companies are preferring the last stage of their DevOps to be a continuous feedback cycle wherein they have put the continuous monitoring tools, right? So these were the reasons. Now moving forward, let's discuss continuous monitoring quickly using a DevOps life cycle. So we have discussed this diagram before, but let us just summarize what we just learned, right? So that we can picture it better while we are basically implementing our DevOps life cycle. So a developer does a commit on the version control system. The version control system basically picks up the code and deploys it on the testing server, right? The testing server does its test. If the test fails, the feedback goes back to the developer. in case the feedback doesn't fail, in that case, the code is again pushed by the CI server to the production server. And now from here, the continuous monitoring starts, right? So your continuous monitoring tool is basically going to check the server on which the website has been or the application has been hosted for any performance issues, right? It will check for network errors, etc., etc. So it will be on a vigilante mode in that case, right? And check for any faults in that particular application or the hardware on which it has been hosted, right? And the stream of logs that I was taking, so even if your systems are okay, the logs are continuously generated, right? And if there is any change in the log, a notification is basically passed on to the developer team, right? Now, based on the severity of the severity of the event which has happened, it could be a critical event, it could be a non-responsive event, it could be a minor event as well. So based on the events, we define rules. So if it's a critical event, we'll probably want to employ our solutions architect guy of our company as well. If it's a minor issue, probably only one or two administrators would be able to solve it. Either two administrators or one administrator and a developer, so that if that minor issue is being caused by some code which has been recently uploaded, only the developer can fix it, right? So all of this is followed, and keeping in mind all your organization needs, you create this life cycle, and continuous monitoring becomes an integral part of it, because without it, you will not be able to identify how well your DevOps life cycle is actually performing. Alright guys, so we saw that Nagios is one of the most popular continuous, or is one of the most, like, we looked at top 3 continuous monitoring tools and we saw that Nagios was one of them, right? And today in this module, we are going to discuss in detail about what Nagios is and how it works. So guys, Nagios is nothing but an open source software which helps us in continuously monitoring applications which are running on remote hosts, right? For this, Nagios follows a master-slave architecture. There is one server on which Nagios is installed, and the others are basically just normal systems on which applications are running, right? So in order for this Nagios server to interact with the services which are running on some other server, you have to install some plugins on those servers, on those hosts which wants to get monitored, and these plugins are chosen based on the platform that they're running. For example, are they running a Windows platform, or are they running a Linux platform, right? Now, what all can you monitor with Nagios? So as you can see over here, you can create monitoring service for literally any kind of things. You can monitor printers, you can monitor applications, you can monitor switches, network switches, right? And you can monitor hosts, right? You can monitor literally anything in Nagios which is in the computer realm and is running on a remote host. What are the components of Nagios, right? So there are basically three main components of what make Nagios the most effective continuous monitoring tool. So the first component is the Nagios GUI, then you have the scheduler, and then you have plugins in Nagios. So let's understand this one by one, right? So let's first talk about the Nagios GUI, guys. So inside, basically the GUI is the web interface that Nagios offers you, and that is basically a dashboard for you on which you can monitor all the services which are running on different servers that you have attached to your Nagios server, right? And also you can have a look at all the hosts which are connected to your Nagios server, right? So along with checking them, you can also have a look at their status. You can also have a look at the logs. All of that is possible inside the Nagios GUI. So basically Nagios GUI acts as a front end for you, right? The second component is the scheduler, right? Now scheduler itself is again a very main centric component of Nagios, which basically does all the work of scheduling, right? So what has to be monitored and when exactly it has to be monitored. For example, you are basically monitoring the ping service of a server, right? Now, when do you have to manage it, right? So at what intervals you'll have to go ahead and check whether that ping service is working or not, and what exactly do you have to manage, right? If, for example, ping you have to manage, what all other services you have to manage, and what all servers you have to manage it on or monitor it on, right? So that all of this job is done by the scheduler, right? And then you have plugins. So basically, when you talk about monitoring hosts, talk about monitoring different servers. So if you have like 1,000 servers in your company that you have to monitor, it's not that you have to install Nagios on the servers that you have to monitor. For example, like I told you guys, you need a Nagios server. So your Nagios server will basically take care of all the monitoring part, right? And with your Nagios server, you attach your application servers, right? And your application servers are basically going to have some plugins. So you don't have to install Nagios on them, on the application servers. All you have to do is install a plugin on it, right? And those plugins are called NRPE plugins, right? You install it on them, and using the NRPE plugin, what the scheduler does is the scheduler basically sends a request to the NRPE plugin along with the command using which it has to monitor that particular host, and the NRPE plugin basically helps the scheduler to get all the log related to that particular service which was requested. And once the logs have been received by the scheduler, they get forwarded to the GUI part of Nagios, and then that Nagios GUI then represents the log in terms of their status, in terms of graphs, in terms of many other useful visualization techniques through which you get to know how your host is performing in terms of its hardware, in terms of the application which is running on it, and etc. Right? So this is how basically the Nagios architecture works, guys. So Nagios follows a master-slave architecture. All your hosts are on separate machines, right? And your Nagios has a dedicated server for it. You can also have applications installed on the same system as the Nagios is installed on, right? And Nagios has the capability of monitoring its own services as well. But usually when you talk about it in production environment, or you talk about how companies use it when they're dealing with monitoring application, it always happens on a scale that you have a Nagios server, and beneath the server you have a lot of hosts which are basically hosting your application, getting monitored by Nagios scheduler. So let me quickly jump on to my browser so that you guys can see that we have two hosts right now, localhost and slave one. This we already did in the last session where I showed you guys how you can add a host to the Nagios server, right? Which the host which is being monitored. So right now the status of this host is that it is up and running, right? Now what I want to do is I want to create a monitoring service which for an application which will be running on this slave. So what I'm going to do, if I go to services right now, I can see there are no services which are monitoring any application which is running on the remote host, right? So what I'll do is I'll first install a service called sudo apt get install Apache 2. I want to install an Apache service which I can monitor in Nagios for this particular server. Okay, so Apache is getting installed. Yes, so Apache is installed now. Now if I go to the browser, I should be able to see for the Nagios slave an Apache service, right? So Apache page is working. Now what I'll do, I'll go to my server, right? Let me just clear the screen. And now I will go to templates, or let's go to templates, or let us go to localhost configuration first, right? Now in this localhost configuration, you will find a service for, right? So I want this service to be copied. I'll just copy this service, right? And what I'll do, I'll make changes to this particular service and I'll make it a service for monitoring the HTTP connections. So what I'll do now, I'll just go to the configuration file of my host 1, right? And I'll paste the service over here. And let's make changes to the service now, right? So this is the service. Now we want to use a template for the service. Let's say it's not a local service. I'll say it's a generic service. So there's a template for generic service inside templates.cfg. You can have a look at that. The host name for this service would be the same as the host name for your host. The host name for my host is slave 1, right? So I'll write exactly slave 1 in my service as well. So I'll do that. I'll call it slave 1. Service description, what do I want this description for this service to be? Check Apache. Okay, and the command for this particular service would be check underscore HTTP, right? So this is the official command for checking the if anything is running on port 80 of any computer, right? So you can have a look. If you want to try some other application that you want to monitor, you can just Google out the service or the command that you would use over here to monitor that particular application. right? And most of the times you will get a command. In case you don't get a command, just Google how you can define a command for basically monitoring the application that you want. Right now, all you have to do is, if you find the right place where you just have to create a command, go inside commands.cfg, right? That is there in your etc directory. And inside the commands.cfg file, all you do is create that command, and which I'll show you in a moment, the way to create a command. And then you can use that command over here as well. So check_HTTP is already a command which is existing in my Nagios server, and I'll show you the definition of this particular command when we go in commands.cfg. For now, the service is ready. So what I'll do, I'll just save the service, right? And now I'll just restart the server. So for restarting, this is the command. I'll pass this command. So my Nagios server is now restarted. Now if I go inside hosts, I can see slave 1 is up. Now if I go inside services, I can see that slave 1 now has a service which is in the pending state, right? So what will happen, it will basically take like 2 minutes for this to refresh and to check whether a service is actually running on port 80 of slave 1. Okay, so let's give it that time and then check after some time. Alright guys, so as you can see, the service that we defined is now under the status of OK, right? So now my service is running fine, and you can check the status over here that HTTP is OK, and 11,192 bytes were responded back to the request in 0.002 seconds. So you can get all the performance details here. You can see that the service is up and running since the past 5 minutes. So I think it took around a good 2.5 minutes for the service to turn green, because Nagios took that time to basically analyze if the service is healthy or not. Alright. Now similarly, if I disable the service, you will be able to see that in another 2 minutes, this server will go into critical state. Right. So let us do that. I'll just go to my terminal and I'll say sudo service apache 2 stop. Right, I just did that, and now if I go to the IP address, I can see that the page is no longer coming. Now it is 5 minutes 39 seconds right now, so let's see 6 minutes 45 seconds right now. Let's see when our service gets into a critical state. Alright guys, so as you can see, the status has now changed, and it says that the status has changed since the past 18 seconds, right? So it took a good 4 minutes for this service to go into critical state. I guess that's how long Nagios checks in intervals as to whether a service is working or not, right? So as you can see, it says connection refused, reason being now Apache is not running on that particular system. Alright guys, so this is how you create a service in Nagios, and similarly you can create any kind of service for your particular application that you want to monitor. Right, all you have to do is either check if you have an internal command which is going to match for your application, or you'd have to create a command for yourself using some plugins, right? So all of that can be checked online when you're working, because there could be zillion applications that you would be working with. Having a look at all the applications is difficult, because with everyone they'll have different kind of needs for the kind of applications that they are monitoring. Okay. Alright, so I forgot about one thing. Let us also have a look at how you can create a command in Nagios, right? So let me jump back to my terminal. So all I have to do now is I'll have to go inside commands.cfg, right? So let's go inside it. So we use the command check_HTTP, right? So let's first that command first. So if you go inside commands.cfg, you will have all these commands over here. Notify host by email, then you have check host alive, then you have check local disk, check local load, then you have check local procs, check local user, check local swap, check local MRT, check FTP, right? So all these commands are then being mapped to their command line usage. So if you pass this command, this command is basically being passed on your Nagios host if you are using the command check FTP. Okay, then you have check HPJD, check SNMP, check DSP. What I'm gonna do is I'll just go click on where is, and I'll search for HTTP. Okay, so here I get it. So on this command, you can check that if you want to define this command, the command name is check_HTTP. The command line for this is $user1 and then check http-i host address $argument1, right? So this is the command which you are using when basically you are just calling check underscore http while defining a service. So basically what you're doing is in your service, you're basically calling the check underscore http command, which in turn is calling this particular command, which is being passed on to the command line, through which you are able to check whether HTTP is working or not, right? So let's define a command for ourselves. Let us call this as command name would be command underscore name. Let's call it test underscore http. Okay, and the command line for this, the command line command for this would be this. Let's paste it, right? And let me just align it. All right, so this is done, and now basically all we have to do is close the brackets, save the file, right? So the file is saved, and now let's go inside sudo nano host 1.cfg. Okay, and now I would want to create a service, right? Let's name this service as, we'll use everything which is the same here except the command. So we'll just go down to the earlier service that we created. We'll just copy everything, paste it here. So we have to paste this commands here, and then we'll close the brackets. The check command will now change to test underscore http. The check Apache, let's change the text to check Apache test, right? And everything else will be the same. Okay, now let me show you one more thing. So you can also control the interval in which Nagios is basically checking your command. So what you can do is, let me just save the file here. We'll go to templates.cfg, right? So let's go inside. So we're using the generic service template, right? So let us go inside sudo nano templates.cfg.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now let's try to search for generic service, right? So here it is. So the generic service is defined like this, that you have check freshness is 0, notifications enabled is 1, event handler enabled 1, flap process performance data, and you can check over here that in check interval, it's 10 minutes, right? And the retry interval is 2 minutes. So if the service is functioning normally, in that case, it should check for the freshness of the service, or check whether the service is again working or not in 10 minutes from the time that the service goes down. So let us change this to 1, or what you can do is you can also change this when you're calling this service. So let's change it over there. So basically you have to remember that this keyword, which is check underscore interval and retry underscore interval. Okay, so let's go out. We're not going to change anything here. What I'm going to do is I'll go to sudo nano host 1 underscore cfg, and now in the service I'll specify retry underscore interval, and I'll give that number to be, say, 1 minute, right? Similarly, what I'll do, I'll say check underscore interval, and I'll again specify it to be 1 minute. So every 1 minute, even if the service is up and running, it will check if the service is running now. If not, it will retry again to check the service whether it's up again or not in the another 1 minute. So with this, you should get a faster response onto when your service will become okay on your Nagios dashboard. All right, so we have specified this. So we have changed the services. So let's save the file now. So I'll save the file like this, and now I'll restart Nagios. So let's search for that command. Here it is. I've restarted Nagios, and now if we go inside the browser, here's my browser. What I'll do is I'll do a refresh. I'll go to services, and now I can see there are 2 services which are running. So because we stopped the Apache service on our server, that's why It is saying it's in a critical state right now. So what I'm going to do, let me go here and okay, so we'll start Apache server, but first let's wait for this pending state to become to critical. So what I'll do, I'll just click refresh once again. I'll go to services and let's wait for this service to become critical. In that case, what I'm going to do, we're going to see that in how much time it becomes okay from the time when we basically up the service. All right, so let's wait for this to become critical. All right, so as you can see, the service is now critical, and what we can do now is we'll go to this system and we'll start the service now. So I'll start the service like this, right? So this service of mine, which is check Apache, is basically working at 10 minutes interval and 2 minutes retry time. On the other hand, this service, which is check Apache test service, is retrying at every 1 minute and checking the service also at every 1 minute. So let's see if there's a difference that we see over here. So we'll just refresh it and see which service becomes up and running again. Alright, so you can see that my check Apache test is already in the OK state now, right? So it became OK faster than the check Apache service. If I again refresh the service, I can see that my check Apache service is still in the critical state. Reason being, the check interval in that case I did not configure, and it took the default values of my generic service template, which had 10 minutes of check interval and 2 minutes of retry. Right? So basically, if this state is in the retry state right now, it should take around 2 minutes for this to become okay, right? On the other hand, my Apache service, because my check intervals is just 1 minute and even my retry interval is 1 minute, it became okay faster because Nagios is now checking the service pretty early than the way it is checking it with this particular service. So if I again click on these services, I can still see that this is in a critical state and check Apache state is in a OK state. All right, so this was it for this session, guys. So our first question asks us, can we explain the Git architecture? Now this is fairly an important question, reason being, only if you understand the underlying basics of how Git works will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right, and this is how the whole Git architecture works. Now I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code, you committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments, and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website, and basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically, there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on this same hardware by virtualizing the hardware, so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond, or which is which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which is on top of your, which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you have virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with the given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a Docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So I'll do an SSH into the same server again so that I'm on dollar. Okay, great. So if I do a PS AUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the dollar prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var/www/html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it -p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it's stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Docker file. And what I want to say is in the image shhar/webapp, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor, and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon, and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, you know, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able to, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker, Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system, you'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. With Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took an example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right, so I'll enter my credentials. And this is how the dashboard for Jenkins looked like. Now our question is, or our aim is, to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment my anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a dollar. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container which is going to have my website. All right, now how can we do that? For that I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Docker file, and it will basically build it and name it as, say, Jenkins Jenkins, it'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do these this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we're building this Docker file and we're naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay, and I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was...
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
'82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the three top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. but once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, if when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, between on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay. So let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay. Now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/ansible and /hosts. Okay. So as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the three dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically, I want to use the apt package to install Apache 2, the latest software. Okay. Now, what I will do, I will type in Ansible -playbook, and I'll type in Apache .yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows, or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below.
So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session. Thanks for watching.